Evaluation of variable declaration list. Return. Evaluation of variable
So I don't know.
binding identifier 1. Return empty. Variable declaration. Binding
Continuation from last stream.
view of binding identifier.
I don't know. I'm like making JavaScript Engine
If is anonymous function.
and yada yada.
Let value be. Named evaluation of initializer.
But I need to like make a shader program.
Evaluation of initializer. Be let value be. Get value.
So that's what I'm doing here.
Put value. LHS.
And I need to like,
Empty. Variable declaration. Binding
I
pattern.
don't know, I want to try something really quick.
Evaluation.
I want to try to like remap the memory
HS. Return.
to avoid an extra copy that's being done.
Arguments relevant undefined. 4, 3, 3.
Because it gets a desktop image and it puts it to like a memory location.
And yield away.
But then that memory location is copied again to map it to the video card area that's mapped to be sent to video card, to GPU.
Object environment record. Then
So I want to like try to like
environment binding of the
get rid of that double copy.
International 2000.
And then there's an offset that can be passed in to the vmap memory call.
Binding property.
And if it's the same address space as my address space, or like it's a flat address space anyways,
Element yield away.
I should be able to add an offset,
Element list.
whatever the address is
Rest property. Yield.
that's mapped for memory,
Identifier yield await.
to get it to align to like
Binding property yield await. Binding property list yield await. Binding property yield await.
the X image struct or whatever,
Binding elision.
because that's like managed memory too.
Yield await.
But if this offset is 64-bit offset,
Await. Elision ought. Binding
it should be possible
property. Yield.
to add however many bytes needed,
Property name yield await.
or negate to subtract,
Yield await. Single name.
to align the data
Initializer.
to that location.
Single name binding. Yield await. Binding identifier.
If I do that, I can avoid a whole entire extra copy.
Yield await. Dart. Bind.
So I'm gonna try that really quick.
Binding pattern.
And then I'm gonna like,
3, 3, 1 runtime semantics. Property binding.
I got a triangle here.
Syntax directed operation. Property binding initialization takes argument
I gotta put in a chatbot the code that does this.
and environment record.
I want chatbot to flip it upside down
Completion contain.
so I can make sure that chatbot is making valid code.
List of all bound property names. It is defined piecewise over the following productions.
And then
Binding property list. Binding property. Let BAM name speed. Property binding initialization of binding property list with arguments value and environment. Let next name speed. Property binding initialization of binding property with arguments value and environment. Return the list concatenate.
I don't know, like
2024 297. Binding property. Single name.
right now it's capturing the desktop,
Single name binding.
but it's overriding
Initialization of single name binding with
what's set to like the command buffer, whatever.
binding property. Pro. Party name. Binding element. Let PB. Evaluation of property name. Perform.
So it's just like 2D pixel blitzing.
Arguments value. Environment. And P. Return P. 4, 3.
So you get the triangle, or I can get
Initialization.
the desktop copied over an output.
Initialization.
This is like a 2D plane.
CMA script language value. Environment and environment record or undefined.
So it's working whatever. I'm getting the desktop for the shader program.
Binding on new store and abrupt.
I gotta like, I don't know, it's the whole thing. I gotta get something done.
Binding rest property. Binding identifier. Let LHS be.
So I gotta like
Binding identifier.
get this
Maybe ordinary object.
memory, avoid the extra copy if possible. If it's not possible, I give up for now. It's not worth optimizing.
Included names. If it
But if I can do it really quick, whatever, I'll try to like get rid of the extra copy,
initialize reference binding. LH.
because the CPU does a copy, so it makes the CPU take twice as long to get done doing this.
Syntax direct.
I have to do 2 copies.
Initialization takes arguments value. Any CMA script language value. Environment and environment record or undefined. And property name. A property key. And
But basically,
containing on new store and abrupt completion. It is defined piecewise over the following productions. Binding element. Binding.
yeah, I don't know, that covers it.
E. Jet. Value.
So I'm gonna try to like figure this out really quick.
V is undefined. Then a let default value be.
And I'm gonna like do the whole shader thing, try to get the program done.
Binding initialization of
And yeah.
indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 98. ECMA International 2024. I2. Let default value be. Evaluation of initializer. 72. Get value. Default value. 5. If environment is undefined, return. Put value. LHS. V. Return. Initialize reference binding, LHS, v 4.4 empty statement syntax, empty statement, 4, 1 runtime semantics, evaluation, empty statement, 1. Return empty, 4.5 expression statement syntax, expression statement, yield, await, look ahead, function, async, no line terminator here, function, class, let, expression, class and yield await, not, an expression statement cannot start with a u plus 007b, left curly bracket, because that might make it ambiguous with a block. An expression statement cannot start with the function or class keywords because that would make it ambiguous with a function declaration, a generator declaration, or a class declaration. An expression statement cannot start with a sync function because that would make it ambiguous with an async function declaration or a sync generator declaration. An expression statement cannot start with the two-token sequence let, because that would make it ambiguous with a let lexical declaration whose first lexical binding was an array binding pattern. 4, 5, 1 runtime semantics, evaluation, expression statement, expression, let x per f be. Evaluation of expression, return, get value, x per f, 4.6 if statement syntax, if statement, yield, await, return, if, expression, class and yield await, statement yield await return, else, statement yield await return, if, expression, class and yield await, statement yield await return, look ahead else, the look ahead restriction, look ahead else, resolves the classic dangling else problem in the note, usual way. That is, when the choice of associated if is otherwise ambiguous, the else is associated with the nearest, innermost, of the candidate ifs. ECMA International 2024 299, 1 4, 6, 1 static semantics, early errors, if statement, if, expression statement else statement, it is a syntax error if is labeled function, the first statement is true, it is a syntax error if is labeled function, the second statement is true, if statement, if, expression statement, it is a syntax error if is labeled function, statement, is true, note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. 4, 6, 2 runtime semantics, evaluation, if statement, if, expression statement else statement, let x per f be. Evaluation of expression, let x per value be to boolean. Get value, x per f. If x per value is true, then a let stmt completion be completion. Evaluation of the first statement 4. Else, a let stmt completion be completion. Evaluation of the second statement 5. Return. Update empty, stmt completion, undefined. If statement, if, expression statement, let x per f be. Evaluation of expression, let x per value be to boolean. Get value, x per f. If x per value is false, then a return undefined 4, else.
Okay, I just realized the flaw in my logic.
Return. Update empty.
This is a call to map memory, so you don't know the offset yet.
Iteration statement.
You don't know the address yet, so you can't compute the offset beforehand because it's not known yet.
For enough statement yield await
I'll
return.
ask Shep anyways, maybe he'll tell me what this offset's used for. I don't know, whatever. That would have been clever. So it says, you're thinking the right direction. Point arithmetic. What's the same wrong? Because I'm wrong. It's 64-bit. Okay. So it would work, but it specifies a byte offset from the beginning of VK memory. Oh, okay. What if a negative address is passed in? Okay, what if wait, what? It specifies a byte offset from the beginning. But you don't know the address yet, so would you specify the offset? So message chatbot. In VK memory, maps memory. What is being mapped? The address is not known yet? Or is the address stored in one of the other args? It says it does not give you the raw address itself. But it does, because you're assigning the address with a memcopy. Why does it lie? It's freaking pissing me off. I want to figure out something really simple. It's just not answering exactly what I'm fucking asking. It says byte offset. This is the start. This is a byte offset from the start of VK device memory. Here. So is it already mapped? What even is that? Staging buffer memory. This is so stupid. It says you not see the address. I'm gonna say okay. So like void pointer does not hold the address. It says literally what void pointer data is assigned. The mother freaking address. Jeppa said it's opaque, whatever the fuck. You don't know what it is, you can't access it 'cause it's on the GPU. How the fuck do you memcopy to an address on the GPU if it's not on the CPU? You can't. It's because it memory maps it at this point and then it's accessible, otherwise it's not. I think. Unless it passes back a different address. It doesn't matter though, because whatever the address it is, it's clearly visible because you can print it. And it's still like the local address space, not the GPU. So you don't see GPU address, but you do see the address space in your address. So I'm asking it, whatever. I'm not asking the right thing. So data is user space CPU pointer. Points to mapped view of CPU memory. So you can see it blah blah blah, that's the point. It's water. So clearly it's not GPU addressable. Okay, so what is VK device memory? I think I just checked. Staging buffer memory. I just want to answer this point. Oh, it's within the device allocation, not the actual CPU pointer. Oh, that way you could like write to just a portion of memory. Like just a chunk of the memory and not the whole thing. So that's why. Why does it do this? It says X image here. It's like it gives entirely incorrect data, but pretends it's correct. And it says you typed it in wrong. It says you made a mistake when it gave you the information. It's so annoying as fuck. It didn't even copy. So here's X create image. Oh, it's a different function. It might work then. This is X SHM create image. This one's just X create image. This might actually be helpful then. I won't ask the difference. I want to like adjust this. So could it do that? Oh, this might just work. I'll just assume whatever. Oh, dang it. I'll try this later. I think I have to like rewrite stuff then. What are the props of the struct? This returns. Oh, come on. Oh, it has with height. I think those are the only two I'm using. Along with data. Maybe it'll work.
optional expression optional chain. Let base reference be. Evaluation of optional expression. Let base value be. Get value, base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation.
Oh, there's a whole bunch of extra steps now.
3.
I get some water.
Semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, any CNA script language value, and base reference, any CNA script language value or a reference record, and returns either a normal completion containing either an eCNA script language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict optional chain. Identify a name. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value. Identify a name. Strict optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Optional chain. Optional chain arguments. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. New value. New reference. Arguments. Tail call. Optional chain. Optional chain. Expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R new value expression strict optional chain identify a name. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value new reference. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N new value. Identify a name. Strict 66 ECMA International 2024 optional chain private identifier. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let field name string be the string value of private identifier. Return make private reference. New value. Field name string. The 3rd of March 2010 import calls. 3.3.1.0. 1 runtime semantics. Evaluation. Import call. Import. Assignment expression. Let referrer be get active script or module. If referrer is null, set referrer to the current realm record. Let argraph be. Evaluation of assignment expression. Let specify be. Get value. Argraph. Let promise capability be. New promise capability. Promise %. Let specify a string be completion. To string. Specifier. If abrupt reject promise. Specify a string. Promise capability. Perform host load imported module. Referrer. Specify a string. Empty. Promise capability. Return promise capability. 3.3.1.0.1. 1 continue dynamic import. Promise capability. Module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then perform call promise capability undefined module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. Perform call, promise capability, undefined, reason B return unused, let onRejected be create built-in function, rejected closure, 1, let link and evaluate closure be a new abstract closure with no parameters that captures module, promise capability, and onRejected and performs the following steps when called, a let link be completion, module link, B if link is an abrupt completion, then I perform, call, promise capability, undefined, link, 2, return unused, C let evaluate promise be module evaluate, D let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called, I let namespace be get module namespace, module 2, perform, call, promise capability, undefined, namespace 3, return unused, E let unfulfilled be create built-in function, fulfilled closure, 0, F perform promise then, evaluate promise, unfulfilled, onRejected, G return unused, link and evaluate be create built-in function, link and evaluate closure, 0, let perform promise then, load promise, link and evaluate, onRejected, return unused, ECMA International 2024 267, the 13th of March 2011 tag templates, 1 runtime semantics, evaluation, member expression template literal, let tag ref be, evaluation of member expression, let tag func be, get value, tag ref, let this call be this member expression, let tail call be as in tail position, this call, return, evaluate call, tag func, tag ref, template literal, tail call expression template literal, let tag ref be, evaluation of call expression, let tag func be, get value, tag ref, let this call be this call expression, let tail call be as in tail position, this call, return, evaluate call, tag func, tag ref, template literal, tail call, the 3rd of March 2012 meta properties, 1 runtime semantics, evaluation, new target 1, return get new target, import meter, import meta, let module be get active script or module, assert, module is a source text module record, let import meter be module, if import meter is empty, then A set import meter to ordinary object create, null, B let import meter values be host get import meter properties, module, C for each record, P of import meter values, do, I perform, create data property or throw, import meter, P, D perform host finalize import meter, module, E set module to import meter, F return import meter, else, assert, import meter is an object, B return import meter, 1 host get import meter properties, module record, the host defined abstract operation host get import meter properties takes argument module record, and returns a list of records with fields, any CMA script language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note to tag template is a function call where the arguments of the call are derived from a template literal 1 3 2 8. The actual arguments include a template object 1 3 2 8 4, and the values produced by evaluating the expressions embedded within the template literal 68. Copyright sign ECMA International 2024 133 121 to host finalize import meter, module record. The host defined abstract operation host finalize import meter takes arguments import meter, an object, and module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to CMA script code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression yield await. Left-hand side expression yield await. Left-hand side expression yield await. Left-hand side expression yield await. Plus unary expression yield await. Unary expression yield await. 1 3 4 1 static semantics. Early errors. Update expression. Left-hand side expression plus. No line terminator here. Plus. No line terminator here. Left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression. Unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3 4 2 postfix increment operator 1 3 4 2 1 runtime semantics. Evaluation. Update expression. Left-hand side expression plus. Let LHS be. Evaluation of left-hand side expression. Let old value be. Denumeric. Get value, LHS, if old value is a number, then a let new value be number, add, old value, 1, else, assert, old value is a bigint, be let new value be bigint, add, old value, 1z, perform, put value, LHS, new value, return old value, ECMA International 2024 269, 1 3 4 3 postfix decrement operator 1 3 4 3 1 runtime semantics, evaluation, update expression, left-hand side expression, let LHS be, evaluation of left-hand side expression, let old value be, denumeric, get value, LHS, if old value is a number, then a let new value be number, subtract, old value, 1, else, assert, old value is a bigint, be let new value be bigint, subtract, old value, 1z, perform, put value, LHS, new value, return old value, 3 4 4 prefix increment operator 1 3 4 4 1 runtime semantics, evaluation, update expression, plus unary expression, let x be, evaluation of unary expression, let old value be, denumeric, Get value, expr, if old value is a number, then a let new value be number, add, old value, 1, else, assert, old value is a bigint, be let new value be bigint, add, old value, 1z, perform, put value, expr, new value, return new value, 3, 4, 5 prefix decrement operator 1 3, 4, 5, 1 runtime semantics, evaluation, update expression, unary expression, let expr be, evaluation of unary expression, let old value be, denumeric, get value, expr, if old value is a number, then a let new value be number, subtract, old value, 1, else, assert, old value is a bigint, be let new value be bigint, subtract, old value, 1z, perform, put value, expr, new value, return new value, 70, ECMA International 2024, 13.5 unary operators syntax, unary expression, yield, await, update expression yield await, delete unary expression yield await, void unary expression yield await, type of unary expression yield await plus unary expression yield await, unary expression yield await, unary expression yield await, unary expression yield await, plus await expression yield, 3, 5, 1 the delete operator, 3, 5, 1, 1 static semantics, early errors, unary expression, delete you, unary expression, it is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression, identifier reference, member expression, private identifier, call expression, private identifier, optional chain, private identifier, or optional chain, private identifier. It is a syntax error if the derived unary expression is primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, and capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3, 5, 1, to runtime semantics, evaluation, unary expression, delete unary expression, let ref be. Evaluation of unary expression, if ref is not a reference record, return true. If is unresolvable reference, ref is true, then assert, ref is false, be return true. If is property reference, ref is true, then assert, is private reference, ref is false, be if is super reference, ref is true. Throw a reference error exception, c let base obj be. To object, ref, d let delete status be base obj, ref, e if delete status is false and ref is true. Throw a type error exception, f return delete status, else a let base be ref, b assert, base is an environment record, c return base delete binding, ref. The last rule means that expressions such as delete foo produce early errors because, note, of recursive application of the first rule, ECMA International 2024 271. Note 1 when a delete operator occurs within strict mode code, a syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note 2 the object that may be created in step 4c is not accessible outside of the above abstract operation in the ordinary object internal method. An implementation might choose to avoid the actual creation of that object. 3, 5, 2 avoid operator. 3, 5, 2, 1 runtime semantics, evaluation, unary expression, void unary expression, let expr be. Evaluation of unary expression, perform. Get value, expr, return undefined. 3, 5, 3 the tippy off operator. 3, 5, 3, 1 runtime semantics, evaluation, unary expression, type of unary expression, let val be. Evaluation of unary expression, if val is a reference record, then if is unresolvable reference, val is true, return undefined. Set val 2. Get value, val, if val is undefined, return undefined. If val is null, return object. If val is a string, return string. If val is a symbol, return symbol. If val is a boolean, return boolean. If val is a number, return number. 0. If val is a big int, return bigint. 1. Assert, val is an object. 2. Note, the step is replaced in section B. 3, 6, 3, 3. If val has an internal slot, return function. 4. Return object. 3, 5, 4 unary plus operator. Note the unary plus operator converts its operand to number type. Note get value must be called even though its value is not used because it may have observable side effects. 272. ECMA International 2024. 1 3, 5, 4, 1 runtime semantics, evaluation, unary expression, plus unary expression, let expr be. Evaluation of unary expression, return to number. Get value, expr. 3, 5, 5 unary operator. 3, 5, 5, 1 runtime semantics, evaluation, unary expression, let expr be. Evaluation of unary expression, let old value be. Denumeric. Get value, expr. If old value is a number, then a return number, unary minus, old value 4. Else, AB, assert, old value is a bigint, return bigint, unary minus, old value. The unary operator converts its operand to a numeric value and then negates it. Negating plus 0. Note, produces minus 0. And negating minus 0 produces plus 0. Bitwise not operator. Unary expression. Unary expression. 3, 5, 6, 3, 5, 6. 1 runtime semantics. Evaluation. Let x be. Evaluation of unary expression. Let old value be. Numeric. Get value. Expa. If old value is a number, then a return number. Bitwise not. Old value 4. Else. AB. Assert. Old value is a bigint. Return bigint. Bitwise not. Old value. Logical not operator. Unary expression. Unary expression. 3, 5, 7, 3, 5, 7. 1 runtime semantics. Evaluation. Let x be. Evaluation of unary expression. Let old value be to boolean. Get value. Expa. If old value is true, return false. Return true. 3.6 exponentiation operator syntax. Exponentiation expression. Yield. Await. Unary expression yield await. Update expression yield await. Exponentiation expression yield await. ECMA International 2024 273. 136. 1 runtime semantics. Evaluation. Exponentiation expression. Update expression. Exponentiation expression. Return. Capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E update expression exponentiation expression 3.7 multiplicative operators syntax multiplicative expression yield await exponentiation expression yield await multiplicative expression yield await multiplicative operator exponentiation expression yield await multiplicative operator 1 of percent 3 7 1 runtime semantics evaluation multiplicative expression multiplicative operator exponentiation expression let op text be the source text matched by multiplicative operator return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E multiplicative expression op text exponentiation expression 3.8 additive operators syntax additive expression yield await multiplicative expression yield or 8 additive expression yield await plus multiplicative expression yield await additive expression yield await multiplicative expression yield await 3 8 1 the addition operator plus note the addition operator either performs string concatenation or numeric addition 3 8 1 1 runtime semantics evaluation additive expression plus multiplicative expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E additive expression plus multiplicative expression note the operator performs multiplication producing the product of its operands the operator performs division producing the quotient of its operands the percent operator yields the remainder of its operands from an implied division 274 copyright sign ECMA International 2024 138 to the subtraction operator 3 8 2 1 runtime semantics evaluation additive expression multiplicative expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E additive expression multiplicative expression 3.9 bitwise shift operators syntax shift expression yield await additive expression yield await 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 3 9 1 the left shift operator 3 9 1 1 runtime semantics evaluation shift expression additive expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E shift expression additive expression 3 9 to the signed right shift operator 3 9 2 1 runtime semantics evaluation shift expression additive expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E, shift expression, additive expression. 3, 9, 3 the unsigned right shift operator. Note, the operator performs subtraction, producing the difference of its operands. Note performs a bitwise left shift operation on the left operand by the amount specified by the right operand. Note performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. Note performs a zero filling bitwise right shift operation on the left operand by the amount specified by the right operand. ECMA International 2024 275 1393 1 runtime semantics evaluation shift expression additive expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E shift expression additive expression. 3.10 relational operators syntax relational expression in yield await shift expression yield await relational expression in yield 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 await shift expression yield await await shift expression yield await await equals shift expression yield await await equals shift expression yield await question mark await instantia. Note 1 the result of evaluating a relational operator is always of type boolean, reflecting whether the relationship named by the operator holds between its two operands. Shift expression yield await plus in relational expression plus in yield await in shift expression yield await plus in private identifier in shift expression yield await. 3 1 0 1 runtime semantics evaluation relational expression shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref let R B is less than val true if R is undefined return false otherwise return R relational expression shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref let R B is less than val false if R is undefined return false otherwise return R relational expression equals shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref let R B is less than val false if R is either true or undefined return false otherwise return true. 276 ECMA International 2024 note 2 the in grammar parameter is needed to avoid confusing the in operator in a relational expression with the in operator in a for statement. Relational expression equals shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref let R B is less than val true if R is either true or undefined return false otherwise return true. Relational expression instantia of shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref return instantia of operator val relational expression in shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref if val is not an object throw a type error exception return has property revel to property key val relational expression private identifier in shift expression let private identifier be the string value of private identifier letter FB evaluation of shift expression letter val B get value ref if val is not an object throw a type error exception let private TNV be the running execution context's private environment let private name be resolved private identifier private TNV private identifier if private element find val private name is not empty return true return false. 3 1 0 2 instantia of operator v target the abstract operation instantia of operator takes arguments v any CMA script language value and target any CMA script language value and returns either a normal completion containing a boolean or a throw completion. It implements the generic algorithm for determining if v is an instance of target either by consulting target sat at has instance method or, if absent, determining whether the value of target's prototype property is present in v's prototype chain. It performs the following steps when called. If target is not an object, throw a type error exception. Let inst of handler be get method target at has instance. If inst of handler is not undefined, then a return to boolean. Call inst of handler target v if is callable target is false. Throw a type error exception. Return ordinary has instance target v. Note steps 4 and 5 provide compatibility with previous editions of ECMA script that did not use a at has instance method to define the instantia of operator semantics. If an object does not define or inherit at has instance, it uses the default instantia of semantics. ECMA International 2024 277 13.11 Equality operators. Syntax. Equality expression in yield await. Relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. 3 1 1 1 runtime semantics. Evaluation. Equality expression equals relational expression. Letter F B. Evaluation of equality expression. Letter val B. Get value. Ref. Letter F B. Evaluation of relational expression. Letter val B. Get value. Ref. Return. Is loosely equal. Val. Equality expression equals relational expression. Letter F B. Evaluation of equality expression. Letter val B. Get value. Ref. Letter F B. Evaluation of relational expression. Letter val B. Get value. Ref. Letter B. Is loosely equal. Val. If R is true, return false. Otherwise, return true. Equality expression equals relational expression. Letter F B. Evaluation of equality expression. Letter val B. Get value. Ref. Letter F B. Evaluation of relational expression. Letter val B. Get value. Ref. Return is strictly equal. Val. Equality expression equals relational expression. Letter F B. Evaluation of equality expression. Letter val B. Get value. Ref. Letter F B. Evaluation of relational expression. Letter val B. Get value. Ref. Let R be is strictly equal. Val. If R is true, return false. Otherwise, return true. 278. ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1. Given the above definition of equality, string comparison can be forced by $sign equals $sign B. Numeric comparison can be forced by plus equals plus B. Boolean comparison can be forced by equals B. Note 2. The equality operators maintain the following invariants. Up equals B is equivalent to up equals B. Up equals B is equivalent to B equals A, except in the order of evaluation of A and B. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string equals A and A equals new string are both true. New string equals new string is false. Note 4. Comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 3.12 Binary bitwise operators. Syntax. Bitwise and expression in yield await. Equality expression in yield await. Bitwise and expression in yield await. And equality expression in yield await. Bitwise or expression in yield await. Bitwise and expression in yield await. Bitwise or expression in yield await. Bitwise and expression in yield await. Bitwise or 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 expression in yield await. 3 1 2 1 runtime semantics. Evaluation. Bitwise and expression and equality expression. Return. Capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E bitwise and expression and equality expression. ECMA International 2024 279. Bitwise or expression bitwise and expression. Return. Capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E bitwise or expression bitwise and expression bitwise or expression bitwise or expression bitwise or expression. Return. Capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E bitwise or expression 3.13 Binary logical operators. Syntax. Logical and expression in yield await. Bitwise or expression in yield await. Logical and expression in yield await and bitwise or expression in yield await. Logical or expression in yield await. Logical and expression in yield await. Logical or expression in yield await. Logical and expression in yield await. Coalesce expression in yield await. Coalesce expression head in yield await. Bitwise or expression in yield await. Coalesce expression head in yield await. Coalesce expression in yield await. Bitwise or expression in yield await. Short circuit expression in yield await. Logical or expression in yield await. Coalesce expression in yield await. 3, 1, 3, 1 runtime semantics. Evaluation, logical and expression and bitwise or expression. Let B. Evaluation of logical and expression. Let val B. Get value, ref. Let bool be to boolean, val. If a bool is false, return val. Let ref B. Evaluation of bitwise or expression. Return. Get value, ref. Logical or expression, logical and expression. Let ref B. Evaluation of logical or expression. Let val B. Get value, ref. Let bool be to boolean, val. If a bool is true, return val. Let ref B. Evaluation of logical and expression. Return. Get value, ref. 280. ECMA International 2024. The value produced by and or operator is not necessarily of type boolean. The value produced, note, will always be the value of one of the two operand expressions. Coalesce expression head. Bitwise or expression. Let ref B. Evaluation of coalesce expression head. Let val B. Get value, ref. If a val is either undefined or null, then let ref B. Evaluation of bitwise or expression be return. Get value, ref, else a returnal val. 3.14 conditional operator. Syntax. Conditional expression in yield await. Short circuit expression in yield await. Short circuit expression in yield await. Assignment expression plus in yield await. Assignment expression in yield await. 3, 1, 4. 1 runtime semantics. Evaluation. Conditional expression. Short circuit expression. Assignment expression. Let ref B. Evaluation of short circuit expression. Let val be to boolean. Get value, ref. If val is true, then let true ref B. Evaluation of the first assignment expression be return. Get value, true ref. Else let false ref B. Evaluation of the second assignment expression be return. Get value, false ref. Note the grammar for a conditional expression in ECMA script is slightly different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMA script is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. ECMA International 2024 281 13.15 Assignment operators syntax. Assignment expression in yield await. Conditional expression in yield await plus yield expression in await. A row function in yield await. A sim arrow function in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await. Assignment operator assignment expression in yield await. Left-hand side expression yield await and equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Assignment operator 1 of equals percent equals plus equals and equals 3, 1, 5, 1 static semantics. Early errors. Assignment expression. Left-hand side expression equals assignment expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. Assignment expression. Left-hand side expression. Assignment operator assignment expression. Left-hand side expression and equals assignment expression. Left-hand side expression equals assignment expression. Left-hand side expression equals assignment expression. It is a syntax error if assignment target type of left-hand side expression is not simple. 3, 1, 5, 2 runtime semantics. Evaluation. Assignment expression. Left-hand side expression equals assignment expression. 82. If left-hand side expression is neither an object literal nor an array literal, then a letter F B. Evaluation of left-hand side expression. B. It is anonymous function definition, assignment expression, and is identifier F of left-hand side expression are both true. Then I let val B. Named evaluation of assignment expression with argument ref. C else I let ref B. Evaluation of assignment expression 2. Let val B. Get value ref D perform. Put value ref. Reval. Return reval. Let assignment pattern be the assignment pattern that is covered by left-hand side expression. ECMA International 2024. 3. Let ref B. Evaluation of assignment expression. Let val B. Get value ref. Perform. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T. Of assignment pattern with argument reval. Return reval. Assignment expression. Left-hand side expression. Assignment operator assignment expression. Let ref B. Evaluation of left-hand side expression. Let val B. Get value ref. Let ref B. Evaluation of assignment expression. Let val B. Get value ref. Let assignment op text be the source text matched by assignment operator. Let op text be the sequence of Unicode code points associated with assignment op text in the following table. Assignment op text equals percent plus equals let R B. Capital A P P L Y. Capital S T R I N G. Capital O R. capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, text, val, perform, put value, ref, R, dot, return R, assignment expression, left-hand side expression and equals assignment expression, letter F B, evaluation of left-hand side expression, letter val B, get value, ref, let bool be to boolean, val, if a bool is false, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then, a letter val B, named evaluation of assignment expression with argument ref, else, a letter F B, evaluation of assignment expression, b let val B, get value, ref, perform, put value, ref, reval, return reval, assignment expression, left-hand side expression equals assignment expression, letter FB, evaluation of left-hand side expression, letter val B, get value, ref, let bool be to boolean, val, if a bool is true, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then, a letter val B, named evaluation of assignment expression with argument ref 6, else, a letter FB, evaluation of assignment expression, b let val B, get value, ref, ECMA International 2024 283, 7. Perform, put value, ref, reval, return reval, assignment expression, left-hand side expression equals assignment expression, letter FB, evaluation of left-hand side expression, letter val B, get value, ref, if a val is neither undefined nor null, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then, a letter val B, named evaluation of assignment expression with argument ref, else, a letter FB, evaluation of assignment expression, b let reval B, get value, ref, perform, put value, ref, reval, return reval, 3, 1, 5, 3, capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, text, reval, the abstract operation, capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, takes arguments of val, any CNA script language value, text, comma percent, plus, or, and reval, any CNA script language value, and returns either a normal completion containing either a string, a begin, or a number, or a throw completion. It performs the following steps when called. If text is plus, then a letter from B. To primitive, val, B letter from B. To primitive, val, see if a prim is a string or a prim is a string, then I let lst rb. To string, prim 2. Let rst rb. To string, reprim 3. Return a string concatenation of lst r and rst r. D set reval to prim, e set reval to reprim. Note, at this point, it must be a numeric operation. Letter num B. To numeric, val, letter num B. To numeric, reval, if type, num, is not type, renum, throw a type error exception. If num is a big int, then, note when this expression occurs within strict mode code, it is a runtime error if ref in step 1D, 2 is an unresolvable reference. If it is, a reference raw exception is thrown. Additionally, it is a runtime error if the ref in step 8, 7 is a reference to a data property with the attribute value, false, to an accessor property with the attribute value, ABCD. Let if text is, return, big int, exponentiate, num, renum, if text is comma return, big int, divide, num, renum, if text is percent, return, big int, remainder, num, renum, if text is, return, big int, and signed right shift, num, renum, operation be the abstract operation associated with text and type, num, in the following table, 84, ECMA International 2024, text type, num, operation, number, exponentiate number, multiply big int, multiply number, divide number, remainder number, add, percent plus, number big int number, text type, num plus big int, number big int, number big int, number big int, comma number big int, number big int, number big int, operation, big int, add number, subtract big int, subtract number, left shift big int, left shift number, signed right shift big int, signed right shift number, and signed right shift number, bitwise and big int, bitwise and number, bitwise or big int, bitwise or number, bitwise or big int, bitwise or return operation, num, renum. Note 1 no hint is provided in the calls to primitive in steps 1 and 1b. All standard objects except dates handle the absence of a hint as if number were given. Dates handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2 step 1c differs from step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital capital E, left operand, op text, right operand. The abstract operation, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, takes arguments left operand, a parse node, op text, a sequence of Unicode code points, and right operand, a parse node, and returns either a normal completion containing either a string, a big int, or a number, or an abrupt completion. It performs the following steps when called. Letter FB. Evaluation of left operand. Letter val B. Get value. Ref. Letter FB. Evaluation of right operand. Letter val B. Get value. Ref. Return. Capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, op text, val, 3, 1, 5. 5. Destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production, assignment expression, left-hand side expression equals assignment expression. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern, yield, await, object assignment pattern yield await, array assignment pattern yield await. ECMA International 2024 285. Object assignment pattern, yield, await, assignment dress property yield await, assignment property list yield await, assignment property list yield await, assignment dress property yield await opt, array assignment pattern, yield, await, eligible assignment dressed element yield await opt, assignment element list yield await, assignment element list yield await, eligible assignment dressed element yield await opt, assignment dress property, yield, await, dot. Destructuring assignment target yield await, assignment property list, yield, await, assignment property yield await, assignment property list yield await, assignment property yield await, assignment element list, yield, await, assignment elision element yield await, assignment element list yield await, assignment elision element yield await, assignment elision element, yield, await, eligible assignment element yield await, assignment property, yield, await, identifier reference yield await, initializer, class and yield await opt, property name yield await, assignment element yield await, assignment element, yield, await, destructuring assignment target yield await, initializer, class and yield await opt, assignment dressed element, yield, await, dot. Destructuring assignment target yield await, destructuring assignment target, yield, await, left-hand side expression yield await, 3, 1, 5, 5, 1 static semantics, early errors, assignment property, identifier reference initializer opt. It is a syntax error if assignment target type of identifier reference is not simple. Assignment dress property. Destructuring assignment target. It is a syntax error if destructuring assignment target is either an array literal or an object literal. Destructuring assignment target. Left-hand side expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. 86. Copyright sign. ECMA International 2024. Comma, it is a syntax error if assignment target type of left-hand side expression is not simple. 1, 3, 1, 5, 5. To runtime semantics. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T. The syntax directed operation. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, takes argument value, any CMA script language value, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Object assignment pattern. Perform. Require object collapsible. Value. Return unused. Object assignment pattern. Assignment property list. Assignment property list. Perform. Require object collapsible. Value. Perform. Capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment property list with argument value. Return unused. Object assignment pattern. Assignment dress.
The address space, whatever.
Val, UE, letter.
64-bit.
Turn. Capital R.
Or like,
T, capital D.
the user address space for code.
U, C, T, U.
In RAP mode, rip relative mode.
S, I, G, N, M.
I think it's because this is outside the 2 gig range.
A, of assignment dress property with arguments value and
It's below
assignment
4 gigs.
dress property. Perform. Require object collapse.
That might be the memory map region, whatever.
R, O.
I don't know though.
R T Y cap
I just want this to work. I'm gonna give up in a second.
U C T
It's taking way too long.
I N G capital A S S I G N M E N of assignment property list with argument value return capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A of assignment dress property with arguments value and excluded names array assignment pattern let iterator record B get iterator value sync return iterator close iterator record normal completion unused array assignment pattern illusion let iterator record B get iterator value sync let result be completion iterator destructuring assignment evaluation of illusion with argument iterator record if iterator record is false return iterator close iterator record result
Let's try this.
assignment pattern elision or assignment dressed element let iterator record B get iterator value sync if illusion is present then a let status
How the fuck am I supposed to get this up?
evaluation of illusion with argument iterator
So annoying.
abrupt completion then assert iterator record is true 2 return status let result be completion iterator destructuring assignment evaluation of assignment dressed element with argument iterator record ECMA International 2024 287 4 if iterator record is false return iterator close iterator record result return result array assignment pattern assignment element list let iterator record B get iterator value sync let result be completion iterator destructuring assignment evaluation of assignment element list with argument iterator record if iterator record is false return iterator close iterator record result
It doesn't work.
elision or assignment dressed element opt let iterator record B get iterator value sync let status be completion iterator destructuring assignment evaluation of assignment element list with argument iterator record if status is an abrupt completion then if iterator record is false return iterator close iterator record status b return status if illusion is present then assert status to completion iterator destructuring assignment evaluation of illusion with argument iterator record b if status is an abrupt completion then assert iterator record is true 2 return status if assignment dressed element is present then assert status to completion iterator destructuring assignment evaluation of assignment dressed element with argument iterator record if iterator record is false return iterator close iterator record status return status 3 1 5 5 3 runtime semantics property destructuring a sig ment evaluation the syntax directed operation capital P R O P E R T Y capital D E S T R U C T U R I N G capital A S S I G N M E N takes argument value, an ECMA script language value, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list of all destructured property keys. It is defined piecewise over the following productions: assignment property list, assignment property list, assignment property. Let property names be capital P R O P E R T Y capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment property list with argument value. Let next names be capital P R O P E R T Y capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property identifier reference initializer opt. Let P be string value of identifier reference. Let LF be resolve binding. P let P be jet value. P if initializer is present and V is undefined. Then if is anonymous function definition initializer is true. Then I set for 2. Named evaluation of initializer with argument P B else. I let default value be evaluation of initializer 2. Set for 2. Get value default value perform put value ref V return P.
Oh my god, that's so dumb. Testing, really? Sound's not working. Everything is shit. Testing. Testing, testing. Testing. It's like this is memory mapped also. Oh my god, I hate chatbot. It's so fucking stupid. Fuck. So dumb. That's not gonna work. Well, I tried. Had to waste a whole extra copy. This stuff is shit. Alright, so this wastes 2 copies. First off, it copies it to whatever the fuck this X shim or whatever the hell it's called to get the frame buffer. And then it does another copy to memory map it. So it's to copy it to make the frame buffer copy. And then does another copy to set it to the memory mapped region. You can't just get the memory mapped region and then do the mem copy to it. Or do the video capture to it. Because they're each like memory mapped or something, or some shit. Really annoying. So this is like, takes up twice as much time to fucking copy buffer, because those are do twice. Imagine an operating system written from the bottom up that didn't do any of that. That'd be really fast, but like everywhere, across the whole thing. Kind of like how like I'm writing a JavaScript engine. Well, it's already done. I have to like update it and make it meet the standard, and have the rest of the mechanics. But I stripped out all the personalization and stuff, and bytecode, and all the shit that's in JavaScript that makes it slow. I stripped all that out. It makes it really fucking fast. Imagine if you did that at operating system level. If at the operating system level, you didn't do this stupid, just whatever the fuck is going on with the dumbass address space. It's idiotic. It's so dumb. This stuff is so slow. I'm gonna get some water, but I had to save this, whatever. And I have chip out, flip the triangle. But not just this, I mean like I had to go through JavaScript, I wrote my own engine, and I like optimize every single thing. If you do that with the operating system, it'd be so fucking fast. So I'm gonna save the backup of this. I think I already have a backup. I'll save another one. And I'm gonna like hit shotbot to flip the triangle. Then I have it make a quad. I want to make sure that I can actually flip the triangle. Because if it doesn't, then I don't trust that I'll make the quad code right. So I want to like flip a triangle first, check it. If it looks like it worked, then I'll probably make valid code for the quad. And I want to give the quad a color. And if it can do that, I can see color on the screen. And the quad worked. All I gotta do is figure out how to apply the fucking image to the quad. Really simple. It's not hacky. I'm not like doing funky stuff trying to like use the address that's gonna be memory mapped after it's memory mapped. Which you should be able to do, but you can't. So I'm not gonna do any more weird funky stuff for now. I'm like done messing around with C. It's getting boring now. I want to like test some stuff because I haven't done C in a while. Or like I have been converting to C but it's like converting. I haven't been writing new stuff in C. So, I don't know, I finally all set up. I'm feeling like ready to just do stupid triangle shit. No more testing, no more like figuring stuff out. It is whatever. So it already gets the desktop. It does like a bullshit double copy. I wonder if I should do the frame copy after it outputs the frame. I said before, but that might be slower. Because if it caches right, it might as well do the reads right after. So increase the odds of it being cached. But then it doubles the latency. Unless it's cached. I'm not going to deal with any performance for now. I'm just going to leave everything from now on. And just get it running. Then later do that. Everything is just shit. Just absolute trash. So it's a triangle. I want JetBot to flip it. First, to make sure that works, because I think it's giving me bad code. If it does flip a triangle, then it might be giving me working code, but something's off. I'm gonna get it working. I'm gonna get this done. I don't know, whatever. BRB. Everything sucks. Including your mom. Oh.
prop. Arguments value, any CMA script language value, and environment record or undefined, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list of all bound property names. It is defined piecewise over the following productions: binding property list, binding property list, binding property. Let bound names be property binding initialization of binding property list with arguments value and environment. Let next names be property binding initialization of binding property with arguments value and environment. Return the list concatenation of bound names and next names. ECMA International 2024 297. Binding property, single name binding. Let name be the sole element of the bound names of single name binding. Perform. Keep binding initialization of single name binding with arguments value, environment, and name. Return name, binding property, property name, binding element. Let PB. Evaluation of property name. Perform. Keep binding initialization of binding element with arguments value, environment, and P. Return P. 4, 3, 3, to runtime semantics, rest binding initialization. The syntax-directed operation rest binding initialization takes arguments value, any CMA script language value, environment record or undefined, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding rest property, binding identifier, let LHS be, resolve binding, string value of binding identifier, environment, let rest objb ordinary object create, %object prototype %perform. Copy data properties, rest obj, value, excluded names, if environment is undefined, return. Put value, LHS, rest obj, return. Initialize reference binding, LHS, rest obj, 4, 3, 3, 3 runtime semantics, keep binding initialization. The syntax-directed operation keep binding initialization takes arguments value, any CMA script language value, environment record or undefined, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding element, binding pattern initializer opt, let VB, jet, value, property name. If initializer is present and V is undefined, then a let default value be. Evaluation of initializer, B sets V2, get value, default value, return. Binding initialization of binding pattern with arguments V and environment. Single name binding, binding identifier initializer opt. Let binding ID be string value of binding identifier. Let LHS be. Resolve binding, binding ID, environment. Let VB. Jet, value, property name. If initializer is present and V is undefined, then if is anonymous function definition, initializer, is true, then I set V2. Named evaluation of initializer with a argument binding ID, be else. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 98. ECMA International 2024. I2. Let default value be. Evaluation of initializer. Semfir 2. Get value. Default value. 5. If environment is undefined, return. Put value. LHS. V. Return. Initialize reference binding. LHS. V. 4.4 empty statement syntax. Empty statement. 4. 4. 1 runtime semantics. Evaluation. Empty statement. 1. Return empty, 4.5 expression statement syntax. Expression statement, yield, await, look ahead, function, async, no line terminator here, function, class, let, expression, class and yield await. Note an expression statement cannot start with a u plus 007b, left curly bracket, because that might make it ambiguous with a block. An expression statement cannot start with the function or class keywords because that would make it ambiguous with a function declaration, a generator declaration, or a class declaration. An expression statement cannot start with a sync function because that would make it ambiguous with an async function declaration or a sync generator declaration. An expression statement cannot start with the two-token sequence let, because that would make it ambiguous with a let lexical declaration whose first lexical binding was an array binding pattern. 4, 5, 1 runtime semantics. Evaluation. Expression statement. Expression. Let x per f be. Evaluation of expression. Return. Get value, x per f, 4.6 if statement syntax. If statement, yield, await, return. If expression, class and yield await, statement yield await return. Else, statement yield await return. If expression, class and yield await, statement yield await return. Look ahead else. The look ahead restriction, look ahead else, resolves the classic dangling else problem in the note, usual way. That is, when the choice of associated if is otherwise ambiguous, the else is associated with the nearest, innermost, of the candidate ifs. ECMA International 2024 299. 1 4, 6, 1 static semantics, early errors. If statement, if, expression statement else statement. It is a syntax error if is labeled function. The first statement is true. It is a syntax error if is labeled function. The second statement is true. If statement, if, expression statement. It is a syntax error if is labeled function. Statement, is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. 4, 6, to runtime semantics. Evaluation. If statement, if, expression statement else statement. Let x per f be. Evaluation of expression. Let x per value be to boolean. Get value, x per f. If x per value is true, then a let stmt completion be completion. Evaluation of the first statement 4. Else, a let stmt completion be completion. Evaluation of the second statement 5. return. Update empty, stmt completion, undefined. If statement, if, expression statement, let x per f be. Evaluation of expression, let x per value be to boolean. Get value, x per f. If x per value is false, then a return undefined for, else, a let stmt completion be completion, evaluation of statement be return. Update empty, stmt completion, undefined. 4.7 iteration statement syntax. Iteration statement, yield, await, return, do while statement yield await return, while statement yield await return, for statement yield await return, for enough statement yield await return. 4, 7, 1 semantics. 4, 7, 1. 1 loop continues. Completion, label set. The abstract operation loop continues takes arguments completion, a completion record, and label set, a list of strings, and returns a boolean. It performs the following steps when called. If completion is a normal completion, return true. If completion is not a continue completion, return false. If completion is empty, return true. 300. ECMA International 2024. 4. If label set contains completion, return true. Return false. 4, 7, 1. To runtime semantics. Loop evaluation. The syntax-directed operation loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Iteration statement, do while statement, return. Do while loop evaluation of do while statement with argument label set. Iteration statement, while statement, return. While loop evaluation of while statement with argument label set. Iteration statement, for statement, return. For loop evaluation of for statement with argument label set. Iteration statement, for enough statement, return. For enough loop evaluation of for enough statement with argument label set 1 4, 7, 2 do while statement, syntax, do while statement, yield, await, return, do statement yield await return, while, expression, plus and yield await, 4, 7, 2, 1 static semantics, early errors, do while statement, do statement while, expression, it is a syntax error if is labeled function, statement, is true, note it is only necessary to apply this rule if the extension specified in B, 3.1 is implemented 1 4, 7, 2, to runtime semantics, do while loop evaluation, the syntax-directed operation do while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Do while statement, do statement while, expression, let v be undefined 2. Repeat, a let stmt result be completion, evaluation of statement, b if loop continues, stmt result, label set, is false, return. Update empty, stmt result, v, see if stmt result is not empty, set v to stmt result, d let x per f be. Evaluation of expression. Note within the statement part of an iteration statement a continue statement may be used to begin a new iteration. Copyright sign, ECMA International 2024 301. E let x per value be. Get value, x per f. F if the boolean, x per value, is false. Return v. 4, 7, 3 while statement syntax. While statement, yield, await, return, while, expression, plus and yield await. Statement yield await return. 4, 7, 3, 1 static semantics, early errors, while statement, while, expression statement, it is a syntax error if is labeled function, statement, is true, note it is only necessary to apply this rule if the extension specified in B, 3.1 is implemented 1 4, 7, 3, to runtime semantics, while loop evaluation, the syntax-directed operation while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. While statement, while, expression statement, let v be undefined 2. Repeat, a let x per f be. Evaluation of expression, b let x per value be. Get value, x per f, see if the boolean, x per value, is false. Return v, d let stmt result be completion. Evaluation of statement, e if loop continues. Stmt result, label set, is false. Return. Update empty, stmt result, v, f if stmt result is not empty, set v to stmt result, 4, 7, 4th f for statement syntax, for statement, yield, await, return, 4, look ahead let, expression, in yield await opt, 1 4, 7, 4, 1, expression, plus in yield await opt, expression, plus in yield await opt, statement yield await return, 4, var variable declaration list, in yield await, expression, plus in yield await opt, expression, plus in yield await opt, statement yield await.
Alright, so like, I don't know.
Wait, expression.
I want to try the union trick to copy memory really quick.
Static semantics, early errors.
Don't do the triangle stuff.
Not, express not statement, 4, var variable.
Because I can't get the stupid copy without the double buffer copy.
02, ECMA into.
So if I get this, it feels like,
function, statement.
I don't know.
Rule if the extension specified in.
I want to do something. I spent all this time figuring out stuff and testing stuff.
Any element of
and I can't get any of it. That's just crap.
of statement 4, 7, 4.
So I'll try this.
For loop evaluation, the syntax-directed operation for loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing any CMA script language value or an abrupt completion. It is defined piecewise over the following productions. For statement, for expression not, statement. If the first expression is present, then let x per f be. Evaluation of the first expression be perform. Get value, x per f. If the second expression is present, let test be the second expression. Otherwise, let test be empty. If the third expression is present, let increment be the third expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement, for var variable declaration list, expression not, statement. Perform. Evaluation of variable declaration list. If the first expression is present, let test be the first expression. Otherwise, let test be empty. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement, for lexical declaration expression not, statement. Let OldEnv be the running execution context's lexical environment. Let loopEnv be new declarative environment. OldEnv, let is constant declaration of lexical declaration. Let bound names be the bound names of lexical declaration. For each element dn of bound names, do if this const is true, then I perform loopEnv create immutable binding. Dn true be else, I perform loopEnv create mutable binding. Dn false, set the running execution context's lexical environment to loopEnv. Let for dclv completion.
Alright, so I'm checking if bytes per line
Abrupt completion, then a set the running
is a literal. literal.
CL. If this const is false, let for iteration let's be bound names. Otherwise, let for iteration let's be a new empty list. 0. If the first expression is first expression, otherwise, let test be empty. 1. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. 2.
Yeah, it's not worth it. I'm done.
Test, increment.
I'm not optimizing jack shit with this shit.
Environment OldEnv 4. Return body result. Copyright sign. ECMA International.
Leave this off.
3 1 4.
And then make the triangles. Yeah, no, this stuff is shit.
STMT. Iteration bindings. Label set. The
Like the compiler can optimize
expression paths no door empty.
a union copy
A statement
into like, or it can optimize a
and returns.
mem copy to do the same thing as a union copy.
It performs the following steps when called.
But then the compiler, it can't optimize things
Repeat. If test is not empty, then I let test
that actually could be optimized.
test value B.
But it optimizes the most basic fucking shit
Return V. B let result be complete.
that it can, because you can only write code a certain way in C syntax.
Update.
So it optimizes whatever.
Create iteration environment.
C language is terrible.
Then I let incref B. Evaluation of increment 2. Perform. Get value. Incref 4 7 4. For create iteration environment.
I gotta find the code that makes a triangle.
Environment takes argument iteration bindings, a list of strings, and return
Paste in and ship out.
new store throw completion. It performs the following steps when called. If iteration bindings has any elements, then a let last iteration env be the running execution context's lexical environment. D let outer be last iteration env. C assert. Outer is not null. D let this iteration env be new.
It's right here.
Outer. If reach element bn of iteration bindings. Do. I perform this iteration env create mutable binding. Bn. False. 2. Let last value be last iteration env get binding value. Bn. True. 3. Perform this iteration env initialize binding. Bn. Last value. F set the running execution context's lexical environment to this iteration env. Return unused. 04. ECMA International 2024. 14. 7. 5. The for and for await of statement syntax. For in of statement. Yield. Await. Return. 4. Look ahead let. Left hand side expression yield await. In. Expression. Class in yield await. Statement yield await return. 4. var for binding yield await. In expression. Class in yield await. Statement yield await return. 4. For declaration yield await. In expression. Class in yield await. Statement yield await return. 4. Look ahead. Let. Async of left hand side expression yield await. Of assignment expression. Class in yield await. Statement yield await return. 4. var for binding yield await. Of assignment expression. Class in yield await. Statement yield await return. 4. For declaration yield await. Of assignment expression. Class in yield await. Statement yield await return. Plus await. For await. Look ahead let. Left hand side expression yield await. Of assignment expression. Class in yield await. Statement yield await return. Plus await. For await.
Okay, so like, I don't know, I think I got a command buffer or whatever. It ends up holding the swap image or
Declaration yield await. Of assignment expression. Plus in
the frame buffer,
for
because it's passed in to the command buffer.
for binding. Yield await.
So I don't know, it's a relationship between the two.
Yield await.
I think.
1 4 7 5
At least it looks like. I don't know, whatever.
statement 4 left
Need some water.
var for binding an expression statement 4 for
Until Shabbat justice.
left hand side expression of assignment expression statement 4 var for binding of assignment expression statement 4 for declaration of assignment expression statement for await left hand side expression of assignment expression statement for await var for binding of assignment expression statement for await for declaration of assignment expression statement. It is a syntax error if is labeled function statement is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. Copyright sign ECMA International 2024 305 for in of statement 4 left hand side expression in expression statement 4 left hand side expression of assignment expression statement for await left hand side expression of assignment expression statement if left hand side expression is either an object literal or an array.
I see Chatbot adjust this to rotate the triangle 180 degrees.
Left hand side expression
Or you need the shader also.
error rule is applied. It is a syntax error if assignment target type of left hand side expression is not simple.
Because I don't know.
Statement 4 for declaration of assignment expression statement for await for declaration of assignment expression statement. It is a syntax error if the bound names of for
You need to apply transformation to the vertex position
occurs
in the vertex shader by modifying the vertex data.
and contains any duplicate entries 4 7 5.
Why? Because blah blah blah.
Syntax directed operation is destructuring, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Member expression, primary expression. If primary expression is either an object literal or an array literal, return true, return false. Member expression, expression, member expression. Identifier name member expression template literal super property, meter property, new member expression argument member expression. Private identifier, new expression.
And it needs a vertex shader.
Call expression, optional expression, return false. For declaration, let or constant.
Because the GPU is set up,
For binding,
it's set up where it's pre-computed for you. It's a big program.
binding pattern 1.
Because lots of people are babies and they don't know how to program.
4 7 5 3 run.
And they're scared to program.
O R capital D E
So the GPU setup is like a big program.
N capital B I N
It has layers,
G capital I N I
just like crap when you take a dump.
Z. The syntax directed operation capital
It like layers itself,
E E C
and you're forced to comply to whatever freaking mathematic, however they want to compute it.
N G
It comes in layers of shit.
I T
So you have to adjust the vertex layer because that's before the fragment shader is applied.
door undefined and
So you can rotate the points in the invisible, made up 3D space doesn't really exist.
const for binding
And you're stuck to triangle math based off the triangle math that they use.
or runtime semantic
Because without triangle math,
R capital D E
matrices and stuff, they'd have no basis. You wouldn't really even need them.
capital B
You could do stuff however the fuck you want to do it.
N G capital I
But if you could do stuff however you want to do it,
N T I
there'd be a lot of people without jobs.
N capital F
Because a lot of people have jobs doing things that are done by convention, but like no other reason.
capital
Then that's how it's been done.
D I N
So it's like triangle math for now, and like forever, I guess.
N T I A takes argument environment a declarative environment.
I hate this so much.
It is defined piecewise over the following productions. For declaration, let or const for binding. For each element name of the bound names if for binding, do a if is constant declaration.
I'm tired of all these dumb structs.
Name, true be
The CPU is not programmed like this.
false to
The CPU could never be programmed like this because it's so inefficient.
for an of loop evaluation. The syntax directed operation for an of loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. For an of statement 4 left hand side expression in expression statement let key result be. For an of head evaluation expression in
Assembly language is like a fine course.
statement key result
This GPU stuff is like dog food. Just complete garbage.
expression statement
It is so annoying.
expression enumerate return. For an of
I gotta stop complaining, but not really. I do whatever.
label set note undefined is passed for environment to indicate that a put value on
But I'm wasting time complaining.
value. This is the case for var statements in the formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International.
I'm just gonna paste this into the vertex shader.
4 for declaration in expression statement let key result be. For in of head evaluation, bound names of for declaration, expression, enumerate, return. For in of body evaluation, for declaration, statement, key result, enumerate, lexical bind.
Alright, so I want it to make it spin it too.
Side expression of assignment expression statement, let key result be. For in of head evaluation, assignment expression, iterate, return. For in of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set. For in of statement, 4, var for binding of assignment expression statement, let key result be. For in of head evaluation, assignment expression, iterate, return. For in
About the Z and X axes.
key result, iterate, var binding, label set. For in of statement, 4, for declaration.
At like 3 rotations per second.
Bound names of for declaration, assignment expression, iterate, return. For in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set. For in of statement, for await, left-hand side expression of assignment expression statement.
So I'm talking to give me a code.
Evaluation, assignment expression, async iterate, return. For in of body evaluation.
That'll make it spin the triangle about the X and Z axes at like 3 rotations per second.
For in of statement, for await, var for binding of assignment expression statement, let key result be. For in of head evaluation, assignment expression, async iterate, return. For in of body evaluation, for binding, statement, key result, iterate, var binding, label set, async. For in of statement, for await, for declaration of assignment expression statement, let key result be. For in of head evaluation, bound names of for declaration, assignment expression, async iterate, return. For in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set, async. Note this section is extended by an XB, 3.5, 4, 7, 5, 6 for in of head evaluation, uninitialized bound names, expr, iteration kind. The abstract operation for in of head evaluation takes arguments uninitialized bound names, a list of strings, expr, an expression parse node or an assignment expression parse node, and iteration kind, enumerate, iterate, or async iterate, and returns either a normal completion containing an iterator record or an abrupt completion. It performs the following steps when called. 1. 2. Let all DNV be the running execution context's lexical environment. If uninitialized bound names is not empty, then 08. ECMA International 2024 ABC D. Assert. Uninitialized bound names has no duplicate entries.
Push constant offset.
Environment. Old env for each string name of uninitialized bound names. Do. I perform new env create mutable binding. Name. False. Set the running execution.
I don't like push. What does that mean?
3. Let expr be completion. Evaluation of expr. Set the running execution context's lexical environment. Old env. Let expr value be. Get value expr. If iteration kind is enumerate, then if expr value is either undefined or not.
Is there a stack?
Record. Break.
This is just passing it in.
B let obj be. To object, expr value. C let iterator be. Enumerate object properties. Obj D let next method be. Jet. Iterator. Next. E return the iterator record. Iterator. Next method.
I'll try this.
Assert. Iteration kind is either iterate or async iterate. B if iteration kind is async iterate. Let iterator kind be async. C else. Let iterator kind be sync. D return. Get iterator, expr value, iterator kind. The abstract operation for in of body evaluation takes arguments LHS, a parse node, STMT, a statement B, AS node, iterator record, an iterator record, iteration kind, enumerate or iterate, LHS kind, assignment, var binding, or lexical binding, and label set, a list of strings, and optional argument iterator kind, sync or async, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If iterator kind is not present, set iterator kind to sync. Let all DNV be the running execution context's lexical environment. Let V be undefined. Let destructuring be as destructuring of LHS. If destructuring is true and LHS kind is assignment, then assert. LHS is a left-hand side expression. B let assignment pattern be the assignment pattern that is covered by LHS. Repeat. A let next result be. Call. Iterator record. Iterator record. B if iterator kind is async. Set next result 2. Await. Next result. See if next result is not an object. Throw a type error exception. DLS done B. Iterator complete. Next result. E if done is true. Return V. F let next value be. Iterator value. Next result. G if LHS kind is either assignment or var binding. Then I if destructuring is true. Then if LHS kind is assignment. Then a let status be completion. Destructuring assignment evaluation of assignment pattern with argument next value 2. Else. Assert. LHS kind is var binding. B assert. LHS is if for binding. C let status be completion. Binding initialization of LHS with arguments next value and undefined. 2. Else. Let LHS ref be completion. Evaluation of LHS.
Paste this underneath.
LHS ref is an abrupt completion. Then a let status be LHS ref 3. Else. A let status be completion. Put value. LHS ref. Next value. H else. I assert. LHS kind is lexical binding. 2. Assert. LHS is a for declaration. 3. Let iteration env the new declarative environment. Old env. I've. Perform. Capital F. O. R. Capital D. E. C. L. A. R. A. T. I. O. N. Capital B. I. N. D. I. N. G. Capital I. N. S. of LHS with argument iteration en v for in of body evaluation LHS stmt iterator record iteration kind LHS kind label set iterator kind 4757 ECMA International 2024.
Must be a global, a global boolean. To check for the time start or whatever. Of course they'll have generic names, so you're like, everything's stupid. I hate having to rename stuff. Fair function. Make bool. Call entry. I could just inline it, but I'm just gonna whatever. Write some lazy code just want to get done.
Elision. Let len be next index plus 1. Perform. Set. Array. Length. Len. True. Note. The above step throws if len exceeds 232 1. Return len. Elision. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision or assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw. Array. To string. Next int x. Init value. Return next index plus 1. Note an array literal is an expression describing the initialization of an array, using a list of 0 or more expressions each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024-247. Element list. Elision or spread
He's even used yet.
Set next index 2. Elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element.
Sort of the pipeline command buffer.
Set next index 2.
Alright, that's what I gotta call this.
Element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw. Array. To string. Next int x. Init value. Return next index plus 1. Element list. Element list. Elision or spread element. Set next index 2. Array accumulation.
Oh, that's what does. Okay.
If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next.
So v command draw.
Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be. Evaluation
Is what does technically the pixel blitz.
be. Get
But there's no pixels
sync. Repeat. Let next.
because it's drawing. Alright, whatever. That's dumb.
Create data property or throw. Array. To string. Next int x.
I think I figured it out.
Next index plus 1. Note create data property or throw is used to ensure that own properties.
Call this right before it.
An array prototype object has been modified in a manner that would preclude the creation of new own properties.
To apply the rotation.
2. Runtime semantics. Evaluation. Array literal. Elision or let array.
Well, they do it before the pipeline even.
A perform. Array accumulation of elision with arguments array and 0. 3. Return array. Array literal. Element list. Let array be. Array create. 0. Perform. Array accumulation of element list with arguments array and 0. Return array. Array literal. Element list. Elision or 2. Let array be. Array create. 0. Let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA International.
So to pass in command buffer pipeline.
Array accumulation of elision with arguments array and next index. Return array. 3. 2. 5 object initializer. Syntax. Object literal.
Make this a macro.
Property definition list yield await. Property definition list yield await. Property definition list yield await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition yield await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression class and yield await. Method definition yield await. Dart. Assignment expression class and yield await. Property name yield await. Literal property name computed property name yield await. Literal property name identifier name string literal numeric literal computed property name yield await. Assignment expression class and yield await. Cover initialized name yield await. Identifier reference yield await. Initializer class and yield await. Initializer in yield await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign, ECMA International 2024-249. Note 3 in certain contexts. Object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3.
Pass this in.
1 static semantics, early errors, property definition, method definition, bullet. It is a syntax error if his direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In
Command buffer was here.
assignment pattern and may be recognized as part of a capital C O V E R capital P
Where the heck is the pipeline layout?
T H E S I Z E D capital E X P R
Dang, is this a global? Man.
O N capital A N.
I'll just assume it's correct.
Object assignment pattern is
I don't care anymore. It's all so fucking annoying.
they are not applied when initially parsing a
Global this, global that.
R capital P A R E N T H E S I Z E D capital E X P R E S
She will just run anyways.
A N C-O-V-E-R, capital C-A-L-L, capital E-X-P-R-E-S,
I didn't define something.
N, capital A,
Or declare something correctly.
S-Y-N-C, capital A-R-R, property definition, cover initialized name. It is a syntax error if any source text is matched by this production. Object liter, al, property definition list, property definition list. It is a syntax error if property name list.
Was it UN? 8?
Entries for proton, at least 2 of those entries were obtained from productions of the form, property definition, property name, assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions: property name, literal property name, return false, property name, computed property name, return true. Addition to describing an actual object initializing the object literal productions are also 250. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note 2. The list returned by property name list does not include property names defined using a computed property name. 1, 3, 2, 5, 3. Static semantics. Property
Oh, come on.
operation property name list takes no arguments and returns a list of strings.
232.
Following productions: property definition list, property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name, property definition.
No, that's fine.
List, property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty,
Got this.
the list concatenation of list and prop name. 3, 2, 5. For runtime semantics, evaluation, object literal, return ordinary, object create, percent, object prototype, percent, object literal, property definition list, property definition list. Let obj be ordinary, object create, percent, object prototype, percent.
All runs.
Definition evaluation of prop.
Yeah, like up to the shader.
Return obj, literal property name, identifier name, return string value of identifier name, literal property name, string literal 1. Return the SV of string literal property name, numeric literal. Let NBR be the numeric value of numeric literal. Return to string, NBR, computed property name, assignment expression. Let X per value be. Evaluation of assignment expression. Let prop name be. Get value, X per value. Return to property key.
I guess use the same shader they gave before.
Runtime semantics, property definition evaluation. The syntax directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an
This doesn't look right.
productions, property definition list,
Whatever.
property definition per form. Property definition evaluation of property definition list with argument object. Perform. Property definition evaluation of property definition with argument object. Return unused. ECMA International 2024 251. Property definition. Assignment expression. Let X per value be. Evaluation of assignment expression. Let from value be. Get value, X per value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value. Excluded names. Return unused. Property definition. Identifier reference. Let prop name be string value of identifier reference. Let X per value be. Evaluation of identifier reference. Let prop value be. Get value, X per value. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop name. Prop value. Return unused. Property definition. Property name. Assignment expression. Let prop key be.
So it's vert and invert.
Contained within a script that is being evaluated for
I don't want to like rename stuff right now.
Then a let is proton.
This is when I get running.
Proton is computed property key of property name is
It's vert, invert.
true, else a let is proto set to be false. If is anonymous function definition, assignment expression is true and is proto setter is false, then a let prop value be. Named evaluation of assignment expression with argument prop key, else a let X per value ref be. Evaluation of assignment expression be
It's 4, 5.
per value ref. If this proto setter is true, then if prop value is an object or prop value is null, then I perform object, prop value be return unused. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop key. Prop value 0. Return unused. Property definition. Method definition. Perform. Method definition evaluation of method definition with arguments object and true.
That's impressive.
6 function defining expressions.
I can take the tab,
Expression. Function expression. See.
like this, whatever. I can like switch windows, and it actually tracks it to the window where I drop it. Like Windows, can't even do that.
Expression.
That's really fancy.
International 2024 132 7 regular expression literal syntax C12 9 5 3 2 7 1 static semantics early
Man, why can't it just open to the same window that I'm just on?
I
That's not very fancy.
L I D
At least that's fancy.
G U L A R capital E X P R E S S I O N capital
So it's the vertex shader.
E R A regular expression.
Oh, please just fucking work.
To static semantics, capital I S capital V
Vertex. This one.
R E G U L A R capital E X P R E S S I O N capital L I T E R A
And then run.
operation capital I S capital V A
Of course it's not gonna work.
capital R
Why would it work?
L A R capital E X P R E S S I O N capital L I T E R A takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flagged.
I think chatbot
Means any code points other
is stupid.
M S U V or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal. If U is false and V is
I said your code did not work. There's no triangle now.
V set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern. Pattern text U V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 runtime semantics. Evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular
The problem is the shader. Piece of crap.
text of regular expression literal. Return regexp create pattern flags 3, 2, 8 template literal syntax template literal yield await tagged no substitution template yield await tagged substitution template yield await tagged template head expression plus and yield await template spans yield await tagged template spans yield await tagged template tail template middle list yield await tagged template tail ECMA International 2024
Let's see, fix it.
middle list yield await
So your mom. You know what? Never mind.
template middle list yield await tagged template middle expression plus and yield await 3, 2, 8 1 static semantics early errors template literal yield await tagged no substitution
Oh my god, it's so broken.
parameter was not set and no substitution template contain
Piece of crap.
yield await tagged substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument force is greater than or equal to
Whoa, so look at that. I mean, it's a fucking food.
tagged template head expression plus and yield await template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans yield await tagged template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list yield await tagged template middle expression plus and yield await template middle list yield await tagged template middle expression plus and yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8 to static semantics template strings. The syntax directed operation template strings takes argument draw a boolean and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template. Raw. Substitution template, template head expression template spans. Let head be template string, template head, raw. Let tail be template strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans, template tail. Return template string, template tail, raw. Template spans, template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string, template tail, raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list, template middle expression 1. Return template string, template middle, raw. Template middle list, template middle list template middle expression. Let front be template strings of template middle list with argument draw. Let last be template string, template middle, raw. Return the list concatenation of front and last. 3, 2, 8 3 static semantics. Template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRV of template token, else a let string be the TV of template token. Return string. 3, 2, 8 for get template object, template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do if e is the same parse node as template literal, then I return e. Let raw strings be template strings of template literal with argument true. Assert raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0 2. Repeat while index count a let prop be to string index b let cooked value be cooked strings index c perform define property or throw template prop property descriptor cooked value writable false true false d let raw value be the string value raw strings index e perform define property or throw raw obj prop property descriptor raw value false true false f set index plus 1 3 perform set integ RITI level raw obj frozen 4 perform define property or throw template raw property descriptor raw obj false enumerable false false 5 perform set integrity level template frozen 6 append the record template literal template to realm 7 return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tag templates. 1 3 2 8 6. The template objects are frozen and the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMA script code. 1 3 2 8 5. Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let precede and be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return the list concatenation of preceding and next. 3 2 8 6. Runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1 2 9 6. Substitution template. Template head expression. Template spans. Let head be the TV of template head as defined in 1 2 9 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return a string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1 2 9 6. Template spans. Template middle list. Template tail. Let head be. Evaluation of template middle list. Let tail be the TV of template tail as defined in 1 2 9 6. Return a string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1 2 9 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Return a string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1 2 9 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let last be. To string. Sub. Return a string concatenation of rest, middle, and last. 3 2 9. The grouping operator. 3 2 9 1. Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3 2 9. 2. Runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. capital A, N, let expa be the parenthesized expression that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, return. Evaluation of expa, parenthesized expression, expression, return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257, 13.3 left-hand side expression syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus and yield await. Member expression yield await. Identify name member expression yield await. Template literal yield await. Plus tagged super property yield await. Meter property. New member expression yield await. Arguments yield await. Member expression yield await. Private identifier super property yield await. Super expression plus and yield await. Super. Identifier name meter property. New target. Import meter new target. New target. Import meter. Import meta. New expression yield await. Member expression yield await. New expression yield await. Call expression yield await. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Yield await. Super call yield await. Import call yield await. Call expression yield await. Arguments yield await. Call expression yield await. Expression plus and yield await. Call expression yield await. Identifier name. Call expression yield await. Template literal yield await. Plus tagged. Call expression yield await. Private identifier. Super call. Yield await. Super arguments yield await. Import call. Yield await. Import. Assignment expression. Plus and yield await. Arguments. Yield await. Argument list yield await. Argument list yield await. 58. ECMA International 2024. Argument list. Yield await. Assignment expression. Plus and yield await. Dart. Assignment expression. Plus and yield await. Argument list yield await. Assignment expression. Plus and yield await. Argument list yield await. Assignment expression, plus and yield await. Optional expression, yield await. Member expression yield await. Optional chain yield await. Call expression yield await. Optional chain yield await. Optional expression yield await. Optional chain yield await. Optional chain yield await. Arguments yield await. Expression, plus and yield await. Identifier name, template literal yield await. Plus tagged. Private identifier, optional chain yield await. Arguments yield await. Optional chain yield await. Expression, plus and yield await. Optional chain yield await. Identifier name, optional chain yield await. Template literal yield await. Plus tagged, optional chain yield await. Private identifier, left-hand side expression, yield await. New expression yield await. Call expression yield await. Optional expression yield await. Supplemental syntax. When processing an instance of the production, call expression, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R. The interpretation of capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R.
So this is like no triangle.
Yield await. Member expression yield await. Arguments yield await. 3 3 1 static semantics. 3 3 1.
And the goal was to like rotate the triangle.
Plate literal.
So this is like a progressive step backwards.
International 2024 200.
If backward stepping is progressive.
Semicolon insertion rules 12.10 from being applied.
So
B C so that
I'm gonna undo this.
statements. The purpose is to maintain consistency with
Chatbot is not AI.
which is a valid statement and where automatic semicolon.
Anybody thinks that is AI,
It
it's a fucking idiot.
is not module 1.3.3 to property accesses. Note properties are accessed by name using either the dot notation, member expression, identifier name call expression, identifier name or
And would probably believe
expression call
that Epstein killed himself over nothing
tactic conversion, member
and his girlfriend's in prison, not overdoing anything wrong.
expression.
And there's no list.
Similarly, call expression, identifier name is identical in its behavior too.
I think his girlfriend like leaked 100 names or some shit.
Is the result of
It's not the list. Nobody cares.
semantics,
Let's grab.
Member expression. Expression. Let base reference B. Evaluation of member expression. Let base.
Alright, so I'm gonna do this, because this works.
The source text match by this member expression is strict.
And then rotate it.
Return. Capital E, V, A, L, E.
Oh, where'd the color go?
Capital P, R, O, P, E, R, T, Y. Capital A, C, C, E, S, S. Capital W, I, T, H. Capital E, X, P, R. Base value. Expression. Strict. 60. ECMA International 2024. Member expression. Member expression. Identifier name. Let base reference B. Evaluation of member expression. Let base value B. Get value. Base reference. If the source text match by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E. Capital P, R, O, P, E, R, T, Y. Capital A, C, C, E, S, S.
Wait, why did I put this inside of?
Capital I, D, E, N. Base value. Identifier name. Strict. Member expression. Member expression. Private identifier. Let base reference B. Evaluation of member expression. Let base value B. Get value. Base reference. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Call expression. Call expression. Expression. Let base reference B. Evaluation of call expression. Let base value B. Get value. Base reference. If the source text match by this call expression is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E. Capital P, R, O, P, E, R, T, Y. Capital A, C, C, E, S, S. Capital W, I, T, H. Capital E, X, P, R. Base value. Expression. Strict. Call expression. Call expression. Identifier name. Let base reference B. Evaluation of call expression. Let base value B. Get value. Base reference. If the source text match by this call expression is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E. Capital P, R, O, P, E, R, T, Y. Capital A, C, C, E, S, S. Capital W, I, T, H. Capital I, D, E, N. Base value. Identifier name. Strict. Call expression. Call expression. Private identifier. Let base reference B. Evaluation of call expression. Let base value B. Get value. Base reference. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. 3, 3, 3. Capital E, V, A, L, U, A, T, E. Capital P, R, O, P, E, R, T, Y. Capital A, C, C, E, S, S. Capital W, I, T, H. Capital E, X, P, R. Base value. Expression. Strict. The abstract operation. Capital E, V, A, L, U, A, T, E. Capital P, R, O, P, E, R, T, Y. Capital A, C, C, E, S, S. Capital W, I, T, H. Capital E, X, P, R. Takes argument space value, any CMA script language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference B. Evaluation of expression. Let property name value B. Get value. Property name reference. Let property key B. To property key, property name value. Return the reference record. Base value. Property key. Strict. This value. Empty. 3, 3, 4. Capital E, V, A, L, U, A, T, E. Capital P, R, O, P, E, R, T, Y. Capital A, C, C, E, S, S. Capital W, I, T, H. Capital I, D, E, N. For key. Base value. Identifier name. Strict. The abstract operation. Capital E, V, A, L, U, A, T, E. Capital P, R, O, P, E, R, T, Y. Capital A, C, C, E, S, S. Capital W, I, T, H. Capital I, D, E, N. Takes argument space value, any CMA script language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name. Return the reference record. Base value, property name string, strict, empty. ECMA International 2024 261. 1 3 3 5 Venue operator. 3 3 5 1 runtime semantics. Evaluation. New expression. New expression. Return. Evaluate new expression, empty, member expression, new member expression, arguments 1. Return. Evaluate new, member expression, arguments 3, 3, 5, 1. 1. Evaluate new, construct expr, arguments. The abstract operation evaluate new takes arguments construct expr, a new expression parse node or remember expression parse node, and arguments, empty or an arguments parse node, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Let ref be. Evaluation of construct expr. Let constructor be. Get value, ref. If arguments is empty, then a let arglist be a new empty list for. Else a let arglist be. Argument list evaluation of arguments. If this constructor is false, throw a type error exception. Return. Constructor, arglist. 3, 3, 6 function calls. 3, 3, 6, 1 runtime semantics. Evaluation. Call expression. Capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital.
Why is it using?
Let expert.
Crap's sake.
I, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Let member expr be the member expression of expr. Let arguments be the arguments of expr. Let ref be. Evaluation of member expr. Let func be. Get value, ref. If ref is a reference record, is proper.
Well,
It's false, and ref.
there's a triangle.
Func, %eval % is true. Then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true. Otherwise, let strict caller be false. V return. Perform eval arg, strict caller, true. Let this call be this call expression. Let tail call be as in tail position. This call return. Evaluate call. Func, ref, arguments. Tail call, a call expression evaluation that executes step 6 AV is a direct eval. Call expression arguments. Let ref be. Evaluation of call expression. Let func be. Get value, ref. Let this call be this call expression. Let tail call be as in tail position. This call return. Evaluate call. Func, ref, arguments. Tail call. 62. ECMA International 2024. 13362. Evaluate call. Func, ref, arguments. Tail, position. The abstract operation evaluate call takes arguments func, an ECMA script language value, ref, an ECMA script language value or a reference record, arguments, a parse node, and tail position, a boolean, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then if is property reference, ref, is true, then I let this value be.
I like how they're like, do you want to pay for chatbot?
Assert.
Chatbot can't do the most basic shit.
Be with base object, else I let this.
How could this stuff be so poorly undocumented
It's not an object.
that chatbot can't even figure it out? What the hell?
Throw a type error exception. If tail position is true, perform prepare for tail call. Return. Call. Func. This value. Arglist. 3, 3, 7 thesaper keyword. 3, 3, 7, 1 runtime semantics. Evaluation super property. Super. Expression. Let env get this environment. Let actual this be env get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key, property name value. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super property. Super. Identifier name. Let env get this environment. Let actual this be env get this binding. Let property key be string value of identifier name. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super call. Super arguments. Let new target be get new target. Assert. New target is an object. Let func be get super constructor. Let arglist be. Argument list evaluation of arguments. If this constructor, func, is false, throw a type error exception. Let result be. Construct. Func. Arglist. New target. Let the ser be get this environment. Perform the ser bind this value. Result. Let f be the ser. 0. Assert. F is an ECMA script function object. 1. Perform. Initialize instance elements. Result. F. 2. Return result. ECMA International 2024 263. 133 7. To get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMA script language value. It performs the following steps when called. Let envrec be get this environment. Assert. envrec is a function environment record. Let active function be envrec. Assert. Active function is an ECMA script function object. Let super constructor be active function. Return super constructor. 3, 3, 7. 3 make super property. Efference. Actual this. Property key. Strict. The abstract operation make super property reference takes arguments actual this, any CMA script language value, property key, and strict, a boolean, and returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. Let env be get this environment. Assert. Env has super binding. Is true. Let base value be env get super base. Return the reference record. Base value. Property key. Strict. This value. Actual this. 3, 8 argument lists. Note the evaluation of an argument list produces a list of values 1, 3, 8, 1 runtime semantics. Argument list evaluation. The syntax directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECF.
Is it moving?
An abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return list. C append next to list. Argument list. Argument list. Assignment expression. 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression.
I can't tell. The colors, like they're not moving. But there's like a teeny fuzzy around it. I don't know. It's being streamed. The colors will look exactly the same.
Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return list. C append next to list. Argument list. Argument list. Assignment expression. 2. Let preceding args be. Argument list evaluation of argument list. Let ref be.
Why is it only entering twice?
International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return preceding args. C append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let cite obj be get template object. Template literal. Return cite obj. Template literal. Substitution template. Let template literal be this template literal. Let cite obj be get template object. Template literal. Let remain in B. Argument list evaluation of substitution template. Return the list concatenation of site obj and remaining. Substitution template. Template head expression template spans. Let first subref be. Evaluation of expression. Let first sub e. Get value. First subref. Letrus sub e. Substitution evaluation of template spans. Assert. Res sub is a possibly empty list. Return the list concatenation of first sub and res sub. 3, 3, 9 optional chains. 3, 3, 9. 1 runtime semantics. Evaluation. Optional expression. Member expression optional chain. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. Let base reference be. Evaluation of call expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accessors and function calls, the first of which begins with the token.
Wait a second.
165. Optional expression. Optional expression option.
Do I call command
of optional expression.
draw with rotation instead?
Base reference. If base value is either undefined or null, then a return undefined. Return.
No, there's no draw it. I didn't put it in.
Base reference. 3, 3, 9. 2 runtime semantics. Chain ev. Evaluation. The syntax directed operation chain evaluation takes arguments base value, any CMA script language value, and base reference, any CMA script language value or a reference record, and returns either a normal completion containing either an ECMA script language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H.
After the pipeline's binded.
R. Base value. Expression. Strict. Optional chain. Identify a name. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E.
Does that make a difference?
U A T E capital P R O P E R T Y capital A C C E S S capital W I T H.
That's only being called twice.
N. Base value. Identify a name. Strict. Optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Optional chain. Optional chain
Oh, this initially makes it.
reference B. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. New value. New reference. Arguments. Tail call. Optional chain. Optional chain. Expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R. New value. Expression. Strict. Optional chain. Optional chain. Identify a name. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N. New value. Identify a name. Strict. 66. ECMA International 2024. Optional chain. Optional chain. Private identifier. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let field name string be the string value of private identifier. Return make private reference. New value. Field name string. The 3rd of March 2010 import calls. 3, 3, 1, 0, 1 runtime semantics. Evaluation. Import call. Import. Assignment expression. Let referrer be get active script or module. If referrer is null, set referrer to the current realm record. Let argraph be. Evaluation of assignment expression. Let specify be. Get value. Argraph. Let promise capability be. New promise capability. Percent promise percent. Let specify a string be completion. To string. Specifier. If abrupt reject promise. Specify a string, promise capability, perform host load imported module, referrer. Specify a string, empty, promise capability, return promise capability, 3, 3, 1, 0, 1, 1 continue dynamic import, promise capability, module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then a perform call, promise capability, undefined, module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call, promise capability, undefined, reason be return unused. Let onRejected be create built-in function, rejected closure, 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module, promise capability, and onRejected and performs the following steps when called. A let link be completion, module link, be if link is an abrupt completion, then I perform call, promise capability, undefined, link 2. Return unused. C let evaluate promise be module evaluate. D let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I let namespace be get module namespace, module 2. Perform call, promise capability, undefined, namespace 3. Return unused. E let unfulfilled be create built-in function, fulfilled closure, 0. F perform promise then, evaluate promise, unfulfilled, unrejected. G return unused. Link and evaluate be create built-in function, link and evaluate closure, 0. Let perform promise then, load promise, link and evaluate, unrejected. Return unused. ECMA International 2024 267. The 13th of March 2011 tag templates. 3, 3, 1, 1, 1 runtime semantics, evaluation, member expression template literal. Let tag ref be. Evaluation of member expression. Let tag func be. Get value. Tag ref. Let this call be this member expression. Let tail call be as in tail po. Session. This call. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. Call expression template literal. Let tag ref be. Evaluation of call expression. Let tag func be. Get value. Tag ref. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Tag func. Tag ref. Template literal, tail call, the 3rd of March 2012 meta properties, 3, 3, 1, 2, 1 runtime semantics, evaluation, new target 1. Return get new target, import meter, import meta, let module be get active script or module, assert, module is a source text module record, let import meter be module, if import meter is empty, then A set import meter to ordinary object create, null, B let import meter values be host get import meter properties, module, C for each record, P of import meter values, do, I perform. Create data property or throw, import meter, P, D perform host finalize import meter, module, E set module to import meter, F return import meter, else, assert, import meter is an object, B return import meter, 3, 3, 1, 2, 1, 1 host get import meter properties, module record, the host define abstract operation host get import meter properties takes argument module record, and returns a list of records with fields, any CMA script language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note to tag template is a function call where the arguments of the call are derived from a template literal 1, 3, 2, 8. The actual arguments include a template object 1, 3, 2, 8, 4, and the values produced by evaluating the expressions embedded within the template literal 68. Copyright sign, ECMA International 2024, 1, 3, 3, 1, 2, 1. To host finalize import meter, module record. The host define abstract operation host finalize import meter takes arguments import meter, an object, and module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties, and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to CMA script code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await.
Ta-da!
Unary expression yield await. 1, 3, 4, 1 static semantics, early errors, update expression, left-hand side expression plus plus, no line terminator here, plus plus, no line terminer, tor here, left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression. It is an early
This is probably wasting memory.
expression is not simple. 3, 4, 2 postfix increment operator 1, 3, 4, 2, 1 runtime semantics, evaluation, update expression, left
Yeah, I could probably like reuse this whatever.
hand side expression.
I don't care right now. Looks like it works. Good enough.
Let new value be number.
Let's get it running.
Value 1 else assert. Old value is a bigint. B let new value be bigint. Add old value 1 z. Perform Put value, LHS, new value, return old value, ECMA International 2024 269, 134, 3 postfix decrement operator 134, 3, 1 runtime semantics, evaluation, update expression, left-hand side expression, let LHS be, evaluation of left-hand side expression, let old value be, denumeric, get value, LHS, if old value is a number, then a let new value be number, subtract, old value, 1, else, assert, old value is a big int, be let new value be big int, subtract, old value, 1z, perform, put value, LHS, new value, return old value, 3, 4, 4 prefix increment operator 1, 3, 4, 4, 1 runtime semantics, evaluation, update expression, plus unary expression, let x be, evaluation of unary expression, let old value be, denumeric, get value, expa, if old value is a number, then a let new value be number, add, old value, 1, else, assert, old value is a big int, be let new value be big int, add, old value, 1z, perform, put value, expa, new value, return new value, 3, 4, 5 prefix decrement operator 1, 3, 4, 5, 1 runtime semantics, evaluation, update expression, unary expression, let x be, evaluation of unary expression, let old value be, denumeric, get value, expa, if old value is a number, then a let new value be number, subtract, old value, 1, else, assert, old value is a big int, be let new value be big int, subtract, old value, 1z, perform, put value, expa, new value, return new value, 70, ECMA International 2024, 13.5 unary operators syntax, unary expression, yield, await, update expression yield await, delete unary expression yield await, void unary expression yield await, type of unary expression yield await plus unary expression yield await, unary expression yield await, unary expression yield await, unary expression yield await, plus await expression yield, 3, 5, 1 the delete operator, 3, 5, 1 static semantics, early errors, unary expression, delete unary expression, it is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression, identifier reference, member expression.
What's it even doing?
Private identifier, call expression, private identifier, optional chain.
It's like out of range.
Or optional ch, optional chain. Private identifier, it is a syntax error if the derived unary expression is primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, and capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3, 5, 1, to runtime semantics, evaluation, unary expression, delete unary expression, let ref be. Evaluation of unary expression, if ref is not a reference record, return true. If is unresolvable reference, ref is true, then assert, ref is false, be return true. If is property reference, ref is true, then assert, is private reference, ref is false, be if is super reference, ref is true, throw a reference error exception, c let base obj be, to object, ref, d let delete status be base obj, ref, e if delete status is false and ref is true, throw a type error exception, f return delete status, else a let base be ref, b assert, base is an environment record, c return base delete binding, ref. The last rule means that expressions such as delete foo produce early errors because, note, of recursive application of the first rule, ECMA International 2024 271. Note 1 when a delete operator occurs within strict mode code, a syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note 2 the object that may be created in step 4c is not accessible outside of the above abstract operation in the ordinary object internal method. An implementation might choose to avoid the actual creation of that object. 3, 5, 2 avoid operator. 3, 5, 2, 1 runtime semantics, evaluation, unary expression, void unary expression, let x be. Evaluation of unary expression, perform. Get value, expa, return undefined. 3, 5, 3 the tipiaf operator. 3, 5, 3, 1 runtime semantics, evaluation, unary expression, type of unary expression, let val be. Evaluation of unary expression, if val is a reference record, then if is unresolvable reference, val is true.
Hey, floats. Floats suck.
Val, if val is undefined, return
Why
undefined.
is he even giving me a float?
If val is a string, return string. If val is a symbol, return symbol. If val is a boolean, return boolean. If val is a number, return number. 0. If val is a big int, return big int. 1. Assert. Val is an object. 2. Note, the step is replaced in section B. 3, 6, 3. 3. If val has an internal slot, return function. 4. Return object. 3, 5, for unary plus operator. Note the unary plus operator converts its operand to number type. Note get value must be called even though its value is not used because it may have observable side effects. 272. ECMA International 2024. 1354. 1 runtime semantics. Evaluation. Unary expression plus unary expression. Let x be. Evaluation of unary expression. Return to number. Get value. Expa 3 5 5 unary operator 3 5 5 1 runtime semantics. Evaluation. Unary expression. Unary expression. Let x be. Evaluation of unary expression. Let old value be. Denumeric. Get value. Expa if old value is a number, then a return number. Unary minus old value 4. Else AB. Assert. Old value is a big int. Return big int. Unary minus old value. The unary operator converts its operand to a numeric value and then negates it. Negating plus 0. Note, produces minus 0. And negating minus 0 produces plus 0. Bitwise not operator. Unary expression. Unary expression. 3 5 6 3 5 6 1 runtime semantics. Evaluation. Let x be. Evaluation of unary expression. Let old value be. The numeric. Get value. Expa if old value is a number, then a return number. Bitwise not. Old value 4. Else AB. Assert. Old value is a big int. Return big int. Bitwise not. Old value. Logical not operator. Unary expression. Unary expression. 3 5 7 3 5 7 1 runtime semantics. Evaluation. Let x be. Evaluation of unary expression. Let old value be to boolean. Get value. Expa if old value is true. Return false. Return true. 3.6 exponentiation operator syntax. Exponentiation expression. Yield. Await. Unary expression yield await. Update expression yield await. Exponentiation expression yield await. ECMA International 2024 273. 136. 1 runtime semantics. Evaluation. Exponentiation expression. Update expression. Exponentiation expression. Return. Capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E update expression exponentiation expression 3.7 multiplicative operators syntax multiplicative expression yield await exponentiation expression yield await multiplicative expression yield await multiplicative operator exponentiation expression yield await multiplicative operator 1 of percent 3 7 1 runtime semantics evaluation multiplicative expression multiplicative
It's not 3 times per second.
matched by multiplicative operator.
It's a whole lot of times per second.
A L U
It's like,
E
holy crap, Chatbot sucks.
G capital O R capital N U M E R I C capital B I N A R Y capital E multiplicative expression text exponentiation expression 3.8 additive operators syntax additive expression yield await multiplicative expression yield await additive expression yield await plus multiplicative expression yield await additive expression yield await multiplicative expression yield await 3 8 1 the addition operator plus note the addition operator either performs string concatenation or numeric addition 3 8 1 1 runtime semantics evaluation additive additive expression plus multiplicative expression return capital E V A L U A T E capital S T R I
Why is Chatbot so dumb?
capital N U M E R I C capital B I N A R Y capital E additive expression plus multiplicative expression. Note, the operator performs multiplication, producing the product of its operands. The operator performs division, producing the quotient of its operands. The percent operator yields the remainder of its operands from an implied division. 274. Copyright sign, ECMA International 2024.
Ta-da!
Fraction operator.
Chatbot is literally so dumb.
Additive expression, multiplicative expression. Return. Capital E.
Oh wait, no.
U.
I did say 3 times per second.
Capital S. T. R. I. N. G. Capital O.
Wouldn't that just be times 3 then?
U. M. E. R. I. C. Capital B. I. N. A. R.
Yeah, why is it multiplying by 6.28?
Multiplicative expression 3.9 bitwise shift operators syntax shift expression yield await additive expression yield await 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 3 9 1 the left shift operator 3 9 1 1 runtime semantics evaluation shift expression additive expression return capital E V A L U N
Yeah, I don't know.
T R I N G
Whatever Chatbot's doing with math here.
N U M E R I
Chip has the control, I'm just
N,
trying to put it all together.
Y,
I really don't care about the video card.
additive expression, 3, 9, to the signed right shift operator, 3, 9, 2, 1 run.
So, I gotta make it quad.
Additive expression,
Paint the freaking image on it.
A, L, U,
I think I got it. This time, it's gonna work.
R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression, 3, 9, 3 the unsigned right shift operator. Note, the operator performs subtraction, producing the difference of its operands. Note performs a bitwise left shift operation on the left operand by the amount specified by the right operand. Note performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. Note performs a zero filling bitwise right shift operation on the left operand by the amount specified by the right operand. ECMA International 2024 275 1393 1 runtime semantics evaluation shift expression additive expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E shift expression additive expression 3.10 relational operators syntax relational expression in yield await shift expression yield await relational expression in yield 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 await shift expression yield await await shift expression yield await await equals shift expression yield await await equals shift expression yield await await instantia. Note 1 the result of evaluating a relational operator is always of type boolean, reflecting whether the relationship named by the operator holds between its two operands. Shift expression yield await plus in relational expression plus in yield await in shift expression yield await plus in private identifier in S shift expression yield await 3 1 0 1 runtime semantics evaluation relational expression shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref letter B is less than val true if R is undefined return false otherwise return R relational expression shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref letter B is less than val false if R is undefined return false otherwise return R relational expression equals shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref letter B is less than val false if R is either true or undefined return false otherwise return true 276 ECMA International 2024 note 2 the in grammar parameter is needed to avoid confusing the in operator in a relational expression with the in operator in a for statement relational expression equals shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref letter B is less than val true if R is either true or undefined return false otherwise return true relational expression instantia of shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref return instantia of operator val relational expression in shift expression letter FB evaluation of relational expression letter val B get value ref letter FB evaluation of shift expression letter val B get value ref if val is not an object throw a type error exception return has property revel to property key val relational expression private identifier in shift expression let private identifier be the string value of private identifier letter FB evaluation of shift expression letter val B get value ref if val is not an object throw a type error exception let private TNV be the running execution context's private environment let private name be resolved private identifier private TNV private identifier if private element find val private name is not empty return true return false 3 1 0 2 instantia of operator v target the abstract operation instantia of operator takes arguments v any CMA script language value and target any CMA script language value and returns either a normal completion containing a boolean or a throw completion it implements the generic algorithm for determining if v is an instance of target either by consulting target sat at has instance method or if absent determining whether the value of target's prototype property is present in v's prototype chain it performs the following steps when called if target is not an object throw a type error exception let inst of handler be get method target at has instance if inst of handler is not undefined then a returns a boolean call, inst of handler, target, v, if is callable, target, is false, throw a type error exception, return, ordinary has instance, target, v. Note steps 4 and 5 provide compatibility with previous editions of ECMA script that did not use a @@ has instance method to define the instantia operator semantics. If an object does not define or inherit @@ has instance, it uses the default instantia of semantics. ECMA International 2024 277, 13.11 Equality operators, syntax, equality expression, in, yield, await, relational expression in yield await, equality expression in yield await, equals relational expression in yield await, equality expression in yield await equals relational expression in yield await, equality expression in yield await, equals relational expression in yield await, equality expression in yield await equals relational expression in yield await. 3, 1, 1, 1 runtime semantics, evaluation, equality expression equals relational expression, letter FB, evaluation of equality expression, letter val B, get value, ref, letter FB, evaluation of relational expression, letter val B, get value, ref, return, is loosely equal, val, equality expression equals relational expression, letter FB, evaluation of equality expression, letter val B, get value, ref, letter FB, evaluation of relational expression, letter val B, get value, ref, letter B, is loosely equal, val, if R is true, return false, otherwise, return true, equality expression equals relational expression, letter FB, evaluation of equality expression, letter val B, get value, ref, letter FB, evaluation of relational expression, letter val B, get value, ref, return is strictly equal, val, equality expression equals relational expression, letter FB, evaluation of equality expression, letter val B, get value, ref, letter FB, evaluation of relational expression, letter val B, get value, ref, let R be is strictly equal, val, if R is true, return false, otherwise, return true. 278, ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1, given the above definition of equality, string comparison can be F, forced by, $, equals $, B, numeric comparison can be forced by, plus equals plus B, Boolean comparison can be forced by equals B. Note 2, the equality operators maintain the following invariants. Up equals B is equivalent to up equals B, up equals B is equivalent to B equals A, except in the order of evaluation of A and B. Note 3, the equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string equals A and A equals new string are both true. New string equals new string is false. Note 4, comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 3.12 binary bitwise operators syntax, bitwise and expression, in, yield, await, equality expression in yield await, bitwise and expression in yield await, and equality expression in yield await, bitwise or expression, in, yield, await, bitwise and expression in yield await, bitwise or expression in yield await, bitwise and expression in yield await, bitwise or expression, in, yield, await, bitwise or expression in yield await, bitwise or expression in yield await, bitwise or expression in yield await. 3, 1, 2, 1 runtime semantics, evaluation, bitwise and expression and equality expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, bitwise and expression, and equality expression. ECMA International 2024 279, bitwise or expression, bitwise and expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, bitwise or expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, bitwise or expression, 3.13 binary logical operators syntax, logical and expression, in, yield, await, bitwise or expression in yield await, logical and expression in yield await, and bitwise or expression in yield await, logical or expression in yield await, logical and expression in yield await, logical or expression in yield await, logical and expression in yield await, coalesce expression in yield await, coalesce expression head in yield await, bitwise or expression in yield await, coalesce expression head in yield await, coalesce expression in yield await, bitwise or expression in yield await, short circuit expression in yield await, logical or expression in yield await, coalesce expression in yield await. 1 runtime semantics, evaluation, logical and expression and bitwise or expression, letter of B, evaluation of logical and expression, letter val B, get value, ref, let a bool be to boolean, val, if a bool is false, return val, letter F B, evaluation of bitwise or expression, return, get value, ref, logical or expression, logical and expression, letter of B, evaluation of logical or expression, letter val B, get value, ref, let a bool be to boolean, val, if a bool is true, return val, letter F B, evaluation of logical and expression, return, get value, ref, 280, ECMA International 2024, the value produced via and or operator is not necessarily of type boolean. The value produced, note, will always be the value of one of the two operand expressions, coalesce expression head, bitwise or expression, letter of B, evaluation of coalesce expression head, letter val B, get value, ref, if a val is either undefined or null, then a letter of B, evaluation of bitwise or expression, be return, get value, ref, else, a returnal val, 3.14 conditional operator, syntax, conditional expression, in, yield, await, short circuit expression in yield await, short circuit expression in yield await, assignment expression, plus in yield await, assignment expression in yield await, 3.14, 1 runtime semantics, evaluation, conditional expression, short circuit expression, assignment expression, letter of B, evaluation of short circuit expression, let val be to boolean, get value, ref, if val is true, then a let true ref B, evalu, false ref. Note the grammar for a conditional expression in ECMA script is slightly different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMA script is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. ECMA International 2024 281 13.15 assignment operators syntax, assignment expression, in, yield, await, conditional expression in yield await, plus yield, yield expression in await, arrow function in yield await, arrow function in yield await, left-hand side expression yield await, equals assignment expression in yield await, left-hand side expression yield await, assignment operator assignment expression in yield await, left-hand side expression yield await, and equals assignment expression in yield await, left-hand side expression yield await, equals assignment expression in yield await, left-hand side expression yield await equals assignment expression in yield await, assignment operator, 1 of, equals percent equals plus equals equals 3 1 5 1 static semantics, early errors, assignment expression, left hand side expression equals assignment expression, if left hand side expression is either an object literal or an array literal, the following early error rules are applied. Left hand side expression must cover an assignment pattern. If left hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left hand side expression is not simple. Assignment expression, left hand side expression, assignment operator assignment expression, left hand side expression and equals assignment expression, left hand side expression equals assignment expression, left hand side expression equals assignment expression. It is a syntax error if assignment target type of left hand side expression is not simple. 3 1 5 2 runtime semantics, evaluation, assignment expression, left hand side expression equals assignment expression. 82. If left hand side expression is neither an object literal nor an array literal, then a letter of B. Evaluation of left hand side expression, B if is anonymous function definition, assignment expression, and is identifier ref of left hand side expression are both true, then I letter val B. Named evaluation of assignment expression with argument ref, C else, I letter F B. Evaluation of assignment expression, 2. Letter val B. Get value, ref, D perform. Put value, ref. Reval, E return reval. Let assignment pattern be the assignment pattern that is covered by left-hand side expression. ECMA International 2024. 3. Letter F B. Evaluation of assignment expression. Letter val B. Get value, ref, perform. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, of assignment pattern with argument reval, return reval, assignment expression, left-hand side expression, assignment operator, assignment expression, letter F B. Evaluation of left-hand side expression, letter val B. Get value, ref, letter F B. Evaluation of assignment expression, letter val B. Get value, ref. Let assignment optext be the source text matched by assignment operator. Let optext be the sequence of Unicode code points associated with assignment optext in the following table. Assignment optext equals percent plus equals and equals. Let R B. capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, op text, val, perform, put value, ref, R, return R, assignment expression, left-hand side expression and equals assignment expression, letter F B, evaluation of left-hand side expression, letter val B, get value, ref, let bool be to boolean, val, if a bool is false, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a letter val B, named evaluation of assignment expression with argument ref, else a letter of B, evaluation of assignment expression, B let val B, get value, ref, perform, put value, ref, reval, return reval, assignment expression, left-hand side expression equals assignment expression, letter FB, evaluation of left-hand side expression, letter val B, get value, ref, let bool be to boolean, val, if a bool is true, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a letter val B, named evaluation of assignment expression with argument ref 6, else a letter of B, evaluation of assignment expression, B let val B, get value, ref, ECMA International 2024 283, 7, perform, put value, ref, reval, return reval, assignment expression, left-hand side expression equals assignment expression, letter FB, evaluation of left-hand side expression, letter val B, get value, ref, if a val is neither undefined nor null, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a letter val B, named evaluation of assignment expression with argument ref, else a letter of B, evaluation of assignment expression, B let reval B, get value, ref, perform, put value, ref, reval, return reval, 3, 1, 5, 3, capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, op text, reval, the abstract operation, capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, takes arguments of val, any CMA script language value, op text, comma percent, plus, or, and reval, any CMA script language value, and returns either a normal completion containing either a string, a begint, or a number, or a throw completion. It performs the following steps when called. If op text is plus, then a letter from B. To primitive, val, B letter from B. To primitive, reval, see if a prim is a string or reprim is a string, then I let lst rb. To string, or prim 2. Let rst rb. To string, reprim 3. Return a string concatenation of lst r and rst r. D set of val to prim, e set reval to reprim. Note, at this point, it must be a numeric operation. Letter num B. To numeric, val, letter num B. To numeric, reval, if type, num, is not type, renum. Throw a type error exception. If num is a big int, then, note when this expression occurs within strict mode code, it is a runtime error if ref in step 1D, 2 is an unresolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the ref in step 8, 7, 6 is a reference to a data property with the attribute value, false, to an accessor property with the attribute value, e-value false. In these cases a type error exception is thrown. ABCD, let if op text is, return, begint, exponentiate, num, renum, if op text is comma return, begint, divide, num, renum, if op text is percent, return, begint, remainder, num, renum, if op text is, return, begint, and signed right shift, num, renum, operation be the abstract operation associated with op text and type, num, in the following table, 84, ECMA International 2024, op text type, num, operation, number, exponentiate number, multiply begint, multiply number, divide number, remainder number, add, percent plus, number big int number, op text type, num plus big int, number big int, number big int, number big int, comma number big int, number big int, number big int, operation, big int, add number, subtract big int, subtract number, left shift big int, left shift number, signed right shift big int, signed right shift number, and signed right shift number, bitwise and big int, bitwise and number, bitwise or big int, bitwise or number, bitwise or big int, bitwise or return operation, num, renum. Note 1 no hint is provided in the calls to primitive in steps 1A and 1B. All standard objects except dates handle the absence of a hint as if number were given, dates handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2 step 1C differs from step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, left operand, op text, right operand. The abstract operation, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, takes arguments left operand, a parse node, op text, a sequence of Unicode code points, and right operand, a parse node, and returns either a normal completion containing either a string, a big int, or a number, or an abrupt completion. It performs the following steps when called. Letter FB. Evaluation of left operand. Letter val B. Get value. Ref. Letter FB. Evaluation of right operand. Letter val B. Get value. Ref. Return. Capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, op text, val, 3, 1, 5. 5. Destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production, assignment expression, left-hand side expression equals assignment expression. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern, yield, await. Object assignment pattern yield await. Array assignment pattern yield await. ECMA International 2024 285. Object assignment pattern, yield, await. Assignment dress property yield await. Assignment property list yield await. Assignment property list yield await. Assignment dress property yield await opt. Array assignment pattern, yield, await. Eligible assignment dressed element yield await opt. Assignment element list yield question mark await. Assignment element list yield await. Eligible assignment dressed element yield await opt. Assignment dress property yield await dot. Destructuring assignment target yield await. Assignment property list yield await. Assignment property yield await. Assignment property list yield await. Assignment property yield await. Assignment element list yield await. Assignment elision element yield await. Assignment element list yield await. Assignment elision element yield await. Assignment elision element yield await. Elision assignment element yield await. Assignment property yield await. Identifier reference yield await. Initializer class in yield await opt. Property name yield await. Assignment element yield await. Assignment element yield await. Destructuring assignment target yield await. Initializer class in yield await opt. Assignment dressed element yield await dot. Destructuring assignment target yield.
Alright, so now
Target yield await. Left hand side expression yield await. 3, 1, 5, 5. 1 static semantics. Early errors. Assignment.
I got this triangle, whatever.
It is a syntax error if assignment target type of identifier reference is not simple. Assignment dress property. Destructuring.
And I removed all the quad stuff
Assignment target is either an array literal or an object literal.
and duplicated the other one.
Side expression. If left hand side expression is either an object literal or an array literal, the following early error rules.
So I chatbot to modify this one
If left hand side expression
to make a quad.
or an array literal, the following early error rule is
If I break it, have it back up.
ECMA International 2024. Comma it is a syntax.
Oh, I just want to be done.
Hand side expression is not simple. 1, 3, 1, 5, 5. To runtime semantics. Capital D, E, F,
It's Bob.
U,
Surbab.
U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T. The syntax directed operation. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, takes argument value, any CNA script language value, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Object assignment pattern. Perform. Require object collapsible. Value. Return unused. Object assignment pattern. Assignment property list. Assignment property list. Perform. Require object collapsible. Value. Perform. Capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment property list with argument value. Return unused. Object assignment pattern. Assignment dress property. Perform. Require object collapsible. Value. Let excluded names be a new empty list. Return. Capital R, E, S, T, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, capital EVA, of assignment dress property with arguments value and excluded names, object assignment pattern, assignment property list, assignment dress property, perform, require object coercible, value, let excluded names be, property destructuring the assignment evaluation of assignment property list with argument value, return, capital REST, capital DESTRUCTURING, capital ASSIGNMENT, capital EVA, of assignment dress property with arguments value and excluded names, array assignment pattern, let iterator record B, get iterator, value, sync, return, iterator close, iterator record, normal completion, unused, array assignment pattern, elision, let iterator record B, get iterator, value, sync, let result be completion, iterator destructuring assignment evaluation of elision with argument, iterator record, if iterator record is false, return, iterator close, iterator record, result, return result, array assignment pattern, elision or assignment dressed element, let iterator record be, get iterator, value, sync, if elision is present, then, a let status be completion, iterator destructuring assignment evaluation of elision with argument iterator record, b if status is an abrupt completion, then, I assert, iterator record is true, 2. Return status, let result be completion, iterator destructuring assignment evaluation of assignment dressed element with argument iterator record, ECMA International 2024 287, 4. If iterator record is false, return, iterator close, iterator record, result, return result, array assignment pattern, assignment element list, let iterator record be, get iterator, value, sync, let result be completion, iterator destructuring assignment evaluation of assignment element list with argument iterator record, if iterator record is false, return, iterator close, iterator record, result, return result, array assignment pattern, assignment element list, elision or assignment dressed element opt, let iterator record be, get iterator, value, sync, let status be completion, iterator destructuring assignment evaluation of assignment element list with argument iterator record, if status is an abrupt completion, then, if iterator record is false, return, iterator close, iterator record, status, be return status, if elision is present, then, assert status to completion, iterator destructuring assignment evaluation of elision with argument iterator record, b if status is an abrupt completion, then, I assert, iterator record is true, 2. Return status, if assignment dressed element is present, then, assert status to completion, iterator destructuring assignment evaluation of assignment dressed element with argument iterator record, if iterator record is false, return, iterator close, iterator record, status, return status, 3, 1 5, 5, 3 runtime semantics, capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, the syntax directed operation, capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, takes argument value, any CNA script language value, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list of all the structured property keys. It is defined piecewise over the following: G productions, assignment property list, assignment property list, assignment property. Let property names be capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment property list with argument value. Let next names be capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property, identifier reference initializer opt. Let P be string value of identifier reference. Let ref be resolve binding. P, let V be jet value. P, if initializer is present and V is undefined, then if is anonymous function definition, initializer, is true, then I set V2. Named evaluation of initializer with argument P, B else, I let default value be. Evaluation of initializer, 2. Set V2. Get value, default value, perform. Put value, ref. V, return P, 88, ECMA International 2024, assignment property, property name, assignment element, let name be. Evaluation of property name, perform. Capital K, E, Y, E, D, capital D, E, S, T R U C T U R I N G, capital A S S I G N M E N T, capital E V, of assignment element with arguments value and name. Return name 3155 for runtime semantics. Capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A. The syntax directed operation, capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A, takes arguments value, an ECMA script language value, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment dress property, destructuring assignment target, letter FB, evaluation of destructuring assignment target, let rest obj be ordinary object create, %object prototype %perform, copy data properties, rest obj, value, excluded names, return, put value, rest obj, 3155, 5 runtime semantics, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N. The syntax directed operation, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, takes argument iterator record, an iterator record, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment element list, assignment elision element, return, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment elision element with argument iterator record, assignment element list, assignment element list, assignment elision element, perform, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment element list with argument iterator record, return, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment elision element with argument iterator record, assignment elision element, assignment element, return, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment element with argument iterator record, assignment elision element, elision assignment element, perform, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of elision with argument iterator record, return, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment element with argument iterate or record elision. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true. C return if abrupt. Next. D if next is false, set iterator record to true. Return unused. Elision. Elision. Perform. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S of elision with argument iterator record. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true. ECMA International 2024 289. C return if abrupt. Next. D if next is false, set iterator record to true 3. Return unused. Assignment element. Destructuring assignment target initial is opt. If destructuring assignment target is neither an object literal nor an array literal, then elect if B. Evaluation of destructuring assignment target. Let value be undefined. If iterator record is false, then elect next B. Iterator step value. Iterator record. B if next is not done, then I set a value to next. If initializer is present and value is undefined, then A if is anonymous function definition. Initializer is true and is identifier ref of destructuring assignment target is true, then I let VB. Named evaluation of initializer with argument ref B else. I let default value B. Evaluation of initializer 2. Let VB. Get value, default value, else a let VB value. If destructuring assignment target is either an object literal or an array literal, then a let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Be return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument V return. Put value ref V assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then elect ref B. Evaluation of destructuring assignment target. Let A be. Array create. 0. Let 0. Repeat. While iterator record is false, elect next B. Iterator step value. Iterator record. B if next is not done, then I perform. Create data property or throw A. To string n. Next 2. Set n to n plus 1. If destructuring assignment target is neither an object literal nor an array literal, then a return. Put value ref A. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Return. Capital D E S T R U C T.
Okay, so like
N.
the lack of the modern C compiler's ability to optimize things.
E. Capital
Well, it's not really the lack.
U A.
It's because it's C language and it can really only optimize so far
A E.
because of the way the language is set up.
Capital D E S
So it's also a language, but the C compiler sucks.
R I
So like there's no point in optimizing.
A S
So I got all optimizing out of my system.
T
I bit my tongue again.
this
So it's hard to talk.
E Y
You know, I really bit my tongue.
S T R
It's like I bit my tongue
R I N
eating once and then like I keep fucking biting the same damn spot.
capital E V
So maybe if I like didn't talk for a week and it healed,
E and returns
I wouldn't bite it. But like freaking,
piecewise over TH. E following product.
it's like, yeah.
If destructuring assignment target is neither
Anyways,
ref B. Evaluation of destructuring
all I gotta do is make a quad.
jet value property name. If
Turn this rotating spinny thing into a quad.
2024. Note left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. If is anonymous function definition.
Then put the desktop on it. And then put the video overlay.
S value B. Named evaluation.
I really want to get distracted.
I let
I
default
want to do something else.
of initializer. 2. Let RHS value B. Get value.
But I'm gonna stay on track.
RHS value BV. If destructuring assignment target is either an object literal or an array literal, then a let assignment pattern.
This is so boring though, I can't take it.
Capital D E S T R U C T U R I
I think that music thing was called Strudel.
S I G N M E N T capital E V A L U A T of assignment pattern with argument RHS value. Return. Put value.
That's like a strudel.
3.16 comma operator. Syntax. Expression. In. Yield. Await. Assignment expression in yield await. Expression in yield await. Assignment expression in yield await. 1316. 1 runtime semantics. Evaluation. Expression. Expression. Assignment expression. Let ref B. Evaluation of expression. Perform. Get value. Ref. Let ref B. Evaluation of assignment expression. Return. Get value, ref, for ECMA script language, statements and declarations syntax,
Should we just do some Mac?
block statement yield await return, variable statement yield await, empty statement expression statement yield await, if statement yield await return, breakable statement yield await return, continue statement yield await, break statement yield await, plus return, return statement yield await, with statement yield await return, labeled statement yield await.
Yeah, this will be a huge distraction. I'm gonna stay on track. I'll do that later. If only this was more interesting. Oh my god, I gotta focus. I can't. This is so boring. Holy crap. I can't take it. Why is it so choppy? It's like tearing. It's one triangle. Why is it tearing? Oh man, this sucks. Alright, I'm gonna step out and make it a quad. Try to focus. So let's chat button. Make a new chat. How do I make this? From a triangle into a quad. And on chatbot, and I want to put this screen capture frame onto the quad. I need, not want, need. I'm going to specify a chatbot. Okay, I need this to be optimal. Why can't text-to-speech work? Why? Why can't it work?
Return. Yield. Undefined. Yield expression. Yield assignment expression. Let x the ref.
Okay, I think it's working.
Expression. Let value be. Get value. X the ref. Return. Yield. Value. Yield expression. Yield assignment expression. Let generator kind be. Get generator kind. Let x the ref be. Evaluation of assignment expression. Let value be. Get value. X the ref. Let iterator record be. Get iterator.
That's a distraction.
Let iterator be. Iterator record. Let received be normal complete.
I'm gonna focus on this.
Note the binding identifier in a generator expression can be referenced from inside the generator expression's function body to allow the generator code to call itself recursively. However, unlike in a generator declaration, the binding identifier in a generator expression cannot be referenced from and does not affect the scope enclosing the generator expression. 38. ECMA International 2024. A. B. If received is a normal completion, then I let in a result B. Call. Iterator record. Iterator record. Received 2. If generator kind is async, set in a result 2.
I don't care about spelling. I really don't care.
Object. Throw a type error exception.
So I'm not gonna spell check that.
Result. V.
I already know that it's spelled already.
Iterator value.
But I like putting 2 L's.
Generator kind of.
It's like all ready.
Iterator value.
I don't know, I just misled with this.
Else. Set receive to completion. Generator yield.
And this one's mixed up.
Completion. Then I2. Last throw.
So whatever.
Iterator. Throw. If throw is not undefined, then 2, 3, 5. Let in a result be. Call. Throw. Iterator.
Just lost my train of thought.
Set in a result 2. Await. In a result. Note. Exceptions from the inner iterator throw method are propagated. Normal completions from an inner throw method are processed similarly to an inner next. If in a result is not an object, throw a type error exception. Let done be. Iterator complete. In a result. 15.6 syntax. If done is true, then a return. Iterator value. In a result. If generator kind is async, set receive to completion. Async generator yield. Iterator value. In a result. Else. Set receive to completion. Generator yield. In a result. 3. Else. Note. If iterator does not have a throw method, this throw is going to terminate the yield loop. But first we need to give iterator a chance to clean up. Let close completion be completion record. Normal. Empty. Empty. If generator kind is async. Perform. Async iterator close. Iterator record. Close completion. Else. Perform. Iterator close. Iterator record. Close completion. Note. The next step throws a type error to indicate that there was a yield protocol violation. Iterator does not have a throw method 6. Throw a type error exception. See else. I assert. R. Received is a return completion. 2. Let return be. Get method. Iterator. Return 3. If return is undefined, then set value to received. If generator kind is async, then a set value to. Await. Value. Return completion record. Return. Value. Empty. I've. Let in a return result be. Call. Return. Iterator. Received. V. If generator kind is async, set in a return result 2. Await. In a return result V. If in a return result is not an object, throw a type error exception. 7. Let done be. Iterator complete. In a return result 8. If done is true, then set value to. Iterator value. In a return result. Return completion record. Return. Value. Empty. 9. If generator kind is async, set receive to completion. Async generator yield.
Iteratorvalget innerert resultat.
Else. Set receive to completion. Generator yield. In a return result. Async generator function definitions. Async generator declaration. Yield. Await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Class yield. Class await. Async generator body. Class default. Async. No line terminator here. Function. Formal parameters. Class yield. Class await. Async generator body. Async generator expression. Async. No line terminator here. Function binding identifier. Class yield. Class await opt. formal parameters, class yield, class await, async generator body, async generator method, yield, await, async. No line terminator here, class element name yield await, unique formal parameters, class yield, class await, async generator body, function body, class yield, class await, ECMA International 2024, 39. Note 1 yield expression and await expression cannot be used within the formal parameters of an async generator function because any expressions that are part of formal parameters are evaluated before the resulting async generator is in a reasonable
So I'm saying this is not possible.
to async generators are defined in 2.7.6.3.1.5.6.
Screen capture map once to staging buffer, then transfer to GPU image.
Unique formal parameters, async generator body. It is a syntax error if his direct super of async generator method is true. It is unique formal parameters contains yield expression is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if function body contains use strict of async.
I say it has to copy.
Unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of async generator body.
It has to copy to get the display buffer to
Formal parameters, async generator body, async function, formal parameters,
to the X image.
expression, async function binding identity locked, formal para, meters, async generator
I can't make it use mapped memory.
strict mode code. The early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text matched by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict of async generator body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of async generator body. It is a syntax error if formal parameters contains yield expression is true. It is a syntax error if formal parameters contains await expression is true. It is a syntax error if formal parameters contains super property is true. It is a syntax error if async generator body contains super property is true. It is a syntax error if formal parameters contains super call is true. It is a syntax error if async generator body contains super call is true. 5, 6.
The rest should be possible.
Evaluate async generator body. The syntax directed operation evaluate async generator body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns a throw completion or a return completion. It is defined piecewise over the following productions. Async generator body, function body, perform. Capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, function object, arguments list. Let generator be. Ordinary create from constructor, function object, percent async generator function prototype percent, async generator context, set generator to empty, perform async generator start, generator, function body, return completion record, return, generator, empty, 40, ECMA International 2024, 156, 3 runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C. Tax directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C.
It doesn't have to unmap every single frame.
Private env, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions. Async generator declaration, async function binding identifier, formal parameters, async generator body, let name be string value of binding identifier, let source text be the source text matched by async generator declaration, let f be ordinary function create, percent async generator function prototype percent, source text, formal parameters, async generator body, non-lexical this, env, private env, perform set function name, f, name, let prototype be ordinary object create, percent async generator function prototype percent, perform, define property or throw, f, prototype, property descriptor, prototype, t, ru, false, false, return f, async generator declaration, async function, formal parameters, async generator body, let source text be the source text matched by async generator declaration, let f be ordinary function create, percent async generator function prototype percent, source text, formal parameters, async generator body, non-lexical this, env, private env, perform set function name, f, default, let prototype be ordinary object create, percent async generator function prototype percent, perform, define property or throw, f, prototype, property descriptor, prototype, true, false, false, return f, 5, 6, for runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, T. The syntax directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions: async generator expression, async function, formal parameters, async generator body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by async generator expression. Let closure be ordinary function create. Async generator function prototype source text, formal parameters, async generator body, non-lexical this. env, private env, perform set function name, closure, name. Let prototype be ordinary object create. Async generator function prototype perform. Define property or throw, closure, prototype, property descriptor, prototype, writable, true, false, return closure, async generator expression, async function binding identifier, formal parameters, async generator body, assert, name is not present, set name to string value of binding identifier. Let outreenv be the running execution context's lexical environment. Let funkenv be new declarative environment. Outreenv, perform funkenv create immutable binding, name, false. An anonymous async generator declaration can only occur as part of an export default. Note, declaration, ECMA International 2024 341, 6. Let private env be the running execution context's private environment. Let source text be the source text matched by async generator expression. Let closure be ordinary function create. Async generator function prototype source text, formal parameters, async generator body, non-lexical this. Funkenv, private env, perform set function name, closure, name, 0. Let prototype be ordinary object create. Async generator function prototype 1. Perform. Define property or throw, closure, prototype, property descriptor, prototype, writable, true, false, dart. 2. Perform funkenv initialize binding, name, closure. 3. Return closure. 5, 6. 5 runtime semantics, evaluation, async generator expression, async function binding identity locked, formal parameters, async generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, of async generator expression. 5.7 Class definition syntax. Class declaration, yield, await, default. Class binding identifier yield await. Class tail yield await. Class default. Class tail yield await. Class expression, yield, await. Class binding identifier yield await op. Class tail yield await. Class tail, yield, await. Class heritage yield await op. Class body yield await opt. Class heritage, yield, await. Extends left-hand side expression yield await. Class body, yield, await. Class element list yield await. Class element list, yield, await. Class element yield await. Class element list yield await. Class element yield await. Class element, yield, await. Method definition yield await. Static method definition yield await. Field definition yield await. Static field definition yield await. Class static block. Note the binding identifier in an async generator expression can be referenced from inside the async generator expression's async generator body to allow the generator code to call itself recursively. However, unlike in an async generator declaration, the binding identifier in an async generator expression cannot be referenced from and does not affect the scope enclosing the async generator expression. 42. ECMA International 2024. Field definition, yield, await. Class element name yield await. Initializer, class in yield await opt. Class element name, yield, await. Property name yield await. Private identifier class static block, static. Class static block body, class static block body, class static block statement list, class static block statement list, yield, class await, return op. Note a class definition is always strict mode code. 5, 7, 1 static semantics, early errors, class tail, class heritage art. Class body. It is a syntax error if class heritage is not present in the following algorithm returns true. Let constructor be constructor method of class body. If constructor is empty, return false. Return has direct super of constructor. Class body, class element list. It is a syntax error if prototype property name list of class element list contains more than one occurrence of constructor. It is a syntax error if private bound identifiers of class element list contains any duplicate entries, unless the name is used once for a getter and once for a setter and in no other entries, and the getter and setter are either both static or both non. Static, class element, method definition. It is a syntax error if prop name of method definition is not constructor and has direct super of method definition is true. It is a syntax error if prop name of method definition is constructor and special method o. F method definition is true. Class element, static method definition. It is a syntax error if has direct super of method definition is true. It is a syntax error if prop name of method definition is prototype. Class element, field definition. It is a syntax error if prop name of field definition is constructor. Class element, static field definition. It is a syntax error if prop name of field definition is either prototype or constructor. Field definition. Class element name initial is rot. It is a syntax error if initializer is present and contains arguments of initializer as true. Copyright sign, ECMA International 2024 343, comma it is a syntax error if initializer is present and initializer contains supercall as true. Class element name, private identifier. It is a syntax error if string value of private identifier is constructor. Class static block body, class static block statement list. It is a syntax error if the lexically declared names of class static block statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of class static block statement list also occurs in the var declared names of class static block statement list. It is a syntax error if contains duplicate labels of class static block statement list with argument is true. It is a syntax error if contains undefined break target of class static block statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of class static block statement list with arguments and is true. It is a syntax error if contains arguments of class static block statement list is true. It is a syntax error if class static block statement list contains supercall is true. It is a syntax error if class static block statement list contains await is true. 5, 7, 2 static semantics. Class element kind. The syntax directed operation class element kind takes no arguments and returns constructor method, non-constructor method, or empty. It is defined piecewise over the following productions. Class element. Method definition. If prop name of method definition is constructor, return constructor method, return non-constructor method. Class element. Static method definition. Field definition. Static field definition. Return non-constructor method. Class element. Class static block. Return non-constructor method. Class element. Return empty. 5, 7, 3 static semantics. Constructor method. The syntax directed operation constructor method takes no arguments and returns a class element parse no door empty. It is defined piecewise over the following productions. Class element list. Class element. If class element kind of class element is constructor method, return class element. Return empty. Class element list. Class element list. Class element. 2. Let head be constructor method of class element list. If head is not empty, return head. 44. ECMA International 2024. 3. If class element kind of class element is constructor method, return class element. Return empty. 5, 7. 4 static semantics. Is static. The syntax directed operation is static takes no arguments and returns a boolean. It is defined piecewise over the following productions. Class element. Method definition. Return false. Class element. Static method definition. Return true. Class element. Field definition. Return false. Class element. Static field definition. Return true. Class element. Class static block. Return true. Class element. Return false. 5, 7. 5 static semantics. Non-constructor elements. The syntax directed operation non-constructor elements takes no arguments and returns a list of class element parse nodes. It is defined piecewise over the following productions. Class element list. Class element. If class element kind of class element is non-constructor method, then a return class element. Return a new empty list. Class element list. Class element list. Class element. Let list be non-constructor elements of class element list. If class element kind of class element is non-constructor method, then a append class element to the end of list 3. Return list. Note early error rules ensure that there is only one method definition named constructor and that it is not an accessor property or generated definition. ECMA International 2024 345. 1, 5, 7, 6 static semantics. Prototype property name list. The syntax directed operation prototype property name list takes no arguments and returns a list of property keys. It is defined piecewise over the following productions. Class element list. Class element. Let prop name be prop name of class element. If prop name is empty, return a new empty list. If the static of class element is true, return a new empty list. Return prop name. Class element list. Class element list. Class element. Let list be prototype property name list of class element list. Let prop name be prop name of class element. If prop name is empty, return list. If the static of class element is true, return list. Return the list concatenation of list and prop name. 5, 7 static semantics. All private identifiers valid. The syntax directed operation all private identifiers valid takes argument names, a list of strings, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of all private identifiers valid. For each child node child of this parse node. Do A if child is an instance of a non-terminal, then I if all private identifiers valid of child with argument names is false. Return false 2. Return true. Member expression. Member expression. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of member expression with argument names. Return false. Call expression. Call expression. Private identifier. If names contains the string value of private identifier, then a return all private identif is valid of call expression with argument names. Return false. Optional chain. Private identifier. If names contains the string value of private identifier, return true. Return false. Optional chain. Optional chain. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of optional chain with argument names. Return false. Class body. Class element list. 2. Let new names be the list concatenation of names and private band identifiers of class body. Return all private identifiers valid of class element list with argument new names. 46. ECMA International 2024. Relational expression. Private identifier in shift expression. If names contains the string value of private identifier, then a return all private identifiers valid of shift expression with argument names. Return false. 5, 7, 8 static semantics. Private bound identifiers. The syntax directed operation private bound identifiers takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Field definition. Class element name initial is rot. Return private bound identifiers of class element name. Class element name. Private identifier. Return list whose sole element is the string value of private identifier. Class element name. Property name. Class element. Class static block. Return a new empty list. Class element list. Class element list. Class element. Let names 1 be private bound identifiers of class element list. Let names 2 be private bound identifiers of class element. Return the list concatenation of names 1 and names 2. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generate a method. Class element name. Unique formal parameters. Generate a body. Async method. Async class element name. Unique formal parameters. Async function body. Async generate a method. Async class element name. Unique formal parameters. Async generate a body. Return private bound identifiers of class element name. 5, 7, 9 static semantics. Contains arguments. The syntax directed operation contains arguments, takes no arguments and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following. Default definition of contains arguments. For each child node child of this parse node. Do a if child is an instance of a non-terminal, then New empty list. Class element list. Class element list. Class element. Let names 1 be private bound identifiers of class element list. Let names 2 be private bound identifiers of class element. Return the list concatenation of names 1 and names 2. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generator method. Class element name. Unique formal parameters. Generator body. Async method. Async class element name. Unique formal parameters. Async function body. Async generator method. Async class element name. Unique formal parameters. Async generator body. Return private bound identifiers of class element name. 5, 7, 9 static semantics. Contains arguments. The syntax-directed operation contains arguments, takes no arguments, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following. Default definition of contains arguments. For each child node child if this parse node. Do A if child is an instance of a non-terminal. Then I if contains arguments if child is true. Return true to. Return false. ECMA International 2024 347. Identifier reference. Identifier. If the string value of identifier is arguments. Return true. Return false. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier. Formal parameters. Function body. Generator declaration. Function binding identifier. Formal parameters. Generator body. Function. Formal parameters. Generator body. Generator expression. Function binding identifier. Formal parameters. Generator body. Async generator declaration. Async function binding identifier. Formal parameters. Async generator body. Async function. Formal parameters. Async generator body. Async generator expression. Async function binding identifier. Formal parameters. Async generator body. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Async function. Formal parameters. Async function body. Async function expression. Async function binding identifier. Formal parameters. Async function body. Return false. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generator method. Class element name. Unique formal parameters. Generator body. Async generator method. Async class element name. Unique formal parameters. Async generator body. Async method. Async class element name. Unique formal parameters. Async function body. Return contains arguments of class element name. The 5th of July 2010 runtime semantics. Class field definition evaluation. The sint. Axe-directed operation class field definition evaluation takes argument home object, an object, and returns either a normal completion containing a class field definition record or an abrupt completion. It is defined piecewise over the following productions. Field definition. Class element name initializer opt. 2. Meta name B. Evaluation of class element name. If initializer is present, then 48. ECMA International 2024. ABCDE. Let formal parameter list be an instance of the production formal parameters. Empty. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let initializer be ordinary function create. Percent function prototype percent. Source text. Formal parameter list. Initializer. Non-lexical this. env. Private env. F perform make method. Initializer. Home object. G set initializer to name. Else. Let initializer be empty. Return the class field definition record. Name. Initializer. Note the function created for initializer is never directly accessible to ECMA script code. The 5th of July 2011 runtime semantics. Capital C L A S S. Capital S T A T I C. Capital B L O C K. Capital D E F I N I T I O N. Capital E V A L. The syntax-directed operation. Capital C L A S S. Capital S T A T I C. Capital B L O C K. Capital D E F I N I T I O N. Capital E V A L. Takes argument home object, an object, and returns a class static block definition record. It is defined piecewise over the following productions. Class static block. Static. Class static block body. Let lex be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let formal parameters be an instance of the production formal parameters. Empty. Let body function be ordinary function create. Percent function prototype percent. Source text. Formal parameters. Class static block body. Non-lexical this. Lex. Private env. Perform make method. Body function. Home object. Return the class static block definition record. Body function. Note the function body function is never directly accessible to ECMA script code. The 15th of July 2012 runtime semantics. Evaluate class static block body. The syntax-directed operation evaluate class static block body takes argument function object, an ECMA script function object, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Class static block body. Class static block statement list. Assert. Function object is a synthetic function created by capital C L A S S capital S T A T I C capital B L O C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L. Step 5. Perform. Capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. Function object. Return. Evaluation of class static block statement list. The 5th of July 2013 runtime semantics. Class element evaluation. The syntax-directed operation class element evaluation takes argument object, an object, and returns either a normal comp, lesson containing either a class field definition record, a class static block definition record, a private element, or unused, or an abrupt completion. It is defined piecewise over the following productions. Class element, field definition, static field definition, return. Class field definition evaluation of field definition with argument object, class element, method definition, static method definition, return. Method definition evaluation of method definition with arguments object and false, class element, class static block, return, capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L, of class static block with argument object, copyright sign, ECMA International 2024 349, class element. 1. Return unused. The 5th of July 2014 runtime semantics. Class definition evaluation. The syntax-directed operation class definition evaluation takes arguments class binding, a string or undefined, and class name, a property key or a private name, and returns either a normal completion containing a function object or an abrupt completion. Note freeze of specification. Private methods and accessors are included alongside private fields in the slot of class instances. However, any given object has either all or none of the private methods and accessors defined by a given class. This feature has been designed so that implementations may choose to implement private methods and accessors using a strategy which does not require tracking each method or accessor individually. For example, an implementation could directly associate instance private methods with their corresponding private name and track. For each object, which class constructors have run with that object as their base value. Looking up an instance private method on an object then consists of checking that the class constructor which defines the method has been used to initialize the object, then returning the method associated with the private name. This differs from private fields, because field initializers can throw during class instantiation. An individual object may have some proper subset of the private fields of a given class, and so private fields must in general be tracked individually. It is defined piecewise over the following productions. Class tail, class heritage art, class body opt. Let env be the lexical environment of the running execution context. Let class env be new declarative environment. Env. If class binding is not undefined, then perform class env create a mutable binding. Class binding. True. Let outer private environment be the running execution context's private environment. Let class private environment be new private environment. Outer private environment. If class body is present, then of for each string dn of the private bound identifiers of class body. Do. I of class private environment contains a private name pn such that pn is dn. Then assert. This is only possible for getter setter pairs. 2. Else, let name be a new private name whose description is dn. Append name to class private environment. If class heritage is not present, then a let proto parent be percent object prototype percent. B let constructor parent be percent function prototype percent. Else. 50. ECMA International 2024. A B C D E F. Set the running execution context's lexical environment to class CNV. Note, the running execution context's private environment is outer private environment when evaluating class heritage. Let superclass ref be completion. Evaluation of class heritage. Set the running execution context's lexical environment to env. Let superclass be. Get value superclass ref. If superclass is null, then I2. Let proto parent be null. Let constructor parent be percent function prototype percent. G else if is constructor superclass is false, then I throw a type error exception. H else I let proto parent be. Get superclass prototype 2. If proto parent is not an object and proto parent is not null, throw a type error exception. 3. Let constructor parent be superclass. Let proto be ordinary object create. Proto parent 0. If class body is not present, let constructor be empty. 1. Else, let constructor be constructor method of class body. 2. Set the running execution context's lexical environment to class CNV. 3. Set the running execution context's private environment to class private environment. 4. If constructor is empty, then a let default constructor be a new abstract closure with no parameters that captures nothing and performs the following steps when called. I let args be the list of arguments that was passed to this function by or 2. If new target is undefined, throw a type error exception. 3. Let f be the active function object. If f is derived, then note this branch behaves similarly to constructor args super args. The most notable distinction is that while the aforementioned DCMA script source text observably calls the @iterator method on %array prototype %, this function does not. Let func be f if this constructor func is false. Throw a type error exception. Let result be construct func args new target v else. Note this branch behaves similarly to constructor. Let result be ordinary create from constructor new target %object prototype %v perform initialize instance elements result f7. Return result. B let f be create built-in function, default constructor, 0, class name, the current realm record, constructor parent, 5. Else, a let constructor info b. Define method of constructor with arguments proton constructor parent, b let f be constructor info, c perform make class constructor, f, d perform set function name, f, class name, 6. Perform make constructor, f, false, proto, 7. If class heritage is present, set f to derived, 8. Perform. Define method property, prota, constructor, f, false, 9. If class body is not present, let elements be a new empty list, 0. Else, let elements be non-constructor elements of class body, 1. Let instance private methods be a new empty list, 2. Let static private methods be a new empty list, 3. Let instance fields be a new empty list, 4. Let static elements be a new empty list, 5. For each class element of elements, do if is static of e is false. Then, I let element be completion, class element evaluation of e with argument proto b else. I let element be completion, class element evaluation of e with argument f. See if element is an abrupt completion. Then, I set the running execution context's lexical environment to env2. Set the running execution context's private environment to outer private environment. 3. Return element d set element to element e if element is a private element. Then, I assert, element is either method or accessor. 2. If a static of e is false, let container be instance private methods. 3. Else, let container be static private methods. 5. If container contains a private element pay such that pay, then, ECMA International 2024 351, 1. Assert, element and pay are both accessor. If element, a let combined be private element, accessor. Else, a let combined be private element, accessor. Element, pay, v else, append element to container. F else if element is a class field definition record, then, either static of e is false, append element to instance fields. 2. Else, append element to static elements. G else if element is a class static block definition record, then, I append element to static elements. 6. Set the running execution context's lexical environment to env7. If class binding is not undefined, then, a perform class env initialize binding, class binding, f8. Set f to instance private methods, 9. Set f to instance fields, 0. For each private element method of static private methods, do a perform private method or accessor add, f, method 31. For each element record of static elements, do if element record is a class field definition record, then, I let result be completion, define field, f, element record, b else, I assert, element record is a class static block definition record, 2. Let result be completion, call, element record, f, see if result is an abrupt completion, then, I set the running execution context's private environment to outer private environment, 2. Return result, 2. Set the running execution context's private environment to outer private environment, 3. Return f, the 5th of July 2015 runtime semantics, capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T. The syntax directed operate. I on, capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T, takes no arguments and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions. Class declaration, class binding identifier class tail. Let class name be string value of binding identifier. Let value be class definition evaluation of class tail with arguments class name and class name. Set value to the source text match by class declaration. Let env be the running execution context's lexical environment. Perform. Initialize bound name, class name, value, env, return value, class declaration, class tail. Let value be class definition evaluation of class tail with arguments undefined and default. Set value to the source text match by class declaration. Return value 352. ECMA International 2024. Class declaration. Class tail only occurs as part of an export declaration and note, establishing its binding is handled as part of the evaluation action for that production. C1623 7. The 15th of July 2016 runtime semantics. Evaluation. Class declaration. Class binding identifier class tail. Perform. Capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T, of this class declaration. Return empty. Class expression. Class tail. Let value be class definition evaluation of class tail with arguments undefined and set value to the source text match by class expression. Return value. Class expression. Class binding identifier class tail. Let class name be string value of binding identifier. Let value be Class definition evaluation of class tail with arguments class name and class name. Set value to the source text match by class expression. Return value. Class element name. Private identifier. Let private identifier be string value of private identifier. Let private TNV-rec be the running execution context's private environment. Let names be private TNV-rec. Assert. Exactly one element of names is a private name whose is private identifier. Let private name be the private name and names whose is private identifier. Return private name. Class static block statement list. Empty. 1. Return undefined. 5.8 Async function definition syntax. Async function declaration. Yield. Await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Yield. Plus await. Async function body. Plus default. Async. No line terminator here. Function. Formal parameters. Yield. Plus await. Class declaration. Class tail only occurs as part of an export declaration and is never, note, directly evaluated. Async function body. Async function expression. Async. No line terminator here. Function binding identifier. Yield. Plus await opt. Formal parameters. Yield. Plus await. Async function body. Async method. Yield. Await. Async. No line terminator here. Class element nom. Yield await. Unique formal parameters. Yield. Plus await. Async function body. Async function body. Function body. Yield. Plus await. ECMA International 2024. 53. Await expression. Yield. Await unary expression yield. Plus await. Note 1. Await is passed as a keyword of an await expression when the await parameter is present. The await parameter is present in the top level of the following contexts. Although the parameter may be absent in some contexts depending on the non-terminals, such as function body, in an async function body, in the formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression. Await expression in this position is a syntax error via static semantics. In a module, when script is the syntactic goal symbol, await may be parsed as an identifier when the await parameter is absent. This includes the following contexts. Anywhere outside of an async function body or formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression, in the binding identifier of a function expression, generator expression, or async generator expression. 158. 1 static semantics, early errors, async method, async class element name, unique formal parameters, async function body. It is a syntax error if function body contains use strict of async function body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if has direct super of async method is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of async function body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, async function expression, async function binding identifier opt, formal parameters, async function body. It is a syntax error if function body contains use strict of async function body is true and is simple parameter list of formal parameters is false. It is a syntax error if formal parameters contains await expression is true, if the source text match by formal parameters is strict mode code. The early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text match by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of async function body. It is a syntax error if formal parameters contain super property is true. It is a syntax error if async function body contains super property is true. It is a syntax error if formal parameters contain super call is true. It is a syntax error if async function body contains super call is true. 54. ECMA International 2024. Note to unlike yield expression, it is a syntax error to omit the operand of an await expression. You must await something. 158. To runtime semantics, instantiate async function object. The syntax directed operation instantiate async function object takes argument CNV, an environment record, and private TNV, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions: async function declaration, async function binding identifier, formal parameters, async function body. Let name be string value of binding identifier. Let source text be the source text match by async function declaration. Let f be ordinary function create. Async function prototype source text. Formal parameters, async function body, non-lexical this, env, private env, perform set function name, f, name, return f, async function declaration, async function, formal parameters, async function body. Let source text be the source text match by async function declaration. Let f be ordinary function create, async function prototype, source text, formal parameters, async function body, non-lexical this, env, private env, perform set function name, f, default, return f, 5, 8, 3 runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S. The syntax directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S, takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions: async function expression, async function, formal parameters, async function body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by async function expression. Let closure be ordinary function create. Async function prototype source text. Formal parameters, async function body, non-lexical this, env, private env, perform set function name, closure, name, return closure, async function expression, async function binding identifier, formal parameters, async function body, assert, name is not present, set name to string value of binding identifier, let outer env be the lexical environment of the running execution context, let funky env be new declarative environment, outer env, perform funky env create immutable binding, name, false. Let private env be the running execution context's private environment. Let source text be the source text matched by async function expression. Let closure be ordinary function create. Async function prototype source text. Formal parameters. Async function body. Non-lexical this. Func env. Private env. Perform set function name. Closure. Name 0. Perform func env initialize binding. Name. Closure. Expressions async function body to allow the function to call itself recursively. However, unlike in a function declaration, the binding identifier in a async function expression cannot be referenced from and does not affect the scope enclosing the async function expression. ECMA International 2024. Function declaration instantiation, function object, arguments list. If declar result is an abrupt completion, then a perform, call, promise capability, undefined, declar result 4. Else, a perform async function start, promise capability, function body, return completion record, return, promise capability, empty, 5, 8, 5 runtime semantics, evaluation, async function expression, async function binding identifier opt, formal parameters, async function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S, of async function expression. Await expression, await unary expression, let X per F be. Evaluation of unary expression, let value be. Get value, X per F, return. Await, value, 5.9 async arrow function definition syntax. Here, equals, async concise body in, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await, async concise body in, async concise body, in, look ahead, expression body in, class await, async function body, async arrow binding identifier, yield, binding identifier yield, class await, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield, await, member expression yield await, arguments yield await, supplemental syntax, when processing an instance of the production, async arrow function, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, equals, async concise body, the interpretation of, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, is refined using the following grammar. Async arrowhead, async, no line terminator here, arrow formal parameters, yield, class await, 56, ECMA International 2024, async arrow function, in, yield, await, async, no line terminator here, async arrow binding identifier yield, no line terminator here, equals, 159, 1 static semantics, early errors, async arrow function, async arrow binding identifier equals, async concise body. It is a syntax error if any element of the bound names of async arrow binding identifier also occurs in the lexically declared names of async concise body. Async arrow function, capital C, O, V, E, R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R equals a concise body, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R must cover an R rowhead. It is a syntax error if capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R contains yield expression is true. It is a syntax error if capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R contains a weight expression is true. It is a syntax error if any element of the bound names of capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R also occurs in the lexically declared names of a concise body. It is a syntax error if capital A S Y N C, capital C O N C I S E, capital B O D Y, capital C O N T A I N S, capital U S E, capital S T R of a concise body is true and is simple parameter list of capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R is false. 5, 9, 2 static semantics, capital A S Y N C, capital C O N C I S E, capital B O D Y, capital C O N T A I N S, capital U S E, capital S T R. The syntax directed operation, capital A S Y N C, capital C O N C I S E, capital B O D Y, capital C O N T A I N S, capital U S E, capital S T R takes no arguments and returns a boolean. It is defined piecewise over the following productions: a concise body, expression body, return false, a concise body, a function body, return function body contains use strict to the function body 159, 3 runtime semantics, evaluate a concise body. The syntax directed operation evaluate a concise body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns a return completion. It is defined piecewise over the following productions: a concise body, expression body, let promise capability be, new promise capability, promise percent, let decl result be completion, function declaration instantiation, function object, arguments list. If decl result is an abrupt completion, then a perform, call, promise capability, undefined, decl result for, else, a performance and function start, promise capability, expression body, return completion record, return, promise capability, empty, 5, 9, 4 runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital A, R, R, O, W, capital F, U, N, C, T, I, O, N, capital E. The syntax directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital A, R, R, O, W, capital F, U, N, C, T, I, O, N, capital E, takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions. Async arrow function, async arrow binding identifier equals, async concise body. If name is not present, set name 2. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by async arrow function. Let parameters be async arrow binding identifier. Let closure be ordinary function create. Percent async function prototype percent. Source text. Parameters. Async concise body. Lexical this. env. Private env. Perform set function name. Closure. Name. Return closure. ECMA International 2024 357. Async arrow function. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R equals async concise body. If name is not present, set name 2. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by async arrow function. Let head be the async arrow head that is covered by capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Let parameters be the array formal parameters of head. Let closure be ordinary function create. Percent async function prototype percent. Source text. Parameters. Async concise body. Lexical this. env. Private env. Perform set function name. Closure. Name. Return closure. 5 9. 5 runtime semantics. Evaluation. Async arrow function. Async arrow binding identifier equals async concise body. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R equals async concise body. Return. Capital I N S T A N T I A T E. Capital A S Y N C. Capital A R R O W. Capital F U N C T I O N. Capital E of async arrow function 15.10 tail position calls 5 1 0 1 static semantics is in tail position call. The abstract operation is in tail position takes argument call, a call expression parse node, a member expression parse node, or an optional chain parse node, and returns a boolean. It performs the following steps when called. If the source text matched by call is non-strict code, return false. If call is not contained within a function body, a concise body, or an async concise body, return false. Let body be the function body, concise body, or async concise body that most closely contains call. If body is the function body of a generator body, return false. If body is the function body of an async function body, return false. If body is the function body of an async generator body, return false. If body is an async concise body, return false. Return the result of has call in tail position of body with argument call. 5 1 0 2 static semantics has call in tail position. The syntax directed operation has call in tail position takes argument call, a call expression parse node, a member expression parse node, or an optional chain parse node, and returns a boolean. Note tail position calls are only defined in strict mode code because of a common non-standard language extension, C10, 2, 4, that enables observation of the chain of caller contexts. Note one call is a parse node that represents a specific range of source text. When the following algorithms compare call to another parse node, it is a test of whether they represent the same source text. Note 2, a potential tail position call that is immediately followed by return get value of the call result is also a possible tail position call. A function call cannot return a reference record, so such a get value operation will always return the same value as the actual function call result. 58. Copyright sign, ECMA International 2024. It is defined piecewise over the following productions. Statement list item. Let his be has call in tail position of statement list with argument call. If his is true, return true. Return has call in tail position of statement list item with argument call. Function statement list, empty. Statement list item, declaration, statement, variable statement, empty statement, expression statement, continue statement, break statement, throw statement, debugger statement, block, return statement, return, labeled item, function declaration, for in of statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. Case block, return false. If statement, if expression statement else statement. Let his be has call in tail position of the first statement with argument call. If his is true, return true. Return has call in tail position of the second statement with argument call. If statement, if expression statement, do while statement, do statement while, expression while statement, while, expression statement for statement. 4. Expression not statement. 4. var variable declaration list, Expression not. Statement 4. Lexical declaration expression not. Statement for in of statement 4. Left-hand side expression in expression statement 4. var for binding in expression statement 4. For declaration in expression statement. ECMA International 2024 359. With statement. With expression statement. Return has call and tail position of statement with argument call. Labeled statement. Label identifier. Labeled item. Return has call and tail position of labeled item with argument call. Return statement. Return expression. Return has call and tail position of expression with argument call. Switch statement. Switch. Expression. Case block. Return has call and tail position of case block with argument call. Case block. Case clause assopt. Default clause case clause assopt. Let has be false. If the first case clauses is present, set has to has call and tail position of the first case clauses with argument call. If his is true, return true. Set has to has call and tail position of default clause with argument call. If his is true, return true. If the second case clauses is present, set has to has call and tail position of the second case clauses with argument call. Return has case clauses case clause. Let has be has call and tail position of case clauses with argument call. If his is true, return true. Return has call and tail position of case clause with argument call. Case clause, case expression, statement list opt default clause, default, statement list opt. If statement list is present, return has call and tail position of statement list with argument call. Return false. Try statement, try block catch. Return has call and tail position of catch with argument call. Try statement, try block finally. Try block catch finally. Return has call and tail position of finally with argument call. Catch parameter, block. Return has call and tail position of block with argument call. 60. ECMA International 2024. Assignment expression, yield expression, arrow function, arrow function. Left-hand side expression equals assignment expression, left-hand side expression assignment op. Rater assignment expression, left-hand side expression and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression. Bitwise and expression and equality expression. Bitwise or expression, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, bitwise or expression. Equality expression equals relational 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 expression. Relational expression. Shift expression relational expression. Shift expression relational expression equals shift expression relational expression equals shift expression relational expression. Instance of shift expression relational expression in shift expression. Private identifier in shift expression. Shift expression. Shift expression. Additive expression. Shift expression. Additive expression. Shift expression. Additive expression. Additive expression. Additive expression plus multiplicative expression. Additive expression. Multiplicative expression. Multiplicative expression. Multiplicative expression. Multiplicative operator. Exponentiation expression. Exponentiation expression. Update expression. Exponentiation expression. Update expression. Left-hand side expression plus plus. Left-hand side expression plus plus unary expression. Unary expression. Unary expression. Delete unary expression. Void unary expression. Type of unary expression plus unary expression, unary expression, unary expression, unary expression, await expression. ECMA International 2024 361. Call expression, super call import call. Call expression, call expression. Identifier name call expression. Private identifier, new expression, new expression, member expression, member expression, expression, member expression. Identifier name super property, meter property, new member expression arguments member expression. Private identifier, primary expression. This identifier reference, literal, array literal, object literal function expression plus expression generator expression async function expression async generator expression regular expression literal template literal return false expression assignment expression expression assignment expression. Return has call and tail position of assignment expression with argument call. Conditional expression, short circuit expression. Assignment expression. Let has be has call and tail position of the first assignment expression with argument call. If his is true, return true. Return has call and tail position of the second assignment expression with argument call. Logical and expression and bitwise or expression 1. Return has call and tail position of bitwise or expression with argument call. Logical or expression, logical and expression. Return has call and tail position of logical and expression with argument call. Coalesce expression, co-alice expression head. Bitwise or expression 1. Return has call and tail position of bitwise or expression with argument call. 62. ECMA International 2024. Call expression, capital C-O-V-E-R, capital C-A-L-L, capital E-X-P-R-E-S-S-I-O-N, capital A-N-D, capital A-S-Y-N-C, capital A-R-R, call expression arguments call expression template literal. If this call expression is call, return true, return false. Optional expression, member expression optional chain call expression optional chain optional expression optional chain. Return has call and tail position of optional chain with argument call. Optional chain, expression, identifier name, private identifier optional chain, expression, optional chain. Identifier name optional chain. Private identifier, return false, optional chain, arguments, optional chain arguments. If this optional chain is cool, return true, return false. Member expression template literal. If this member expression is cool, return true, return false. Primary expression, capital C-O-V-E-R, capital P-A-R-E-N-T-H-E-S, I Z E D capital E X P R E S S I O N capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return has call and tail position of expa with argument call parenthesized expression return has call and tail position of expression with argument call. ECMA International 2024 363 1510 3. Prepare for tail call. The abstract operation prepare for tail call takes no arguments and returns unused. It performs the following steps when called. Assert. The current execution context will not subsequently be used for the evaluation of any ECMA script code or built-in functions. The invocation of call subsequent to the invocation of this abstract operation will create and push a new execution context before performing any such evaluation. Discard all resources associated with the current execution context. Return unused. A tail position call must either release any transient internal resources associated with the currently executing function execution context before invoking the target function, or reuse those resources in support of the target function. 6. ECMA script language. Scripts and modules. 6.1 Script syntax. Script body opt. Script body. Statement list. Yield. Await. Return. 6. 1. Static semantics. Early errors. Script body. It is a syntax error if the lexically declared names of script body contains any duplicate entries. It is a syntax error if any element of the lexically declared names of script body also occurs in the are declared names of script body. Script body. Statement list. It is a syntax error if statement list contains super unless the source text containing super is eval code that is being processed by a direct eval. Additional early error rules for super within direct eval are defined in 192.1.1. It is a syntax error if statement list contains new target unless the source text containing new target is eval code that is being processed by a direct eval. Addition. Null early error rules for new target in direct eval are defined in 192.1.1. It is a syntax error if contains duplicate labels of statement list with argument is true. It is a syntax error if contains undefined break target of statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments and is true. It is a syntax error if all private identifiers valid of statement list with argument is false unless the source text containing script body is eval code that is being processed by a direct eval. Note, for example, a tail position call should only grow an implementation's activation record stack by the amount that the size of the target function's activation record exceeds the size of the calling function's activation record. If the target function's activation record is smaller, then the total size of the stack should decrease. 64. ECMA International 2024 161. 2. Static semantics is strict. The syntax directed operation is strict, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Script body opt. If script body is present and the directive prologue of script body contains a use strict directive, return true. Otherwise, return false. 6. 1. 3. Runtime semantics. Evaluation. Script empty. Return undefined. 6. 1. 4 script records. A script record encapsulates information about a script being evaluated. Each script record contains the fields listed in Table 40. Table 40. Script record fields. Field name. Value type. Meaning. Realm. A realm record or undefined. The realm within which this script was created. Undefined if not yet assigned. ECMA script code. A script parse node. The result of parsing the source text of this script. Loaded modules. A list of records with fields. A string. And. A module record. A map from the specifier strings imported by this script to the resolved module record. The list does not contain two different records with the same host defined. Anything default value is empty. Field reserved for use by host environments that need to associate additional information with a script. 161. 5 parse script. Source text. Realm. Host defined. The abstract operation parse script takes arguments source text, ECMA script source text, realm, a realm record or undefined, and host defined anything and returns a script record or a non-empty list of syntax error objects. It creates a script record based upon the result of parsing source text as a script. It performs the following steps when called. Let script be parse text, source text, script. If script is a list of errors, return script record, realm, script, host defined. Note an implementation may parse script source text and analyze it for early error conditions prior to evaluation of parse script for that script source text. However, the reporting of any errors must be deferred until the point where this specification actually performs parse script upon that source text. ECMA International 2024 365. 161. 6 script evaluation, script record. The abstract operation script evaluation takes argument script record, a script record, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Let global env be script record. Let script context be a new ECMA script code execution context. Set the function of script context to null. Set the realm of script context to script record. Set the script or module of script context to script record. Set the variable environment of script context to global env. Set the lexical environment of script context to global env. Set the private environment of script context to null. Suspend the running execution context. 0. Push script context onto the execution context stack. Script context is now the running execution context. 1. Let script be script record. 2. Let result be completion, global declaration instantiation, script, global env. 3. If result is a normal completion, then I set result to completion, evaluation of script. B. If result is a normal completion and result is empty, then I set result to normal completion, undefined. 4. Suspend script context and remove it from the execution context stack. 5. Assert, the execution context stack is not empty. 6. Resume the context that is now on the top of the execution context stack as the running execution context. 7. Return result. 6. 1. 7. Global declaration instantiation, script, env. The abstract operation global declaration instantiation takes argument script, a script parse node, and env, a global environment record, and returns either a normal completion containing unused or a throw completion script as the script for which the execution context is being established. TNV is the global environment in which bindings are to be created. It performs the following steps when called. Let lex names be the lexically declared names of script. Let var names be the var declared names of script. For each element name of lex names, do A if env has var declaration, name, is true, throw a syntax error exception. B if env has lexical declaration, name, is true, throw a syntax error exception. C let has restricted global. B env has restricted global property, name. D if his restricted global is true, throw a syntax error exception. For each element name of var names, do A if env has lexical declaration, name, is true, throw a syntax error exception. Let var declarations be the var scope declarations of script. Let functions to initialize be a new empty list. Let declared function names be a new empty list. For each element D of var declarations, in rev, us list order, do 366. ECMA International 2024. Note 1. When an execution context is established for evaluating scripts, declarations are instantiated in the current global environment. Each global binding declared in the code is instantiated. A. If D is not either a variable declaration, a for binding, or a binding identifier, then I. 2. 3. Assert. D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. Note, if there are multiple function declarations for the same name, the last declaration is used. Let fn be the sole element of the bound names of D. If declared function names does not contain fn, then let fn definable be env can declare global function, fn. 2. If fn definable is false, throw a type error exception. Append fn to declared function names. Insert D as the first element of functions to initialize. Let declared var names be a new empty list. 0. For each element D of var declarations, do if D is either a variable declaration, a for binding, or a binding identifier, then I for each string vn of the bound names of D, do if declared function names does not contain vn, then a let vn definable be env can declare global var, vn. B if vn definable is false, throw a type error exception. C if declared var names does not contain vn, then I append vn to declared var names. 1. Note, no abnormal terminations occur after this algorithm step if the global object is an ordinary object. However, if the global object is a proxy exotic object, it may exhibit behaviors that cause abnormal terminations in some of the following steps. 2. Note, MXB. 3. 2. 2 adds additional steps at this point. 3. Let lex declarations be the lexically scoped declarations of script. 4. Let private TNV be null. 5. For each element D of lex declarations, do a note, lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D, do I if this constant declaration of D is true, then perform env create a mutable binding, Dn, true. 2. Else perform env create mutable binding, Dn, false. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments env and private env. C perform env create global function binding, fn, fo, false. 7. For each string vn of declared var names, do a perform env create global var binding, vn, false. 8. Return unused. Note 2. Early errors specified in 1.6. 1. 1. Prevent name conflicts between function var declarations and let const class declarations as well as redeclaration of let const class bindings for declaration contained within a single script. However, such conflicts in redeclarations that span more than one script are detected as runtime errors during global declaration instantiation. If any such errors are detected, no bindings are instantiated for the script. However, if the global object is defined using proxy exotic objects, then the runtime tests for conflicting declarations may be unreliable, resulting in an abrupt completion in some global declarations not being instantiated. If this occurs, the code for the script is not evaluated. Unlike explicit var or function declarations, properties that are directly created on the global object result in global bindings that may be shadowed by let const class declarations. 6.2 Module syntax. Module body opt, module body, module item list, module item list, module item list, module item. ECMA International 2024 367. Module item, import declaration, export declaration, statement list item, yield, class await, return, module export name, identifier name, string literal. 6. 2. 1 module semantics. 6. 2. 1. 1 static semantics. Early errors. Module body. Module item list. It is a syntax error if the lexically declared names of module item list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of module item list also occurs in the are declared names of module item list. It is a syntax error if the exported names of module item list contains any duplicate entries. It is a syntax error if any element of the exported bindings of module item list does not also occur in either the are declared names of module item list or the lexically declared names of module item list. It is a syntax error if module item list contains super. It is a syntax error if module item list contains new target. It is a syntax error if contains duplicate labels of module item list with argument is true. It is a syntax error if contains undefined break target of module item list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a module item list with arguments and is true. It is a syntax error if all private identifiers valid of module item list with argument is false. Module export name string literal. It is a syntax error if is string well formed Unicode. The SV of string literal is false. 6 2 1 2 static semantics imported local names import entries. The abstract operation imported local names takes argument import entries, a list of import entry records, and returns a list of strings. It creates a list of all of the local name bindings defined by import entries. It performs the following steps when called. Let local names be a new empty list. For each import entry record I of import entries, do a append I to local names 3. Return local names. 6 2 1 3 static semantics module requests. The syntax directed operation module requests takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module empty return a new empty list. The duplicate exported names rule implies that multiple export default export declaration items. Note, within a module body is a syntax error. Additional error conditions relating to conflicting or duplicate declarity arms are checked during module linking prior to evaluation of a module. If any such errors are detected, the module is not evaluated. 68 ECMA International 2024 module item list module item return module requests of module item list module item list module item. Let module names be module requests of module item list. Let additional names be module requests of module item. For each string name of additional names, do if module names does not contain name, then I append name to module names. Return module names. Module item statement list item return a new empty list. Import declaration import clause from clause. Return module requests of from clause. Module specifier string literal return a list whose sole element is the SV of string literal. Export declaration export from clause. Return the module requests of from clause. Export declaration export named exports. Export variable statement. Export declaration export default hoistable declaration. Export default class declaration. Export default assignment expression. Return a new empty list 1 6 2 1 4 abstract module records. A module record encapsulates structural information about the imports and exports of a single module. This information is used to link the imports and exports of sets of connected modules. A module record includes 4 fields that are only used when evaluating a module. For specification purposes, module record values are values of the record specification type and can be thought of as existing in a simple, object-oriented hierarchy where module record is an abstract class with both abstract and concrete subclasses. This specification defines the abstract subclass named cyclic module record and its concrete subclass named source text module record. Other specifications and implementations may define additional module record subclasses corresponding to alternative module definition facilities that they defined. Module record defines the fields listed in Table 41. All module definition subclasses include at least those fields. Module record also defines the abstract method list in Table 42. All module definition subclasses must provide concrete implementations of these abstract methods. ECMA International 2024 369. Table 41. Module record fields. Field name. Value type. Meaning. Realm. A realm record. The realm within which this module was created. Environment. A module environment record or empty. The environment record containing the top level bindings for this module. This field is set when the module is linked. Namespace. An object or empty. The module namespace object. 28.3. If one has been created for this module. Host defined. Anything default value is undefined. Field reserved for use by host environments that need to associate additional information with a module. Table 42. Abstract methods of module records. Method. Purpose. Load requested modules. Host defined. Close bracket. Prepares the module for linking by recursively loading all its dependencies. And returns a promise. Get exported names. Export star set. Return a list of all names that are either directly or indirectly exported from this module. Load requested modules must have completed successfully prior to invoking this method. Resolve export. Export name. Resolve set.
Finally, it's a quad.
Record of the form. Module record.
It's not a square.
Export is a module namespace object.
It's 2 triangles.
Will be set to names.
It's triangle land. GPU land.
As if multiple.
In GPU world,
Time this operation is.
there's only triangles.
Resolve set pairs arguments. It must
There's no male. There's no female.
completed successfully prior to
Only trigender, meaning triangles.
dependencies and creating a module
In triangle world, you make squares out of triangles.
invoking this method.
You make triangles out of squares.
Module and its dependence
You just have to always have only triangles.
successfully and rejecting for an evaluation error or if it has already been evaluated unsuccessfully.
That's a GPU world.
Hosts are expected to handle the
GPU world is horrible.
did successfully prior to invoking this method.
This is so annoying.
International 2024 1621 5
All I have to do now
used to represent
is
information
figure out how to map
dependency cycle.
the display to the freaking quad. It's all that's left. All that's left to do is mapping the display to the quad. Holy crap, it's hot. I need winter to come back. I can't take the heat.
Meaning status new unlinked linking linked if
Just like when I released my JavaScript engine. It's not working.
sync evaluated in that order as the module progresses throughout its life cycle. Evaluating is
And I meet the entire standard.
of its asynchronous dependencies, or it is a module whose field is true that has been executed and is pending top-level completion.
From page 1 to 816.
Representing the exception that occurred during evaluation, undefined if no exception occurred or if is not evaluated. DFS index, an integer empty, auxiliary field.
And I stream every single section, subcategory, every single thing.
It's the point at which the
It's evidence that I meet the whole entire standard.
FS and
Very first instance to do so.
auxiliary field used during linking.
Put in the description, timestamp.
This is either the module's own or that of an earlier module in the same strongly connected component.
The other engines, they won't be able to take the heat.
All the module specifier strings.
But it's so freaking hot. I need winter to come back.
The list is in source text occurrence order.
Holy heat. So freaking...
A module record.
I need some ice.
Represented by this record to request the importation of a module to the resolved module record.
I can't take the heat.
With the same cycle root, a cyclic module record or empty, the first visited module of the cycle, the root DFS ancestor of the strongly connected component. For a module not in a cycle, this would be the module itself. Once evaluate has completed, a module says the of its copyright sign, ECMA International 2024, 71, Table 43, additional fields of cyclic module records, continued, field name, value type, meaning, has TLA, a boolean, whether this module is individually asynchronous. For example, if it's a source text module record containing a top-level await. Having an asynchronous dependency does not mean this field is true. This field must not change after the module is parsed. A sync evaluation, a boolean, whether this module is either itself asynchronous or has an asynchronous dependency. Note, the order in which this field is set is used to order queued executions. C16, 2, 1, 5, 3, 4. Top-level capability. A. Promise capability record or empty. If this module is the of some cycle, and evaluate was called on some module in that cycle, this field contains the promise capability record for that entire evaluation. It is used to settle the promise object that is returned from the evaluate abstract method. This field will be empty for any dependencies of that module, unless a top-level evaluate has been initiated for some of those dependencies. A sync parent modules, a list of cyclic module records. If this module or a dependency has true, and execution is in progress, this tracks the parent importers of this module for the top-level execution job. These parent modules will not start executing before this module has successfully completed execution, pending async dependencies. An integer or empty. If this module has any asynchronous dependencies, this tracks the number of asynchronous dependency modules remaining to execute for this module. A module with asynchronous dependencies will be executed when this field reaches 0 and there are no execution errors. In addition to the methods defined in Table 42, cyclic module records have the additional methods listed in Table 44. Table 44, additional abstract methods of cyclic module records. Method, purpose, initialize environment. Initialize the environment record of the module, including resolving all imported bindings, and create the module's execution context. Execute module, promise capability. Evaluate the module's code within its execution context. If this module has true in, then a promise capability record is passed as an argument, and the method is expected to resolve or reject the given capability. In this case, the method must not throw an exception, but instead reject the promise capability record if necessary. A graph loading state record is a record that contains information about the loading process of a module graph. It's used to continue loading after a call to host load imported module. Each graph loading state record has the fields defined in Table 45, 72, copyright sign, ECMA International 2024, Table 45, graph loading state record fields, field name, value type, meaning, promise capability. A. Promise capability record. The promise to resolve when the loading process finishes is loading. A boolean. It is true if the loading process has not finished yet, neither successfully nor with an error. Pending modules count. A non-negative integer. It tracks the number of pending host load imported module calls. Visited. A list of cyclic module records. It is a list of the cyclic module records that have been already loaded by the current loading process to avoid infinite loops with circular dependencies. Host defined. Anything default value is empty. It contains host defined data to pass from the load requested modules caller to host load imported module. 6, 2, 1, 5, 1 load requested modules. Host defined. The load requested module's concrete method of a cyclic module record module takes optional argument host defined anything and returns a promise. It populates the of all the module records in the dependency graph of module. Most of the work is done by the auxiliary function in a module loading. It takes an optional host defined parameter that is passed to the host load imported module hook. It performs the following steps when called. If host defined is not present, let host defined be empty. Let PCB. New promise capability. %promise %. Let state be the graph loading state record. True. 1. Promise capability. PC. Host defined.
So like, this has been the worst 8 days of my life. Getting this freaking quad to spin on the damn screen. And I've had some pretty bad days. And this is the worst. Holy crap. I'd rather go through 2 years of plastic surgery. You know what? Never mind. It could be worse. 8 freaking days. I'm so annoyed. All I gotta do there's not much left to do. Literally almost done now, but not really. I still have to like get the freaking video in here, overlay it, cut out the middle. I have to do it today. I don't want to do this tomorrow. I just want to get to programming again. This is horrible. GPU programming. This is not programming. This is setting up predefined structures for predefined lists, for predetermined routines. None of this is real programming. Oh, it's so frustrating. Alright, anyways. All I gotta do on this spinny quad is put the desktop image. Yeah, the quad's taken up GPU performance. How the hell do you render like 4,000 or 5,000 things on the screen? I mean, this is one spinning cube. I mean, quad. There has to be ways to optimize this. I am like making it, like adding to the stack down below whatever, and then there's like redundant operations. So that's probably why. I don't know. I just gotta put the screen on the quad. Oh, chatbot, please help me. Don't give me crap. So I was here, now I'm here. I saved it, make it back up. Backup of everything. I can't stand when this like auto selects. Like every once in a while you'll go to like folder and it like it does that. It like double clicks everything in the thing. All it takes is like one accidental drag. I guess it's like double click. Can I turn that off? I'll look that up later. It's drag. So that's it. I have to turn off whatever this double click to select all, because it's so annoying. I could totally like double click on accident and move everything on accident. I think it's like stuck every now and then. Back up to C code. Wait, what? The source is bigger than the recent. The source is more. The source is bigger. How did it change before you made a copy? I don't know what's happening. Let's recopy it again. There we go. Oh, I think it's the same name. All I gotta do is put the desktop image on the quad. I gotta get done.
internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object must return the same value as. Applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object only returns true if applied to. The proxy object's target object is false. 2. Perform. Validate non-revoke proxy O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target. P. 0. If trap result obj is undefined, then A if target desk is undefined, return undefined. B if target desk is false, throw a type error exception. C let extensible target be. Is extensible. Target. B if extensible target is false, throw a type error exception. E return undefined. 1. Let extensible target be. Is extensible. Target. 2. Let result desk be. To property descriptor, trap result obj. 3. Perform complete property descriptor, result desk. 4. Let valid be as compatible property descriptor, extensible target, result desk, target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then A if target desk is undefined or target desk is true, then I throw a type error exception. B if result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariance. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists. TS is a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, P, desk. The internal method of a proxy exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desk. Let desk obj be from property descriptor. Desk. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. Desk obj. If Boolean trap result is false, return false. 0. Let target desk be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desk has a field and desk is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desk is undefined, then A if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else A if is compatible property descriptor, extensible target, desk, target desk, is false, throw a type error exception. B if setting config false is true and target desk is true, throw a type error exception. C if is data descriptor, target desk, is true, target desk is false, and target desk is true, then I if desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be added if the target object is not extensible. A property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Proxy handler. Assert. Handler is an object. Let trap be. Get method. Handler has if trap is undefined, then a return target. P. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. If Boolean trap result is false, then a let target desk be target. P. B if target desk is not undefined, then I if target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. Return Boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method, handler, get. If trap is undefined, then a return target. Let trap result be call, trap, handler, target, P, receiver. Let target desk be target, P. If target desk is not undefined and target desk is false, then if is data descriptor, target desk, is true and target desk is false, then I have same value, trap result, target desk, is false. Throw a type error exception, B if is accessor descriptor, target desk, is true and target desk, 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call, trap, handler, target, P, V, receiver. If boolean trap result is false, return false. Let target desk be target, P, 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor, target desk, is true and target desk is false, then I have same value, V, target desk, is false. Throw a type error exception, B if is accessor descriptor, target desk, is true, then I have target desk, 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0, P. The internal method of a proxy exotic object so takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let T. Arget be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible. Target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key. B if desk is not undefined and desk is false, then I append key to target non-configurable keys. C else I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let array be create array from list. Arguments list. Return. Call. Trap. Handler. target, this argument, array, note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024-211, the 10th of May 2013, arguments list, new target. The internal method of a proxy exotic object O takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O, assert, is constructor, target, is true. Let handler be O, assert, handler is an object. Let trap be. Get method, handler, construct. If trap is undefined, then a return. Construct, target, arguments list, new target. Let array be create array from list, arguments list. Let new obj be. Call, trap, handler, target, array, new target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The resultive must be an object. 0, 5, 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMA script language value, and handler, an ECMA script language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let p be make basic object. Set p's essential internal methods, except friend, to the definitions specified in 10.5. It's callable. Target is true. Then a set p is specified in the 10th of May 2012. B if is constructor. Target is true. Then I set p is specified in the 10th of May 2013. Set p to target. Set p to handler. Return p. 12. ECMA International 2024. Note 1 a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11 ECMA script language. Source text. 1.1 source text syntax. Source character. Any Unicode code point. ECMA script so as text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMA script source text where permitted by the ECMA script grammars. The actual encodings used to store and interchange ECMA script source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMA script implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMA script implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMA script differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMA script program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMA script program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert. 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let CO1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 XD800. Let CO2 be the code unit whose numeric value is CP0 times 10,000. Modulo 0 times 400 plus 0 XDC00. Return a string concatenation of CO1 and CO2. ECMA International 2024 213 points. And returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1 3 static semantics, UTF-16 surrogate pair to code point, led, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0xd800. 0 times 400 plus trail 0xdc00 plus 0 times 10,000. Return the code point CP 1 1. For static semantics, code point it, string, position. The abstract operation code pointed takes arguments string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6, 1, 4, and reads from it a single code point starting with the code unit at index position, within string. And let CP be the code point whose numeric value is the numeric value of first. If the first is neither a leading surrogate nor a trailing surrogate, then I return the record, CP 1, full 6. If the first is a trailing surrogate or position plus 1 equals size, then I return the record, CP 1, true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then I return the record, CP 1, code points, string. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point it. String. Position be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International. 2024. 111. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMA script grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note to see also clause 17. 1.2 types of source code. There are 4 types of ECMA script code. Global code is source text that is treated as an ECMA script. The global code of a particular script does not include any source text that is passed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMA script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is passed to supply the value of the internal slots, C10.2, of an ECMA script function object. The function code of a particular ECMA script function does not include any source text that is passed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text matched by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024-215. Text that is passed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions, 15.2, arrow function definitions, 15.3, method definitions, 15.4, generator function definitions, 15.5, async function definitions, 15.8, async generator function definitions, 15.6, and async arrow functions, 15.9. Function code is also derived from the arguments to the function constructor, 2021. 1, the generator function constructor 27311, and the async function constructor 27711. Note 2, the practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues in the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1, 2, 2 strict mode code. Any CMA script syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4, 3, 2. Code is interpreted as strict mode code in the following situations. Capital G. Lobel code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMA script code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1, 2, 3 non-ECMA script functions. An ECMA script implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMA script source text. Whether a function object is defined with an ECMA script code or as a built-in function is not observable from the perspective of ECMA script code that calls or is called by such a function object. 2. ECMA script language. Lexical grammar. The source text of an ECMA script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element #bang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is us. And in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template
So like you can only like pass 127 bytes.
is used as the lexical goal symbol. Note the use of multiple
But you can pass like, could you pass like 127 bytes? 127 bytes. I bit my tongue. It's killing me.
alignment.
Can't really talk.
Literal are permitted. This
It's on fire.
C12
It's so freaking hot. I need a winter to come back.
up D where the first non-white space, non-comment,
So I don't know, you can pass in 127 bytes I guess.
solidus, and the syntactic
Also says we instruct
assignment.
to pass it into the
The line terminator. Above example is interpreted in the same way as up equal
shade or whatever.
map D syntax input element of white space line terminator comment token to punctuator right brace punctuate
Oh, this is so I hate this.
line terminator comment token right brace punctuator regular expression literal ECMA International 2024 217 capital I N P U T capital E L E M E N T capital R E G capital E X P capital O R capital T E M P L A T E capital T, A, white space, line terminator comment common token regular expression literal template substitution tail, input element template tail, white space, line terminator comment common token punctuated template substitution.
So let's check out a question.
Already XP, white space, line terminator comment common token hashbang comment regular expression literal 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right.
And it's avoiding what I asked it.
To control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In a CMA script source text, these code points may also be used in an identifier name after the first character. U plus F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding in byte order. ZWN, BSP, characters intended for this purpose can sometimes also appear after the start of a text, for example as a result of concatenating files. In a CMA script source text, ZWNBSP, code points are treated as white space characters. See 12.2, the special treatment of certain format control characters outside of comments. String literals, and regular expression literals is summarized in Table 35. Table 35, format control code point usage, code point, name, abbreviation, usage, U plus 200C, 0 width non-joiner, ZWNJ, identify part, U plus 200D, 0 width joiner, ZWJ, identify part, U plus FF, 0 width no break space, ZWNBSP, white space, 218, ECMA International 2024, 12.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of the literal value. They may also occur within a comment, but cannot appear within any other kind of token. The CMA script white space code points are listed in Table 36. Table 30.
Shut up, stupid.
Code points, name, abbreviation, U plus 0009, character tabulation, tab, U plus 000B, line tabulation, VT, U plus 000C, form feed, FF, U plus FF, 0 width no break space, ZWNBSP.
How do I send 2046 bytes?
USP, no 1 U plus 0020, space, and U plus 0080, no break space. Code points are part of USP syntax. Note.
I get that 128 is the limit.
CMA script white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. Zs, 2.3, white space, tab, VT, FF, ZWNBSP, USP, line terminators, like white space code points. Line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF. MCR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024-219. The CMA script line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U plus 000 line feed. LF. U plus 000D. Carriage return CR. U plus 2028. Line separator. LS. U plus 2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table Sequence. CR. LF. Is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax. Line terminator. LF. CRLS. PS. Line terminator sequence. LF. CR look ahead. LF. LS. PS. CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible. A single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important, because it implies that the presence or absence of single-line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of passing by the syntactic grammar. Syntax. Comment. Multi-line comment. Single-line comment. 20. ECMA International 2024. Multi-line comment. Multi-line comment charsopt. Multi-line comment chars. Multi-line not asterisk char. Multi-line comment charsopt. Post asterisk comment charsopt. Post asterisk comment chars. Capital M U L T I. Capital L I N E. Capital N O T. Capital F O R W A R D. Capital S L A S H. Capital O R. Capital A S T E. Multi-line comment charsopt. Post asterisk comment charsopt. Multi-line not asterisk char. Source character but not. Capital M U L T I. Capital L I N E. Capital N O T. Capital F O R W A R. Capital S L
I'm pretty sure this will work. So all I gotta do after this
R
is
S T E. Source character but not one of all. Single line comment. Single line comment charsopt. Single line comment char.
the image
Comment charsopt.
onto square. And I gotta like
Terminator. A number of productions.
edit the video to like cut out square. That'll be fun.
Comments. Hash.
A whole lot of fun.
Sensitive and like other types of comments are discarded.
So much fun. This is just, it's so exciting. I love this. This is how I want to spend all my time.
2 points.
I just love the GPU.
Identify.
It's just a great time.
Literal string literal T. Template. Note the
Super fun time.
literal. Right brace punctuator. And template substitution tail productions derive additional tokens that
Triangles are like the best
international
of all the geometric shapes.
7 names and
I mean, it's triangles, triangles,
interpreted according
and more triangles.
syntax given in Unicode standard and X number 31, identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMA script implementations. ECMA script implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax. Private identifier. Identifier name. Identifier name. Identifier start. Identifier name. Identifier part. Identifier start. Identifier start char. Unicode escape sequence. Identifier part. Identifier part char. Unicode escape sequence. Identifier start char. Unicode ID start. Underscore. Identifier part char. Unicode ID continue. ZWNJ. ZWJ. SCI letter. One of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not the Christ boxes. Unicode ID start. Any Unicode code point with the Unicode proper.
So let me get the desktop onto the quad, whatever.
TID continue. The
I just gotta get
Unicode escape sequences given in 1-2
the video, cut out the screen,
specifies specific code
put it inside of the square, and I'm done. I'm freaking done.
05F. Low line are permitted anywhere in an identifier name, and the code points U plus 200C, 0 width non-joiner.
Oh, it's 8 days long. It's so way too long.
Anywhere after the first code point of an identifier name. 22. Copyright sign. ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2. 7. 1 identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2 identifier names that are canonically equivalent accord to the Unicode standard and not equal unless, after replacement of each Unicode escape sequence, they are represented by the exact same sequence of code points. 2, 7, 1, 1 static semantics, early errors, identifier start, Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by
Advanced music.
action. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2, 7, 1, 2 static semantics. Identifier code points. The syntax directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following productions: identifier name, identifier start, let CP be identifier code, point of identifier start, return CP, identifier name, identifier part, let CPS be identifier code, points of the derived identifier name, let CP be identifier code, point of identifier part, return the list concatenation of CPS and CP, 2, 7, 1, 3 static semantics, identifier code point. The syntax-directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions: identifier start char, return the code point matched by identifier start char. Note 3: the sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identify part char, return the code point matched by identify part char. Unicode escape sequence, U hex 4 digits, return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence, U, code point, return the code point whose numeric value is the NV of code point. 2, 7, 2 keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed width font, in some syntactic production. The keywords of ECMA script include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts. And while a reserved word's await is reserved only inside async functions and modules, async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names: those that are always allowed as identifiers, and are not keywords, such as math, window, to string, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield. Those that are contextually allowed as identifiers, namely await and yield. Those that are contextually disallowed as identifiers, in strict mode code. Let, static, implements, interface, package, private, protected, and public. Those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax, reserved word, 1 of, await break case catch class const continue debugger default delete do, else element export extends false finally for function of import and instantia of new null return super switch this throw true try type of var void well with a yield. 24, ECMA International 2024. Note 1 per 5, 1, 5, keywords in the grammar match literal sequences of specific source character elements. A code point in a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13, 1, 1, 8, 6, 4, 1, 5, 2, 1, 1, 5, 5, 1, 1, 5, 6, 1, and 1, 5, 8, 1. 2.8 punctuator syntax. Punctuator, optional chaining punctuator. Other punctuator, optional chaining punctuator. Look ahead decimal digit. Other punctuator, 1 of, comma equals, 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 plus, percent plus plus, and, equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. The punctuator, equals sign. Right brace punctuator. 2.9 literals. 2, 9, 1 null literals syntax. Null literal, null. ECMA International 2024 225. 1, 2, 9, 2 boolean literals syntax. Boolean literal, true, false. 2, 9, 3 numeric literals syntax. Numeric literal separator. Numeric literal, decimal literal. Decimal big integer literal non-decimal integer literal. Plus sep, non-decimal integer literal. Plus sep, begin literal suffix legacy octa. L integer literal. Decimal big integer literal. 0 big int literal suffix. Non-zero digit decimal digits. Plus sep opt begin literal suffix. Non-zero digit numeric literal separator decimal digits. Plus sep, begin literal suffix. Non-decimal integer literal. Sep, binary integer literal sep. Octal integer literal sep. Hex integer literal sep. Begin literal suffix. N decimal literal. Decimal integer literal. Decimal digits. Plus sep opt exponent part. Plus sep opt. Decimal digits. Plus sep, exponent part. Plus sep opt. Decimal integer literal exponent part. Plus sep opt. Decimal integer literal. 0, non-zero digit numeric literal separator op decimal digits, plus sep, non-octal decimal integer literal, decimal digits, sep, decimal digit sep, decimal digit, plus sep, decimal digits, plus sep, numeric literal separator decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 26, ECMA International 2024, non-zero digit, 1 of 123,456,789, exponent part, sep, exponent indicator signed integer sep, exponent indicator, 1 of EE, signed integer, sep, decimal digit sep, binary integer literal, sep, 0b binary digit sep, 0b binary digit sep, binary digits, sep, binary digit sep, binary digit, plus sep, binary digits, plus sep, numeric literal separator binary digit, 1 of 0, 1, octal integer literal, sep, 0 low octal digit sep, 0 low octal digit sep, octal digits, sep, octal digit sep, octal digit, plus sep, octal digits, plus sep, numeric literal separator octal digit, legacy octal integer literal, 0 octal digit, legacy octal integer literal octal digit, non-octal decimal integer literal, 0 non-octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit non-octal decimal integer literal decimal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, 0 octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal digit, 1 of 89, ECMA International 2024 227, hex integer literal, sep, 0x hex digit sep, 0x hex digit sep, hex digits, sep, hex digit sep, hex digit, plus sep, hex digits, plus sep, numeric literal separator hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef A, B, C, D, E, F. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics, early errors, numeric literal, legacy octal integer literal decimal integer literal, non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy 2, 9, 3, 2 static semantics, MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal, E, where E is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and E is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and E is the MV of exponent part. The MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal 10e, where E is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digits 10n plus the MV of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal digits. Decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or of binary digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1. The MV of decimal digit. 2 or of non-zero digit. The MV of decimal digit. 3 or of non-zero digit. The MV of decimal digit. 4 or of non-zero digit. The MV of decimal digit. 5 or of non-zero digit, the MV of decimal digit. 6 or of non-zero digit, the MV of decimal digit. 7 or of non-zero digit, the MV of decimal digit. 8 or of non-zero digit, the MV of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit, or of hex digit. A is 10, the MV of hex digit. B or of hex digit. B is 11, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. E or of hex digit. E is 14, the MV of hex digit. F or of hex digit. F is 15, the MV of binary digits. Binary digits, binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits numeric literal separator binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digits. Octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal. Legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit. The MV of non-octal decimal integer literal. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L. Non-octal digit is the MV of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit. The MV of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L octal digit is the MV of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L times 10 plus the MV of octal digit. The MV of hex digits. Hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digit 16 plus the MV of hex digit 2 9 3 3 static semantics. Numeric value. The syntax directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions: numeric literal, decimal literal, return round MV result, MV of decimal literal, numeric literal, non-decimal integer literal, return MV of non-decimal integer literal, numeric literal, legacy octal integer literal, return MV of legacy octal integer literal, numeric literal, non-decimal integer literal big int literal suffix, return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229, decimal big integer literal, 0 big int literal suffix 1, return 0z, decimal big integer literal, non-zero digit big int literal suffix 1, return the big int value for the MV of non-zero digit, decimal big integer literal, non-zero digit decimal digits big int literal suffix, non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let nv be the MV of non-zero digit 10n plus the MV of decimal digits. Return z, MV 2 9 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. Also, oat points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code point may appear in the form of an escape sequence. String literals evaluate to ECMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as two code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, single string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, line terminator sequence, 30, ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit, legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFN RTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, x hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 129.3. Source character is defined in 11.1, ECMA International 2024-231. Note 2, LF. MCR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000 2 9 4 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text match by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2 9 4 to static semantics. SV, the syntax directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 129.3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, ls, is the string value consisting of the code unit 0 times 2028, line separator. The SV of double string character, ps, is the string value consisting of the code unit 0 times 2029, paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0 times 2028, line separator. The SV of single string character, ps, is the string value consisting of the code unit 0 times 2029, paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note 2, it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7, use strict. 32, copyright sign, ECMA International 2024, table 38. String single character escape sequences, escape sequence, code unit value, Unicode character name, symbol B 0 times 0008, backspace BS T 0 times 0009, character tabulation HT N 0 times 000 line feed LF V 0 times 000B, line tabulation VT F 0 times 000C, form feed FF R 0 times 000D, carriage return CR, double quote 0 times 0022, quotation mark, apostrophe 0 times 0027, apostrophe, backslash 0 times 005C, reverse solidus, comma. The SV of non-escape character, source character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence, legacy octal ease, cape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence, 8 is the string value consisting of the code unit 0 times 0038, digit 8, the SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0 times 0039, digit 9, the SV of hex escape sequence. X hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence. U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4, 3 static semantics, MV, the MV of legacy octal escape sequence. 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence. 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence. 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0, the MV of 0 to 3. 1 is 1, the MV of 0 to 3. 2 is 2, the MV of 0 to 3. 3 is 3, the MV of 4 to 7. 4 is 4, the MV of 4 to 7. 5 is 5, the MV of 4 to 7. 6 is 6, the MV of 4 to 7. 7 is 7, the MV of hex escape sequence. X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit plus 0 times 100 the MV of the second hex digit plus 0 times 10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input elements and are to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2 2 2 1. An implementation may extend the ECMA script regular expression grammar defined in 2 2 2 1, but it must not extend the regular expression body and regular expression flags. Productions defined below are the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars, empty, regular expression chars, regular expression char, regular expression first char, regular express. I am non-terminated but not one of or all. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, regular expression char, regular expression non-terminated but not one of or all. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars, empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminator but not one of, or, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U. Note 1: a regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate two regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. See 22.2 4. 34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char. 2, 9, 5. 1 static semantics. Body text. The syntax directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1, 2, 9, 5. To static semantics. Flag text. The syntax directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1, 2, 9, 6. Template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sop. Note: 2 regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use art. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $sign or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit. Decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead. Not code point. Hex digits. Sep. But only if MV of hex digits. 0 times 10FF. Code point. Hex digits. Sep. But only if MV of hex digits 0 times 10FF. Note: template substitution tail is used by the input element template tail alternative lexical goal 1, 2, 9, 6, 1 static semantics, TV. The syntax directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $sign, is the empty string. The TV of template middle, $sign, is the empty string. The TV of template tail is the empty string. The TV of template characters, template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character, $sign is the string value consisting of the code unit 0 times 0024, $sign, the TV of template character, template escape sequences, the SV of template escape sequence, the TV of template character, not escape sequences undefined, the TV of template character, line terminator sequences, the TRV of line terminator sequence, 236, copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequences, the empty string 1, 2, 9, 6, to static semantics, TRV. The syntax directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $sign, is the empty string. The TRV of template middle, $sign, is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $sign is the string value consisting of the code unit 0 times 0024, $sign, the TRV of template character, template escape sequences, the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence. The TRV of template character, not escape sequences, the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of not escape sequence. The TRV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0. The TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit. The TRV of not escape sequence, X, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter X. The TRV of not escape sequence, X hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter X, and the TRV of hex digit. The TRV of not escape sequence, U, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter U. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the TRV of hex digit. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit. The TRV of not escape sequence, U, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the code unit 0 times 007b, left curly bracket. The TRV of not escape sequence, U, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the code unit 0 times 007b, left curly bracket, and the TRV of not code point. The TRV of not escape sequence, U, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the code unit 0 times 007b, left curly bracket, and the TRV of code point. The TRV of decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence, non-escape character is the SV of non-escape character. The TRV of single escape character, 1 of BFN RTV is the result of performing UTF-16 encode code point on the single C ode point matched by this production. The TRV of hex escape sequence, X hex digit is the string concatenation of the code units 0 times 0078, Latin small letter X. The TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence, U hex 4 digits is the string concatenation of the code units 0 times 0075, Latin small letter U, and the TRV of hex 4 digits. The TRV of Unicode escape sequence, U, code point, is the string concatenation of the code units 0 times 0075, Latin small letter U, the code unit 0 times 007b, left curly bracket. The TRV.
I swear to God, chatbot is information hiding.
The code unit.
Where did it go? For fuck's sake.
The TRV of hex 4 digits. Hex digit is the string.
You can't look up certain shit.
The TRV of the second hex digit. The TRV of the third hex digit. And the TRV of the fourth hex digit. The TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digit.
Where's IBM?
The TRV of hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCDEF ABCDEF.
They removed it.
16 encode code point on the single code point matched by this production. The TRV of line continuation, line terminator sequences the string concatenation of the code units 0 times 005C, reverse solidus, and the TRV of line terminator sequence.
How do they have the power to do that?
Unit 0 times 000 line feed. The TRV of line terminator sequence. CR.
Wait, here it is.
Unit 0 times 000 line feed. The TRV of line terminator.
What was the other thing?
Is the string value consisting of the code unit 0 times 2028 line separator. The TRV of line terminator sequence. PS is the string value consisting of the code unit 0 times 2029 paragraph.
Okay, so this.
TRV of line terminator sequence.
It's like
F is the string value consisting of the code units 0 times 0
car cooter
2.10 automatic semicolon insertion.
or CDR.
Script statements and declarations must be terminated with a semicolon.
On the left hand side,
They always appear explicitly in the source text.
they explain it.
However,
CAR stands for contents of the address, part of the register.
described by
CDR stands for contents of the decrement, part of the register.
1 rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion.
So left hand side, it says in list, but linked list element is called a cons. It is a structure with 2 elements called car and CDR. It's a stupid joke. My other car is a CDR. So left hand side, they like describe it. They don't really describe it. On the right hand side, They actually describe it. It's like cons makes pair from two values. Car extracts the first element of that pair. CDR extracts the second element, often the tail of the list. When used in linked list, car returns the first list element, and CDR returns the rest of the list. The names come from hardware architecture of the IBM machines used to implement early Lisp. The IBM 704, 790 machines. It was a total waste of time. But they also like, I don't know, I found like a whole bunch of articles, and now they're not showing up anywhere. They had like the definition for orbit is hooked up to like satellites. I don't know, I found like a bunch of like really interesting articles from 1970s, 60s, and they all like, I can't find them now. It's a really, really slow computer. Chatbot used to like just find stuff really easy, and now it's like, I don't know. Chatbot's like information hiding. It says response 1, response 2. Response 1 has IBM in it. IBM. Response 2 doesn't. Response 1 does. No, response 1 doesn't, response 2 does. Because on the left-hand side, it doesn't say IBM at all. So it's like, maybe it's like the training data, and people either pick the option without IBM more, or they're trying to like, I don't know, this is weird. It's weird that IBM only shows up on one side of the choice. Used to not have a choice. It would show up as like one answer, and it had more info than this. This is like surface level. Used to say the guy's name. So they like removed all of the context, and the companies tied to it on the left hand side when compared to the right hand side. You can't just like remove the history. I don't know, it's freaking biased. Oh, that's what it's doing. Okay, so I'm gonna do like, I want to call something, whatever, the struct inside a union. I want to access it with like a common property. And this is I don't know, car CDR. We'll set up for that, whatever. I don't want to call it car. I thought it was like coup or something. I gotta give a name.
The internal method of a proxy exotic object so takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a Boolean value. Applied to the proxy object must return the same value as. Applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a Boolean value. Applied to the proxy object only returns true if applied to. The proxy object's target object is false. 2. Perform. Validate non-revoke proxy, O. let target BO 06 ECMA International 2024. 3. Let handler BO assert handler is an object. Let trap B get method handler get own property descriptor. If trap is undefined, then a return target P. Let trap result OBJB call trap handler
Well, unit, but UNT.
OBJ is not undefined.
So get rid of the I.
Target desk B target P 0. If trap result OBJ is
Then it's almost like,
undefined.
I don't know, like union.
Target desk is false. Throw a type error exception. C. Let extensible target B is extensible. Target D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible
Spells cunt.
target
I'll do that.
to property descriptor. Trap result OBJ 3.
This will be the union,
Desk 4.
XS, GCUNT,
Extensible target result desk target desk
the XS what it holds, which is a struct.
exception 6. If result desk is false, then if target desk is undefined or
Really, I don't need to go through
a type error
this property because you can like access the sub-properties by their name.
if target desk is true, throw a type error exception.
I don't know how to do this.
Result desk. Note the proxy objects enforces the following invariance. The result must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property
Maybe like US for like union struct,
non-configurable own
union struct.
be reported as both non-configurable and non-writable unless it exists as a non-configurable
Oh, that's easier to read.
property of the target object. 0, 5, 6, P, desk. The internal method of a proxy exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target BO. Let handler BO. Assert. Handler is an object. Let trap B. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desk. Let desk OBJB from property descriptor. Desk. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desk OBJ. If boolean trap result is false, return false. 0. Let target desk be target. P. ECMA International 2024 207. 11. Let extensible target B is extensible. Target 2. If desk has a field and desk is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desk is undefined, then A. If extensible target is false, throw a type error exception. B. If setting config false is true, throw a type error exception. 5. Else A. If is compatible property descriptor extensible target desk target desk is false, throw a type error exception. B. If setting config false is true and target desk is true, throw a type error exception. C. If is data descriptor target desk is true, target desk is false, and target desk is true, then I. If desk has a field and desk is false, throw a type error exception. 6. Return true. Note the proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be added if the target object is not extensible. A property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target BO. Let handler BO. Proxy handler. Assert. Handler is an object. Let trap B. Get method. Handler has. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desk be target. P. B. If target desk is not false.
Really? The sound stopped working?
Extensible target B is extensible.
Everything sucks.
It is false. Throw a type error except
I gotta like undo everything.
08. ECMA International 2024.
I don't know where I left off.
Following invariant
Got way too distracted looking for stupid crap on chatbot.
exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy O. Let target BO. Let handler BO. Assert. Handler is an object. Let trap B. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false, then if is data descriptor target desk is true and target desk is false, then I have same value. Trap result. Target desk is false. Throw a type error exception. B. If is accessor descriptor target desk is true in target desk. 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Up. Handler.
It said that it's like C, but it's not. I can't put that in there.
Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor, target desk, is true and target desk is false, then I have same value, V, target desk, is false. Throw a type error exception, B if is accessor descriptor, target desk, is true, then I have target desk, 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable
Well, that's fine.
own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0, P.
I'm not passing these args.
So takes argument P, a property key, and returns
I don't know. Get this done.
for completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. 4. Return true.
I'm just gonna put the stupid image on it.
The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method
It's too much yellow.
takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let T. Arget be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible. Target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key. B if desk is not undefined and desk is false, then I append key to target non-configurable keys. C else I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception, be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception, be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let array be create array from list. Arguments list. Return. Call. Trap. Handler. Target.
Put commas instruct.
To proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024-211. The 10th of
Oh, you don't.
arguments list. New target.
God.
Proxy exotic object O takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal complete
How could it possibly have that many errors for one struct?
form. validate non-revoke proxy, O, let target be O, assert, is construct,
What is going on?
handler be O, assert, handler is an object, let trap be, get method, handler, construct, if trap is undefined, then a return, construct, target, arguments list, new target, let array be create array from list, arguments list, let new obj be, call, trap, handler, target, array, new target, 0, if new obj is not an object, throw a type error exception, 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The resultive must be an object. 0, 5, 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, any CMA script language value, and handler, any CMA script language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let PB make basic object. Set P's essential internal methods, except friend, to the definition specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target, set P to handler, return P, 12, ECMA International 2024. Note 1 A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11 ECMA script language. Source text. 1.1 source text syntax. Source character. Any Unicode code point. ECMA script so, as text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMA script source text where permitted by the ECMA script grammars. The actual encodings used to store and interchange ECMA script source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMA script implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMA script implementations are not required to perform any normalization
Oh my god, what the heck?
of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMA script differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode
Oh, it's defined for the headers. For the headers. This isn't. Oh, this is the.
which is
It's in the main. I wonder.
008 to cause a line feed, LF, to be
Gotta move it into the call.
in an ECMA script program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMA script program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP 0 times 10FF. If CP 0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let Co1 be the code unit whose numeric value is floor. CP 0 times 10,000. 0
Yeah, I hate everything. C is stupid.
whose numeric value is CP 0 times 10,000, modulo 0 times 400 plus 0 XDC 00. Return a string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static semantics. Code points to string, text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6, 1, 4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1 3 static semantics. UTF-16 surrogate pair to code point, led, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0 XD800. 0 times 400 plus trail 0 XDC 00 plus 0 times 10,000. Return the code point CP. 1 4 static semantics. Code point it. string, position. The abstract operation code pointer takes arguments string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6, 1, 4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string, assert, position 0 and position, size. Let first be the code unit at index position within string, and let CP be the code point whose numeric value is the numeric value of first. If the first is neither a leading surrogate nor a trailing surrogate, then I return the record, CP, 1, full 6. If the first is a trailing surrogate or position plus 1 equals size, then I return the record, CP, 1, true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then I return the record, CP, 1, true. Set CP to UTF-16 surrogate pair to code point, first, second, 0, return the record, CP, 2, false, 1, 1, 5 static semantics, string to code points, string. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6, 1, 4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string. Position be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International. 2024. 111. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMA script's grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note to see also clause 17. 1.2 types of source code. There are 4 types of ECMA script code. Global code is source text that is treated as an ECMA script. The global code of a particular script does not include any source text that is passed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMA script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is passed to supply the value of the internal slots, C10.2, of an ECMA script function object. The function code of a particular ECMA script function does not include any source text that is passed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text matched by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024-215. Text that is passed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions, 15.2, arrow function definitions, 15.3, method definitions, 15.4, generator function definitions, 15.5, async function definitions, 15.8, async generator function definitions, 15.6, and async arrow functions, 15.9. Function code is also derived from the arguments to the function constructor 20, 2, 1, 1, the generator function constructor 27, 3, 1, 1, and the async function constructor 27, 7.1.1. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1. 2. 1 directive prologues in the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1. 2. 2 strict mode code. Any CMA script syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4. 3. 2. Code is interpreted as strict mode code in the following situations. Capital G. Loggle code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMA script code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1. 2. 3 non-ECMA script functions. An ECMA script implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMA script source text. Whether a function object is defined with an ECMA script code or as a built-in function is not observable from the perspective of ECMA script code that calls or is called by such a function object. 2. ECMA script language. Lexical grammar. The source text of an ECMA script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element hashbang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, goal is us. Add in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: up equals b high g exec, cmap, d, where the first non-white space, non-comment code point after a line terminator is u plus 002 f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as up equals b high g exec, cmap, d, syntax, input element div, white space, line terminator comment token div punctuator right brace punctuator, input element regexp, white space, line terminator comment token right brace punctuator regular expression literal, ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E.
Now I can finally run it.
Expression literal template substitution tail. Input element template tail. White space. Line terminator comment comment.
I have to do one more thing again.
Tail. Input element hashbang or regexp.
Put this back up there.
Nator comments comment token hashbang comment regular expression literal 2.
I don't think I had to move it now. I thought it was the slashes, whatever. Set up. I guess not.
The base such as left to right mark or right to left mark are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters.
Okay. It should just work.
Template literals.
It should just like work. It didn't work.
And U+200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMA script source text, these code points may also be used in an identifier name after the first character. U+F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding in byte order. ZWN, BSP, characters intended for this purpose can sometimes also appear after the start of a text, for example as a result of concatenating files. In ECMA script source text, ZWNBSP, code points are treated as white space characters. See 12.2, the special treatment of certain format control characters outside of comments. String literals and regular expression literals is summarized in Table 35. Table 35, format control code point usage. Code point, name, abbreviation, usage, U+200C, 0 width non-joiner, ZWNJ, identify part, U+200D, 0 width joiner, ZWJ, identify part, U+F, 0 width no break space, ZWNBSP, white space, 218, ECMA International 2024, 12.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other.
Oh, I want to be done. This is so annoying.
May occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of the literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMA script white space code points are listed.
That's not...
X, white space code.
Oh, I didn't apply it yet.
Abbreviation, U+0009, character tabulation, tab, U+000B, line tabulation, VT.
Please work. I want to be done. I think it'll work. It should work.
0 width no breaks.
So it's just multiplying the one X or Y, I guess X,
Space,
by the ratio
no break space, code,
to scale it.
tax, note 2.
And other side's like a unit of 1, so it doesn't have to do both, I guess.
Intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator.
So it's going to scale one of the axes.
FF, ZWNBSP, OSP, line terminators, like white space.
Yes! Finally!
To improve source text readability and to separate tokens, indivisible.
Now I just gotta put a freaking display desktop capture on that. Freaking almost done at that point. I gotta like get the video now and like cut the center of the video and put it in the video, pixelate it, then it's done. Almost done.
Then any token except a string literal, template, or template.
This is finally the last stream. This will be freaking done on a freaking...
Terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code.
Closer to getting to standard, because there's still a couple other things I gotta freaking do. Damn it. Oh, BRB.
Table 37, Table 37, line terminator code points, code point, Unicode name, abbreviation, U+000, line feed, LF, U+000D, carriage return CR, U+2028, line separator, LS, U+2029, paragraph separator, PS, only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence, CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax, line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF, LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible. A single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important, because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax, comment, multi-line comment, single line comment. 20. ECMA International 2024. Multiline comment. Multiline comment charsopt. Multiline comment chars. Multiline not asterisk char. Multiline comment charsopt. Post asterisk comment charsopt. Post asterisk comment chars. Capital M U L T I. Capital L I N E. Capital N O T. Capital F O R W A R D. Capital S L A S H. Capital O R. Capital A S T E. Multiline comment charsopt. Post asterisk comment charsopt. Multiline not asterisk char. Source character but not. Capital M U L T I. Capital L I N E. Capital N O T. Capital F O R W A R D. Capital S L A S H. Capital O R. Capital A S T E. Source character but not one of all. Single line comment. Single line comment charsopt. Single line comment chars. Single line comment char. Single line comment charsopt. Single line comment char. Source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 hashbang comments. Hashbang comments are location sensitive and like other types of comments are discarded from the stream of input elements for the syntactic grammar. Syntax. Hashbang comment. Single line comment charsopt. 2.6 tokens syntax. Common token. Identifier name. Private identifier punctuator numeric literal string literal T. Template. Note the punctuator. Regular expression literal. Right brace punctuator. And template substitution tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221. 12.7 names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31. Identifier and pattern syntax. With some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode Standard. The Unicode code points and the specified categories in the latest version of the Unicode Standard must be treated as in those categories by all conforming ECMA script implementations. ECMA script implementations may recognize identifier code points defined in later editions of the Unicode Standard. Syntax. Private identifier. Identifier name. Identifier name. Identifier start. Identifier name. Identifier part. Identifier start. Identifier start char. Unicode escape sequence. Identifier part. Identifier part char. Unicode escape sequence. Identifier start char. Unicode ID start. Underscore. Identifier part char. Unicode ID continue. ZWNJ. ZWJ. A SI letter. One of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not but have boxes. Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequences given in 129.4. Note 1. This standard specifies specific code point additions, U plus 0024, $, and U plus 005F. Low line are permitted anywhere in an identifier name, and the code points U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner. Are permitted anywhere after the first code point of an identifier name. 22. Copyright sign, ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2. 7. 1. Identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2. Identifier names that are canonically equivalent accord to the Unicode standard and not equal unless, after replacement of each Unicode escape sequence, they are represented by the exact same sequence of code points. 2. 7. 1. 1. Static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier start char lexical grammar production. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2. 7. 1. 2. Static semantics. Identifier code points. The syntax directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following productions. Identifier name, identifier start. And let CP be identifier code point of identifier start. Return CP, identifier name, identifier part. Let CPS be identifier code points of the derived identifier name. And let CP be identifier code point of identifier part. Return the list concatenation of CPS and CP. 2. 7. 1. 3. Static semantics. Identifier code point. The syntax directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions. Identifier start char, return the code point matched by identifier start char. Note 3 the sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identify part char, return the code point matched by identify part char. Unicode escape sequence, U hex 4 digits, return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence, U, code point, return the code point whose numeric value is the NV of code point. 2, 7, 2 keywords and reserved words. A keyword is a token that matches identify name, but also has a syntactic use. That is, it appears literally, in a fixed width font, in some syntactic production. The keywords of ECMA script include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts. And while a reserved words await is reserved only inside async functions and modules, async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names, those that are always allowed as identifiers, and are not keywords, such as math, window, to string, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield, those that are contextually allowed as identifiers, namely await and yield, those that are contextually disallowed as identifiers, in strict mode code, let, static, implements, interface, package, private, protected, and public. Those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax, reserved word, 1 of, await break case catch class const continue debugger default delete do, else enum export extends false finally for function of import and instantia of new null return super switch this throw true try type of var void well with a yield. 24, ECMA International 2024, note 1 per 5, 1, 5, keywords in the grammar match literal sequences of specific source character elements. A code point and a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1. 1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13, 1, 1, 8, 6, 4, 1, 5, 2, 1, 1, 5, 5, 1, 1, 5, 6, 1, and 1, 5, 8, 1. 2.8 punctuator syntax. Punctuator, optional chaining punctuator, other punctuator, optional chaining punctuator, look ahead decimal digit, other punctuator, 1 of, comma equals, 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 plus, percent plus plus, and, equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. The punctuator, equals sign, right brace punctuator, 2.9 literals, 2, 9, 1 null literal syntax, null literal, null, ECMA International 2024 225, 1, 2, 9, 2 boolean literal syntax, boolean literal, true, false, 2, 9, 3 numeric literal syntax, numeric literal separator, numeric literal, decimal big integer literal non-decimal integer literal, plus sep, non-decimal integer literal, plus sep, big int literal suffix legacy octa, L integer literal, decimal big integer literal, 0 big int literal suffix, non-zero digit decimal digits, plus sep oct big int literal suffix, non-zero digit numeric literal separator decimal digits, plus sep, big int literal suffix, non-decimal integer literal, sep, binary integer literal sep, octal integer literal sep, hex integer literal sep, big int literal suffix, n decimal integer literal, decimal digits, plus sep opt exponent part, plus sep opt, decimal digits, plus sep, exponent part, plus sep opt, decimal integer literal exponent part, plus sep opt, decimal integer literal, 0 non-zero digit numeric literal separator opt decimal digits, plus sep, non-octal decimal integer literal, decimal digits, sep, decimal digit sep, decimal digit, plus sep, decimal digits, plus sep, numeric literal separator decimal digit, 1 of 0 1 2 3 4 5 6 7 8 9, 26. ECMA International 2024. Non-zero digit. 1 of 123,456,789. Exponent part. SEP. Exponent indicator signed integer SEP. Exponent indicator. 1 of EE. Signed integer. SEP. Decimal digit SEP. Decimal digit SEP. Decimal digit SEP. Binary integer literal. SEP. 0b binary digit SEP. 0b binary digit SEP. Binary digits. SEP. Binary digit. Binary digit SEP. Binary digit. Plus SEP. Binary digits. Plus SEP. Numeric literal separator binary digit. Binary digit. 1 of 0 1. Octal integer literal. SEP. 0 low octal digit SEP. 0 low octal digit SEP. Octal digits. SEP. Octal digit. Octal digit SEP. Octal digit. Plus SEP. Octal digits. Plus SEP. Numeric literal separator octal digit. Legacy octal integer literal. 0 octal digit. Legacy octal integer literal octal digit. Non-octal decimal integer literal. 0 non-octal digit. Capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit non-octal decimal integer literal decimal digit. Capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, 0 octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal digit, 1 of 89, ECMA International 2024 227, hex integer literal, SEP, 0x hex digit SEP, 0x hex digit SEP, hex digits, SEP, hex digit SEP, hex digit, plus SEP, hex digits, plus SEP, numeric literal separator hex digit, 1 of 0 1 2 3 4 5 6 7 8 9 abdef ABCDEF. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics, early errors, numeric literal, legacy octal integer literal, non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note to non-strict code. This syntax is legacy. 2, 9, 3, 2 static semantics. MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. E, where E is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator and D is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal digits. Decimal digits is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or of binary digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1. The MV of decimal digit. 2 or of non-zero digit. The MV of decimal digit. 3 or of non-zero digit. The MV of decimal digit. 4 or of non-zero digit. The MV of decimal digit. 5 or of non-zero digit. The MV of decimal digit. 6 or of non-zero digit. The MV of decimal digit. 7 or of non-zero digit. The MV of decimal digit. 8 or of non-zero digit. The MV of decimal digit. 9 or of non-zero digit. Or of hex digit. 2 or of octal digit. 2 is 2. 3 or of hex digit. 3 or of octal digit. 3 is 3. 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit, or of hex digit. A is 10, the MV of hex digit. B or of hex digit. B is 11, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. E or of hex digit. E is 14, the MV of hex digit. F or of hex digit. F is 15, the MV of binary digits. Binary digits is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits numeric literal separator binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal. Legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit. The MV of non-octal decimal integer literal. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L. Non-octal digit is the MV of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit. The MV of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L octal digit is the MV of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L times 10 plus the MV of octal digit. The MV of hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digits 16 plus the MV of hex digit 2 9 3 3 static semantics. Numeric value. The syntax directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions: numeric literal, decimal literal, return round MV result, MV of decimal literal, numeric literal, non-decimal integer literal, return MV of non-decimal integer literal, numeric literal, legacy octal integer literal, return MV of legacy octal integer literal, numeric literal, non-decimal integer literal big int literal suffix, return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229, decimal big integer literal, 0 big int literal suffix 1, return 0z, decimal big integer literal, non-zero digit big int literal suffix 1, return the big int value for the MV of non-zero digit, decimal big integer literal, non-zero digit decimal digits big int literal suffix, non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let NV be the MV of non-zero digit 10n plus the MV of decimal digits. Return Z, MV 2 9 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. Also, oat points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as two code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, single string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, line terminator sequence. 30. ECMA International 2024. Escape sequence. Character escape sequence. Look ahead decimal digit. Legacy octal escape sequence. Non-octal decimal escape sequence. Hex escape sequence. Unicode escape sequence. Character escape sequence. Single escape character. Non-escape character. Single escape character. One of BF and RTV. Non-escape character. Source character but not one of escape character or line terminator. Escape character. Single escape character. Decimal digit. XU. Legacy octal escape sequence. 0. Look ahead. 8, 9, non-zero octal digit. Look ahead octal digit. 0 to 3 octal digit. Look ahead octal digit. 4 to 7 octal digit. 0 to 3 octal digit. Non-zero octal digit but not 0. 0 to 3. 1 of 0, 1 to 3. 4 to 7. 1 of 4567. Non-octal decimal escape sequence. 1 of 89. Hex escape sequence. X hex digit. Unicode escape sequence. U hex 4 digits. U code point. Hex 4 digits. Hex digit. The definition of the non-terminal hex digit is given in 1, 2, 9, 3. Source character is defined in 11.1. ECMA International 2024 231. Note 2, LF. MCR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000 2 9 4 1 static semantics. Early errors. Escape sequence. Legacy octal escape sequence. Non-octal decimal escape sequence. It is a syntax error if the source text match by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2 9 4 to static semantics. SV. The syntax directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1, 2, 9, 3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, ls, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of double string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of single string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence. 0 is the string value consisting of the code unit 0 times 0000, null. The SV of character escape sequence. Single escape character is the string value consisting of the code unit whose numeric value is determined by
All I gotta do
into table 38.
is plaster or paint.
Strict directive
However,
mode and
apply
to enforce the above rules for such literal
the desktop screen capture to the square that's spinning, the rectangle that's spinning,
copyright sign
and that's it. That's basically it. Well,
character escape sequences escape sequence code unit value Unicode character
I also have to like
times 0008 backspace bst 0 times 00
download this video off YouTube,
0 times 000
find a video editor for Linux,
times 00
cut out the middle of the picture, whatever,
C form feed ffr 0 times 00
and apply that over top.
cr double quote 0 times 0022 quotation mark apostrophe
Then it's done.
apostrophe backslash 0 times 005
So I'll actually be done this stream. Like finally, actually done.
result of performing UTF-16 encode.
Then it's on the standards. Well,
The SV
I still have to install Arch or
string value consisting
Raspberry on the Pi.
sequence
The what's it called?
small escape sequence
Raspberry Pi 4 or something.
unit 0 times 0038 digit 8
I don't know. Then standard or whatever.
string value consisting of the
Almost done. Or almost done getting to being done because it took a whole freaking week.
value consisting of the code unit whose
I would have given up, but I literally need this stupid program.
Hex digit, hex digit, hex.
The only reason that I finished it.
Caret value is the
This is, I have not learned anything about math.
code.
I have not learned anything about anything
Point on the MB of
other than
template escape sequence. 0 is the string value.
that
0 times 0, 0, 0.
it's a triangle world
4. 3.
in GPU land.
The MB of legacy octal escape sequence. 0 to 3 octal digit is 8 times the MB of 0.
All that exists are triangles.
MB of legacy octal escape sequence. 4 to 7 octal.
Squares a triangle. Oh, it's gone.
The MB of octal digit. The MB of legacy octal escape sequence.
Oh, I had to restart. Well, this is here.
Digit is 64. That is 82 times the MB.
I learned about the pipeline
MB of the second octal digit. The MB
and
is 0. The MB of 0 to 3.
a whole bunch of stuff that isn't really relevant to anything.
3.
I didn't actually compute any of this.
MB of 4 to 7.
In fact, I feel dumber
4 to 7. 6 is
because I didn't learn anything.
7. The MB of hex escape sequence.
I literally feel dumber.
16 times the MB of the first hex digit plus the MB of the second
I
hex.
just plugged in functions, function names, and it's all done for me.
0 times 1000 the MB of the first hex digit plus 0 times 100 the MB
That's probably why people are getting dumber,
hex digit plus the MB.
because they don't have to know anything.
International 2024 233 1 2 9 5 regular expression
Like, of course you have to know the collection of structures,
elements.
data types, the ordering,
The source text
but you're not actually doing anything
is subsequent
other than mixing up a pre-made book.
expression grammar 2 2 2
You can say the same about assembly
CNA script regular expression grammar defined
and CPU hardware,
but it must not extend the regular
but you can't really, because it's completely different. It's actually, I don't know.
for his production
This was terrible. This was like the worst 8 days ever.
regular expression flags
But not really, that's just an exaggeration.
expression jars regular expression
Yeah, no, I've had worse days.
regular expression
Like way worse days.
regular express iron non-terminated but not one of all capital R E G U L A R
I gotta focus and get done.
R E S S I O N
I need more pop. So
E G U L A R capital E X P R E S S I O N capital B A C K
there's a couple places where like
H capital S E Q regular
it's doing like redundant writes
source character but not line terminated
and stuff. I have to turn those off.
expression class chars
And it should I don't know.
expression class chars regular expression class
I'm not gonna optimize anything or change anything. I'm just gonna leave it for now and get it running.
E U
That's my goal.
R capital E X P R E S S I O N capital B A C K S L A S H
But I am gonna wrap this in a bubble.
U. Note 1 a regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate to regular expression objects that never compare,
And later on I'll
even if the two literals' contents are identical.
set a boolean
Will be created at runtime by new regexp
to indicate if the struct had changed.
2 2 4 34 ECMA International 2024 regular expression flags empty.
So it'll only like reassign the properties if there's a change.
Semantics body text. The syntax directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1.
I don't know, yeah.
5. To static semantics. Flag text. The syntax directed operation flag text takes no arguments and returns
So it goes like change
following productions:
or
regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1 2 9 6 template literal lexical components syntax
attention.
substitution template head no substitution template character sop template head
It doesn't matter, I'll just do that.
tail template middle, template tail, template middle, template character sop, $, template tail, template character sop, template characters, template character, template character sopt. Note 2 regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use Dart, ECMA International 2024-235, template character, look ahead, template escape sequence, not escape sequence, line continuation, line terminator sequence, source character but not one of or $, or line terminator, template escape sequence, character escape sequence, look ahead decimal digit, hex escape sequence, Unicode escape sequence, not escape sequence, 0 decimal digit but not 0, X, look ahead hex digit, X hex digit, look ahead hex digit, U, look ahead hex digit, look ahead, U hex digit, look ahead hex,
A big boost structure after it.
look ahead hex digit, U hex digit, hex digit, hex digit, look ahead,
But it's in a union, so it'll collapse.
digit, U, not code point, look ahead hex digit,
So we need to like...
look ahead hex digit, look ahead, not code point, hex digits, sep,
Alright, I'm not gonna do anything complicated right now.
F, code point, hex digits, sep, but only if
I don't even remember. I don't like remember everything off the top of my head.
template tail alter,
So I gotta get back into whatever.
9, 6,
Or whatever.
TV. The syntax directed operation TV takes no arguments and returns a string or undefined. A template literal
I'll make this like a single line.
of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail is the empty string. The TV of template characters, template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character, $, is the string value consisting of the code unit 0 times 0024, $, the TV of template character, template escape sequences, the SV of template escape sequence, the TV of template character, not escape sequences undefined, the TV of template character, line terminator sequences, the TRV of line terminator sequence, 236, copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequences, the empty string 1, 2, 9, 6, to static semantics, TRV, the syntax directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type.
Oh, this way it's colorized.
Components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $, is the empty string. The TRV of template middle, $, is the empty string. The TRV of
So I'll set this boolean to on.
characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $, is the string value consisting
And it's calling a function to get the time.
$, the TRV
It's ridiculous.
template escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence, the TRV of template character, not escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus.
So we'll like save the last result maybe.
0 is the string value consisting of the code unit 0 times 0030, digit 0, the TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit. The TRV of not escape sequence, X, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter X. The TRV of not escape sequence, X hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078,
Feels like trip time. I don't know.
The TRV of not escape sequence, U, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small
I'll set
TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the TRV of hex digit. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of not escape sequence, U hex digit,
I'll compare the trip time to the actual time result.
unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit. The TRV of not escape sequence, U, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the code unit 0 times 007B, left curly bracket. The TRV of not escape sequence, U, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 0 0.
And then I can like
The code unit
make it only enter like
bracket.
when the time is changed by like over like 0.50 of a second or something. I don't know.
The string concatenation of the code
Just for like testing. Later on I can like actually set it up for real.
7b, left curly bracket, and the TRV of code point, the TRV of decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8.
I gotta get this stupid picture on the rectangle now.
Point matched by this production, the TRV of character escape sequence, non-escape character is the SV of non-escape character, the TRV of single escape character, 1 of BFN RTV is the result.
So like time resolve
Code point on the single C, O's point matched by this production, the TRV of hex escape sequence,
plus 0.5
of the code units, 0.
or like 0.1 maybe.
The TRV of the first hex digit, and the TRV of the second hex digit, the TRV of Unicode escape sequence, U hex 4 digits is the string concatenation of the code units, 0 times 0075, Latin small letter U, and the TRV of hex 4 digits, the TRV of Unicode escape sequence, U, code point, is the string concatenation of the code units, 0 times 0075, Latin small letter U, the code unit 0 times 007b, left curly bracket, the TRV of ECMA International 2024 237, code point, and the code unit 0 times 007d, right curly bracket, the TRV of hex 4 digits. Hex digit, hex digit, hex digit, hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit, the TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 A, B, C, D, E, F. A, B, C, D, E, F is the result of performing UTF-16 encode code point on the single code point matched by the
And then
continuation, line terminator sequences the
oh, this is so boring.
0 times 005C, reverse solidus, and the TRV of line terminator sequence, the TRV of line terminator sequence, LF, is the string value consisting of the code unit 0 times 000 line feed, the TRV of line terminator sequence,
I guess check this lesson.
the code unit 0 times
Can I roll over the timer?
TRV of line terminator sequence, LS, is the string value consisting of the code unit 0 times 2028, line separator, the TRV of line terminator sequence, PS, is the string value consisting of the code unit 0 times 2029, paragraph separator, the TRV of line terminator sequence, CRLF, is the string value consisting of the code units 0 times 000 line feed, 2.
It's an N64.
On insertion, most ECMA script statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.1.0.1 rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of
I'll say the int instead of the float. I'll name it to like granularity or something. Granular time or resolution. Adjust. Trip. Let's copy. Sorry, taking me too long to set up. So I got that. Set this here. So now if the seconds change, or what is it, milliseconds or nanoseconds are less than whatever the current is. Nanoseconds copy. Alright, so now whenever the nanoseconds are less than the now nanoseconds, I'll add 0.1, wrap it. This way it only ever has to sign when it enters. I'll OR this with I'll do the second test first. I'll like XOR the seconds. So it's not a less than or greater than test, it's just if the second count changed, then that's it. Then we don't gotta worry about if it's less than or equal to 0. So if the seconds end up wrapping around and it ruins the test, the seconds will change, so they'll catch any wraparound. So I can just do a simple less than test. I mean, what is up with the freaking input? So this XOR seconds now. So seconds now XOR the last seconds in parentheses or the triangle trip time in nanoseconds plus 0.1. So that's less than nanoseconds now. Then it's true that nanoseconds now has exceeded past nanoseconds then plus 0.1. That way, when it starts off initially, it'll be 0 for seconds now. And then it's not going to be 0 for the actual time that it gets. So when it does the comparison, it'll enter. And then continue ticking on from there. And only has to sign when it enters. What do I assign? Oh, the Boolean. And then I'll set this to on. It's a tension variable. Set it to not equal 0. I could do true or false. I don't know, I'm gonna do this instead. Where it's not like, because true means true, false means false, but it's based on context. If it's 0 or not 0, that's like literal, if that makes sense. I don't know. I want to test for the 0 for EQZ or any Z. I don't know, I never tried this. I'm gonna try this, whatever. Is that true or false? Set it back to equal 0. Any errors? Yes, there's errors. Is it 1,000 nanoseconds in a second? How many nanosec in a sec? It's 1,000. That's not what I'm asking. Oh my god. That's what I'm asking. chatbot wrong. I hate chatbot. Okay, so it works. I want to get like choppy. It's not choppy yet. There we go. So later on I can fine tune or whatever. But I still need to like wrap other structures and parts of the code to only enter at points where something changed or something needs to be modified. I'll do it later. This is good enough. This is like a reminder, whatever. I think the counter's overflowing. It's not doing exactly what I think. Oh well. It's doing like the opposite. maybe. it doesn't enter enough times to make this test worth it. Alright, so I'm save it back up. All I gotta do is put the image on it. I can optimize what's being called when and where later. It'd be best to do this inside here. Make this not and inside the else case, have it do the assignment. Otherwise, do an early return. This way, the true case, if it ever enters more than once, the whole point would be to like see if I'm doing work. This way it'd fall through on the case that it enters too many times before the granularity has been reached. I think I could also do like the module operator. I don't know how this works. And I shouldn't optimize because, yeah. Alright, I'm gonna put the video on the square. Or the quad, whatever it's called. How long is this stream? $8, man. I gotta find some music. Alright, I'm gonna get this done though.
0.4 built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMA script function objects listed in table 30. Instead, they have the internal slots listed in table 31, in addition to table 31, internal slots of bound function exotic objects. Internal slot type, description, bound target function, a callable object, the wrapped function object. Bound this, an ECMA script language value, the value that is always passed as the this value when calling the wrapped function. Bound arguments, a list of ECMA script language values, a list of values whose elements are used as the first arguments to any call to the wrapped function. 86, ECMA International 2024, 10411. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let target be f, let bounds this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target, return. Construct, target, args, new target, 0, 4, 1, 3 bound function create, target fun, Cheyenne, bound this, bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMA script language value, and bound args, a list of ECMA script language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of, and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1, 0, 4, 1, 1. If this constructor, target function, is true, then a set obj as described in 1, 0, 4, 1, 2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return. Array set length, a, desc. Else if p is an array index, then a let length desc the ordinary get own property, a, length, b assert, is data descriptor, length desc, is true, c assert, length desc, urable, is false, d let length be length desc, e assert, length is a non-negative integral number, f let index b. 32, p, g if index length and length desc is false, return false, h let succeeded b. Ordinary define known property, a, p, desc, I have succeeded is false, return false, j if index length, then I set length desc to index plus 1, 2. Set succeeded to, ordinary define known property, a, length desc, 3. Assert, succeeded is true, k return true, return. Ordinary define known property, a, p, desc, 0, 4, 2. To array create, length, proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proton object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232.1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform. Ordinary define known property a length. Property descriptor length true false false. Return a 0 4 2 3. Array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If is array is false, return array create length. Let c be get original array constructor. If this constructor C is true, then 88 ECMA International 2024. Let this realm be the current realm record. B let realm be get function realm C. See if this realm and realm are not the same realm record. Then I have same value C realm is true. Set C to undefined. If C is an object, then I set C to get C at species. B if C is null, set C to undefined. If C is undefined, return array create length. If this constructor C is false, throw a type error exception. Return construct C length 0 4 2 4. Array set length a desk. The abstract operation array set length takes arguments a an array and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary define known property a length desk. Let new len and desk be a copy of desk. Let new len be 232 desk. Let number len be the number desk. If same value 0, new len number len is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property a length. Assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return ordinary define known property a length new len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else a note setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be ordinary define known property a length new len desk. 6. If succeeded is false, return false. 7. For each own property key p of a such that p is an array index and 32 p new len in descending numeric index order. Do a let delete succeeded b a p b if delete succeeded is false, then I set new len desk to 32 p plus 1 2. If new writable is false, set new len desk to false. 3. Perform ordinary define known property a length new len desk. 5. Return false. 8. If new writable is false, then assert succeeded to ordinary define known property a length property descriptor false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have internal slot 1 0, 4, 3, 1, p. The internal method of a string exotic object s takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property s, p. If desk is not undefined, return desk. Return string get own property s, p, 0, 4, 3, 2, p, desk. The internal method of a string exotic object s takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property s, p. If string desk is not undefined, then a let extensible be s. B return is compatible property descriptor, extensible, desk, string desk, return, ordinary define known property s, p, desk, 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str. For each integer I such that 0 I, len, in ascending order. Do, a append. to string I to keys for each own property key p of O such that p is an array index and to an integer or infinity p len in ascending numeric index order do a append p to keys for each own property key p of O such that p is a string and p is not an array index in ascending chronological order of property creation do a append p to keys 90 ECMA International 2024 8 for each own property key p of O such that p is a symbol in ascending chronological order of property creation do a append p to keys 9 return keys 0 4 3 for string create value prototype the abstract operation string create takes arguments value a string and prototype an object and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called let s be make basic object set s to prototype set s to value set s is specified in 1 0 4 3 1 set s is specified in 1 0 4 3 2 set s is specified in 1 0 4 3 3 let length be the length of value perform define property or throw s length property descriptor length false enumerable false false return s 0 4 3 5 string get own property s p the abstract operation string get own property tar kes arguments s an object that has an internal slot and p a property key and returns a property descriptor or undefined. It performs the following steps when called if p is not a string return undefined let index be canonical numeric index string p if index is undefined return undefined if is integral number int x is false return undefined if index is -0 return undefined let str be s assert str is a string let len be the length of str if r int x 0 or len r int x return undefined 0 let result str be the substring of str from r int x dra index plus 1 1 return the property descriptor result str false true false 0 4 4 arguments exotic objects most ECMA script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMA script function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed and create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 2 0 1 3 6 to identify them as such. Note 1 while creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2 the integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the argument's object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function and there is no dynamic linkage between the property values and the formal parameter values. Note 3 the parameter map object and its property values are used as a device for specifying the argument's object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMA script code. An ECMA script implementation does not need to actually create or use such objects to implement the specified semantics. Note for ordinary arguments, objects define a non-configurable accessor property named callee which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMA script implementations. Note 5 ECMA script implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMA script 2017, this specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMA script 2017 dropped the requirement for a throwing caller accessor 0 4 4 1 p. The internal method of an arguments exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called let desk be ordinary get own property args p. If desk is undefined, return undefined. Let map be args let is mapped be has own property map p. If is mapped is true, then a set desk to get map p6 return desk 0 4 4 2 p desk. The internal method of an arguments exotic object args takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called let map be args let is mapped be has own property map p. Let new arg desk be desk. If is mapped is true and is data descriptor desk is true, then if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to get map p. Let allowed be ordinary define own property args p. New arg desk 92 ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desk, is true, then I perform map, p, be else. If desk has a field, then assert. The following set will succeed, since formal parameters mapped by arguments objects are always writable. Perform, set, map, p, desk, false. 2. If desk has a field and desk is false, then perform map, p8. Return true, 0, 4, 4, 3. The MA script language value or a throw completion. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, p. If is mapped is false, then a return. Ordinary get, args, p, receiver 4, else, a assert. Map contains a formal parameter mapping for p, b return, get, map, p, 0, 4, 4, 4. The, if same value, args, receiver, is false, then a let is mapped be false, else, a let map be args, b let is mapped be. Has own property, map, p. If is mapped is true, then a assert. The following set will succeed, since formal parameters mapped by arguments objects are always writable. B perform, set, map, p, v, false, return, ordinary set, args, p, v, receiver, 0, 4, 4, 5, p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, p, let result be. Ordinary delete, args, p. If result is true and is mapped is true, then a perform map, p5. Return result, ECMA International 2024 193, 10, 4, 4, 6. Create and mapped arguments object, arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMA script, language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create, percent object prototype percent, set obj to undefined, perform. Define property or throw, obj, length, property descriptor, len, true, enumerable, false, true, let index be 0, repeat, while int x, len, a let val be arguments list, index, be perform, create data property or throw, obj, to string, int x, val, c set index plus 1, perform. Define property or throw, obj, add iterator, property descriptor, percent array prototype values percent, true, false, true, perform. Define property or throw, obj, callee, property descriptor, percent throw type error percent, false, false, return obj, 0, 4, 4, 7. Create mapped arguments object, func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMA script language values, denv, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1, 0, 4, 4, 1. Set obj is specified in 1, 0, 4, 4, 2. Set obj is specified in 1, 0, 4, 4, 5. Set obj to percent object prototype percent 0. Let map be ordinary object create, null, 1. Set obj to map, 2. Let parameter names be the bound names of formals, 3. Let number of parameters be the number of elements in parameter names, 4. Let index be 0, 5. Repeat, while int x, len, a let val be arguments list, index, be perform. Create data property or throw, obj, to string, int x, val, c set index plus 1, 6. Perform. Define property or throw, obj, length, property descriptor, len, true, false, true, 7. Let map names be a new empty list, 8. Set index to number of parameters 1, 9. Repeat, while index 0, 94. ECMA International 2024, A, B, C. Let name be parameter names, index. If map names does not contain name, then I append name to map names, 2. If int x, len, then let g be make arg getter, name, env. Let p be make arg setter, name, env. Perform map. To string, int x, property descriptor, get, g, false, true, set index 1, 20. Perform. Define property or throw, obj, add iterator, property descriptor, percent array prototype values percent, true, false, true, 1. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true, 2. Return obj, 0, 4, 4, 7, 1. Make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0. Note, getter is never directly accessible to ECMA script code. Return getter, 0, 4, 4, 7, to make arg setter, name, env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a functio, an object. It creates a built-in function object that when executed sets the value bound for name in the env. It performs the following steps when called. Let's set a closure be a new abstract closure with parameters. Value that captures name in the env and performs the following steps when called. A return env set mutable binding. Name. Value. False. Let setter be create built-in function. Setter closure. 1. Note. Setter is never directly accessible to ECMA script code. Return setter. 0. 4. 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally, length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I let value be typed array get element. Oh, numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor. Value true, true, true. Return ordinary get own property. O P ECMA International 2024 195 1045 2. P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Return is valid integer index. O. Numeric index. Return. Ordinary has property O P 0 4 5 3 P desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I is valid integer index. O. Numeric index is false. Return false. 2. If desk has a field and desk is false, return false. 3. If desk has a field and desk is false, return false. 5. If is accessor descriptor, desk is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element. Oh, numeric index, desk 7. Return true, return. Ordinary define known property. O, P, desk 0, 4, 5, 4. The. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I return typed array get element. Oh, numeric index 2. Return. Ordinary get O P receiver 0 4 5 5. The. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I have same value O receiver is true. Then perform. Typed array set element. Oh, numeric index V return true 2. If is valid integer index O numeric index is false. Return true. Return. Ordinary set. O, P, V, receiver, 96. ECMA International 2024 104 5 6. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I is valid integer index. O, numeric index is false. Return true. Else return false 2. Return. Ordinary delete. O, P 0 4 5 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST. Let keys be a new empty list. If it's typed array out of bounds, tar record is false. Then a let length be typed array length. Tar record be for each integer I such that 0 I length in ascending order. Do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do A append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do A append P to key 6. Return keys 0 4 5 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in table 32. Table 32. Typed array with buffer witness record fields 0 4 5 9. Capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W, I, T, N, E, S, O, B, J, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexcst or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj. If is detached buffer is true, then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order, return the typed array with buffer witness record. OBJ, byte length, 0, 4, 5, 1, 0 typed array create. Prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let AB make basic object. Internal slots list. Set A is specified in 1, 0, 4, 5, 1. Set A is specified in 1, 0, 4, 5, 2. Set A is specified in 1, 0, 4, 5, 3. Set A is specified in 1, 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A, 0, 4, 5, 1, 1 typed array byte length, tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness, record, and returns a non-negative integer. It performs the following steps when called. If its typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size, 0, 4, 5, 1, 2 typed array length. Tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert. Is typed array out of bounds, tar record. Is false. Let O be tar record. If O is not auto, return O. Assert. Is fixed length array buffer. O. Is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert. Byte length is not detached. Return floor. Byte length. Byte offset. Element size. 0, 4, 5, 1, 3 is typed array out of bounds, tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer. O. Is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else, a let element size be typed array element size. O. Be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note. 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1, 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments O, a typed array, and an x, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, int x, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note, bounds checking is not a synchronizing operation when O's backing buffer is agreeable. Shared array buffer, if it's typed array out of bounds, tar record, is true, return false. Let length be typed array length, tar record. If R, int x, 0, or R, int x, length, return false. Return true, 0, 4, 5, 1, 5 typed array get element. O, index. The abstract operation typed array get element takes arguments O, a typed array, and an x, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index, O, int x, is false, return undefined. Let offset be O, let element size be typed array element size. O, let byte index in buffer be R, int x, element size plus offset. Let element type be typed array element type. O, return get value from buffer. O, byte index in buffer, element type, true, unordered, 0, 4, 5, 1, 6 typed array set element. O, int x, value. The abstract operation typed array set element takes arguments O, a typed array, int x, a number, and value, any CMA script language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be. To bigint, value. Otherwise, let num value be. The number, value, if is valid integer index, O, int x, is true, then a let offset b O, b let element size be typed array element size, O, c let byte index in buffer b, R, int x, element size plus offset, b let element type be typed array element type, O, e perform set value in buffer, O, byte index in buffer, element type, num value, true, unordered, return unused, ECMA International 2024 199, 1045517 is array buffer view out of bounds, O, the abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record B, capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, sexy S, T, B return is view out of bounds, view record. Let tar record be, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy S, T, return is typed array out of bounds, tar record, 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMA script module, C16, 2, 3. There is a one-to-one correspondence between the string key dome properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string value dome property key is the string value of the corresponding exported binding name. These are the only string key properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare f. 1, 0, 4, 6, 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 0, 0. ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1, 0, 4, 6, 2. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V. 0, 4, 6, 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0, 4, 6, 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0, 4, 6, 5, P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary get own property. O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor. Value. True. True. False. 0, 4, 6, 6. P. Desk. The internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define known property. O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk hasn't field and desk is false, return false. If is access a descriptor, desk, is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value, desk, current, return true. 0, 4, 6, 7, P. The internal method of a module namespace exotic object O takes argument TP, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O. P. Let exports be O. If exports contains P, return true, return false. ECMA International 2024 201 10 4 6 8. The. If P is a symbol, then a return. ordinary get O P receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M resolve export. P assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a return get module namespace. Target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception. 2. Return target env get binding value. Binding true 0 4 6 9. The return false 1 0 4 6 1 0 P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return. Ordinary delete. O P. Let exports be O. If exports contains P, return false. Return true 0 4 6 1 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary and property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 104612 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert. Module is empty. Let internal slots list be the internal slots listed in table 33. Let n be make basic object. Internal slots list. Set m's essential internal methods to the definitions specified in 1 0 4 6. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare f. Set m to sorted exports. Create own properties of m corresponding to the definitions in 28.3. Set module to m 0. Return m 0 4 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0 4 7 1 v. The internal method of an immutable prototype exotic object O takes argument v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return. Set immutable prototype O v10 4 7 to set immutable prototype O v. The abstract operation set immutable prototype takes arguments O, an object, and v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O. If same value v current is true, return false. 0.5 proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMA script code. Every proxy object has an internal slot called.
So I kind of thought
Called the proxies.
that I was at the end of this.
Methods. See table 34. About the implementation for one.
Holy freaking cannoli.
Note, unlike other exotic objects, there is not a dedicated
I just don't care. I just want to be done.
objects. This is because
Oh my god.
type % and
I already have this though.
host environments. The relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or
I removed it.
the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create. Table 34. Proxy handler methods. Internal method. Handler method. Get prototype of. Get prototype.
Okay, so this is what
Prototype of is
Chatbot had a problem with originally.
extensions. Get own property. Get own property descriptor. Define own property. Define property. Has property. Has get. Get. Set. Set. Delete. Delete property.
Oh, Chatbot, you're a piece of shit.
Construct. When a handler method is called to provide
Chatbot's not helping at all. It's not making this any easier.
object as a
No, not at all.
does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy result
Why do I need these? Like,
typically may not be modified. Some proxy objects are created in a manner that permits them to be
I don't know what Chatbot's doing.
proxy is revoked. Its internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy object
He literally does not know how
CMA
to mother love and map
the object whose hand
an image to the freaking quad.
1 7 3
It is literally
variance defined
not capable.
3 are essential integrity and variance
And it's just making up stuff.
by the proxy object internal method
Because it changes it every single time.
implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMA script proxy object, P is a property key value, V is any ECMA script language.
We get a copy of everything,
Board, O4 copyright sign, ECMA International 2024, 10.
and then undo, and then try again.
Of a proxy exotic object OT,
Because there may be crap inside of here that's useful.
or null, or if
Something relates to something.
perform. Validate non-revoke proxy.
Oh my god, I'm so close to being done.
There is an object.
I thought it would be like applying a simple property,
Find, then.
but now it looks like I might have to like
Trap, handler, target. If handler proto is not
make a whole separate structure that's tied to the flip buffer.
0, if extensible, target is true. Return handler proto 1.
Describes the types of resources you use, allocates the actual descriptor sets, hold, the binding info, image plus sampler. So this is what I actually need, I think.
V, the internal method of a proxy exotic object.
Because it's an image and there's a fucking sampler.
Returns either a normal
You update the descriptor sets with your texture and samples.
called perform.
You bind the descriptor sets before drawing, so shaders can access textures.
Let trap B.
Oh my god.
V, if Boolean trap result is false, return false. Let
I'm so fucking pissed.
extensible target is true.
Holy cannoli.
2, if same value, V, target proto, is false.
Crab apples.
Return true. Note the proxy objects enforces the following invariance. The result must be either an object or null. If the target object is not extensible, applied to the proxy object must return. The same value is applied to the proxy object's target object.
I don't wear panties, but if I did, they would be in a bunch.
The target object is not extensible. The argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 105.
Oh, I gotta cut all this text out, paste it over there,
Or throw
and probably end up putting it back.
when called.
I just have to undo
Proxy
to the point that it was at, where I didn't add random stuff that Chatbot said I need.
is extensible. If trap is undefined, then a return is extensible. Target
And this is that point. This is the point that I need to save it back up.
target let
Because from this point on,
target
it can turn into absolute hell,
throw type error
and I could totally fuck it up.
Boolean trap result
I just need the image on that fucking quad for, oh my god.
returns either.
This is so annoying.
It performs the following steps when
I hate quads
revoke proxy
and anything triangle related.
assert handler is an object. Let trap be.
I hate the GPU. This is really annoying.
Trap is undefined. The n a return target. Let Boolean trap result be to Boolean. Call trap handler target. If Boolean trap result is true, then a let extensible
You know what's more fun than this?
extensible target. B if extensible target is true. Throw a type error exception. Return Boolean trap result 0 5 5 P. The internal method of a proxy exotic object so takes argument P, a property key, and returns either a normal completion containing either a property descriptor undefined, or a throw completion. It performs the following steps when called. Note the proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object must return the same value as. Applied to the proxy object's target object with the same argument. Note the proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object only returns true if applied to. The proxy object's target object is false. 2. Perform. Validate non-revoke proxy. O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method.
Oh, rip it.
P descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target.
You know what's more fun than this?
Result
Doing like actual logic or something that uses your head.
C. Let extensible target be. Is extensible. Target. D. If extensible target is
Way more fun than this.
E. Return undefined. 1. Let extensible target be. Is extensible.
So like, how do you get the highest bit set in a number
Trap result obj. 3. Perform complete property descriptor. Result desk. 4.
without shifting or doing any math?
Target.
Just bit masking.
5. If valid is false, throw a type error exception. 6. If
You get the number and you bit smudge.
is undefined or target desk is true.
So you take the number, you shift to right 1, you assign it to itself, you shift to right 2, assign it to itself, you shift to right 4, assign it to itself, and 8, 16, 32 for a 64-bit number.
The proxy objects enforces the following invariance. The result of must be either an object or undefined. A property cannot.
And then I came up with this technique down here.
A
I have not seen anybody else do this, so I'm claiming this technique.
object. A property
if you claim this technique, I've already like made a video and I tagged it, I named it,
Extensible.
and I'll like prove you're lying son of a bitch.
The non-configurable
And I could like show like a whole bunch of other tricks I figured out that you wouldn't know.
unconfigurable, non-writable own property of the target object.
So I claim this trick or whatever. Not this part.
No method of a proxy.
This part.
P, a property key, and desk, a property
So if you have a number in binary,
boolean or a throw
64 number,
steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let
ask chatbot to give me a random 64 number in binary.
then a return target. P. Desk. Let desk obj be from property descriptor. Desk. Let boolean trap result be to boolean.
Give me a rando.
Target. P. Desk obj. If boolean trap result is false, return false. 0.
64-bit number
P. ECMA International 2024
in
200.
binary form.
Let extensible target be. Is extensible. Target. 2. If desk has a field and desk is false, then a let setting config false be true 13. Else, a let setting config false be false 4. If target desk is undefined, then A if extensible
Oh, it's freaking negative.
option, B if setting config false is true, throw a type error exception 5. Else, A if is compatible property descriptor, extensible target, desk, target desk, is false. Throw a type error exception, B if setting config false is true and target desk is true, throw a type error exception,
Okay, so here's 64 number, and it just scrolled. What just happened?
target desk is true. Then, I if desk has a field and desk is false, throw a type error exception 6. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable, unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable, unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a
Oh, it changed tabs on me.
then applying the property descriptor of the property to the target object using will not throw an exception has property P, the internal method of a proxy exotic
Alright, so here's a 64 number.
key, and returns either a normal completion
I'm gonna get the highest bit set
performs the following
without any math.
form. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be.
So I don't want it to be the top bit,
Has if trap is under
'cause that's like too obvious.
target P. Let boolean trap result be to boolean. Call trap handler target P. If boolean trap result is false.
I'll pick like a bit that's lower down,
P. B if target desk is not.
like here maybe.
I if target desk is false. Throw a type error exception 2. Let extensible target be. Is extensible target 3. If extensible target is false, throw a type error exception. Return boolean trap result. Oh.
Okay, so how do you get the highest bit of this 64 number without shifting?
The result of is a boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target
Could you imagine doing a loop
target desk
and going like,
is false.
wow,
Trap result. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true and target desk 0. Return trap result. Note. The value reported for a property was be.
that's saying it, or like you don't even need to set a number.
Property is a non-writable, non-configurable.
Just make like a bit position.
Defined if the corresponding target object property is an
It's like
property that has undefined as its 0, 5.
uint 8
Validate non-revoke proxy O. Let
type
be O. Assert. Handler is an object. Let trap
bit position.
handler set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call trap handler target P V receiver. If boolean trap result is false, return false. Let target desk be target P 0. If target desk is not undefined and target desk
Like source
International 2024 200
number.
data descriptor target desk is true and target desk is false, then I have same value.
So you're like source number, rate shift,
Exception. B if is accessor descriptor target desk is true, then I have
bit position.
turn true. Note the result of a property to be different from the value of the corresponding target object property if the corresponding target object
Like that.
non-configurable own data property cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0, P, the internal method of a proxy
But not really.
argument P, a property key, and returns either a normal completion containing a boolean or completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method, handler, delete property. If trap is undefined, then a return target. P, let boolean trap result be to boolean. Call, trap, handler, target, P. If boolean trap result is false, return false. Let target
Let's wrap an if.
0. If target desk is undefined, return true. 1.
So if source num does not equal 0.
Exception 2. Let extensible target be. Is extensible target 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the tar. Reject object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion contained.
Like -1.
It performs the following.
Gotta cast it.
Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method.
Let's make it long.
10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be.
Alright, so now,
Handler. Target. Let trap result be. Create
do I need this check though?
trap result array.
No, I don't.
If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible. Target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4.
Alright, so like,
Keys be a new empty
if
list.
the number is 0,
Let target non-configurable keys be a new empty list.
the result, whatever, is gonna be
Desk be target. Key. B if desk is not undefined and desk is full.
position 0.
Configurable key C else.
You can wrap it if and handle the exception however you want
Configurable keys is empty. Then
to indicate that no bits are set.
alt keys be a list whose elements are the elements of trap.
This is like a simple while loop
Get non-configurable key
that does 64-bit, 64 shifts, whatever, at worst,
keys. 0.
if the number happens to be that big.
Belt 1. For each element key of target configurable keys,
So since it's set to -1,
throw a type error exception. Be remove key from unchecked result keys. 2. If unchecked result,
could do it do while.
type error exception. 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of
This works.
the target object and no other values.
Alright, so it's always going to enter to at least test,
Arguments list.
which means it's always going to increment.
Exotic object O takes arguments this
But that first shift is going to be fucked up.
list. A list of ECMA script language values. And returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Perform. Validate no. And revoke proxy.
So let's do this then.
LBO. Assert. Handler is an object.
Alright, so logically, it always has to enter.
Undefined. Then a return. Call.
So it'll be -1 always, then 0.
Argar AB created.
If the number is 0,
Return. Call. Trap. Handler. Target.
then the result
Note to proxy exotic.
is 0.
Initial value of its
If the number has any bits set, it's going to continue shifting right.
2024 to
So 0, 1, 2, 3, 4, 5,
13. Arguments list.
up to 63.
Internal method of a proxy exotic object O takes up
At some point, it'll be 0.
ECMA script language values. And
I think I have to cast it to it specifically,
object or
just to be safe, that it does actually do 64-bit shifts.
and revoke proxy. O. Let target be O. Assert.
Because sometimes I'll break it down to 32-bit.
Be O. Assert. Handler is an object. Let trap be. Get method.
Alright, so like this is as simple gets.
Return. Construct. Target. Arguments list. New target. Let argar AB create array from list.
If you can do it like a naive way, where you test every single bit.
Target. Array. New.
Alright, so like, that's ridiculous.
Throw a type error exception. 1. Return new OB.
What you can actually do, instead of that,
Invariance. The result of must be an object.
is just use pure logic, no math,
Proxy. The
just the fact that the bit is in a column,
a proxy exotic object.
and then or the columns that the bit shows up in,
Error exception if proxy has been revoked.
and you can map the position to the indice directly,
Is not null. Return unused.
and it's magical.
5. Proxy create. Target. Handler.
Because math is fake, it's just a collection of patterns,
Any CMA script language value. And handler. Any CMA script.
and the fake part is that as long as you get the same patterns,
It is used to specify.
the same result for the same input,
Performs the following.
you don't really have to do technically, quote, math.
Handler is not.
You can get the same output, the same pattern from other patterns with different operations,
Specified in 10 points.
other than like math.
True. Then a set P is specified in the 10th.
Because math is
Constructor.
an operation on columns and rows.
2013. Set P to target.
So you can break that down to binary.
International.
You can find the bit position based on the columns and rows
The initial value
without any math.
is an object that has an internal method. 11.
So first off, you bit smudge.
Source text.
So you do like argx, whatever.
Character. Any Unicode code.
So I guess that would be here. Let's just go source num argx.
Points. All Unicode code point values from you
So this is how you get it, like the bit position in the naive way.
may occur in where permitted by the ECMA script grammars. The actual encodings used to store and interchange ECMA script source text is not relevant.
And here's how you get the bit position, being clever.
ECMA script
And there's another way where you can like divide
source character values. Each
by a constant magic number.
ECMA script implementations are not required to perform any
But I think that's pretty lame. This is cooler.
normalization of source text. The components of a combining character sequence are treated as individual Unicode code points, even though a user might think of
Okay, so you bit smudge, you shift right, you OR to itself, you shift right, you OR to itself.
files.
So it folds the number.
Unicode escape sequence
So if this top bit is set here,
value within a
and you shift right 32,
effectively ignored as part of the
then the top bit, wherever halfway is,
language in the behavior
gets set to the top there.
of the program. If
So whatever the bit pattern is,
for example, line comment
for all possible combinations,
Unicode
it's gonna smudge the top half of the top 32 with the bottom 32,
of the comment. Similarly,
like folding a piece of paper.
row A occurs within a string literal in a Java program. It is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U0008 to cause a line feed. LF.
Alright, so when a bit smudges, it's gonna do this.
CMA script program. A Unicode escape sequence occurring within a comment is never interpreted.
Do a shift right.
Determination.
It's gonna do a shift right 1, 2, 4, 8, 16, 32.
A string literal in an ECMA script program always contributes to the literal and is never interpreted as a line terminator or as a code point that must
So I paste this in here,
1
do the bit shift.
encode code point CP. The abstract operation UTF-16 encode code point takes argument CP. A Unicode code point.
1, 2, 4, 8, 16, 32 times. So put it in front. It's like, I don't know, I claimed this technique, it's mine. Chatbot couldn't find any records of anybody else doing it, so I'm claiming it. Alright, so 1 bit to the right, then 2 bits to the right, 4, then 4 bits, and then 8 bits, and then 16 bits, and then 32 bits. Now the number is bit smudged, just like in Krita, the paint program. It's literally the same thing as art. It's just different medium. And this is real numbers. If they taught real numbers in school, like actual numbers, like a real number system, not a lazy number system like decimal, I don't know, probably be better off. So Krita, I could do this, whatever. And I can smudge it. I don't remember where the smudge tool is. I think it's over here. Is it purple? Why does it not say what it is? Oh, come on. I would really like for something to work just once. It's like one time. Could something work? No? That's too much to ask for? Yes, it's too much to ask for. I knew I was asking for too much. It's not gonna hover and highlight and say what it is. This might be a smudge tool. I think that's a palette. It's got like a recycle thing. So maybe it applies water? I don't know. See if it's smudge. That's not smudge. Is this smudge? That looks like smudge. What is that? That's like a ghetto smudge. That's like this smudge here. That's like Google following the ECMA 262. They didn't quite follow the standard, but Google says, oh, we got a JavaScript engine that meets the standard. But they don't. They're not even close to meeting the standard. It's kind of like this smudge tool. It's like saying, hey, look, I got a smudge tool. And I smudge. It's like, you know what? That's not quite a smudge tool. Just like JavaScript, it's the V8 engine. It's not quite actually JavaScript. If you can't meet the standard, then you're not what you say you are. Otherwise, this could be considered a smudge tool. Which it does actually kind of smudge, but it's not actually smudging. It's a little bit off. Just like Google. I think they're a little slow. I mean, they're like 15 years behind the standard. Maybe one day they'll catch up. Maybe they won't. I'm kind of hoping they don't. I don't think they will. That gives me an edge. Man, I gotta Google it. I just wanted to like do this really quick and it's not working. Blending, I thought it's typing smudge. Why is there so much work? Brush preset. Oh, this is not helpful. There's no smudge in here. How the hell do you search? Oh, here. Are you kidding? No results? Why does everything have to be so damn difficult? Holy crap. Oh my god. The whitish brushes are for pure blending, and the purplish brushes are for blend and add color. So the white one's not the purple. I should have remembered that with all the other random shit I gotta remember, because nothing makes fucking sense. So I want white. So this one. There we go. So, like that never happened. Anyways. So you bit smudge the bits, just like in a paint program or with paint, because it's the same technique, different medium. And this is what the video card does behind the scenes. The fun stuff, the actual stuff that you can like learn upon, become good at, and get, what is it? You get learned, educated, become smarter, but instead, all of it's figured out for you. And you just call these mother-loving structures upon structures upon structures within structures inside of structures, because all the fun stuff that you actually learn, that's all been figured out. That's the whole point. Because the fun part is actually doing something. Like smudging, not just using what somebody's already done. And a big ass list. And you gotta like wait for some new feature to come out. Because you can't just make it, because they're in control. The video card company. You can't just simply, I'm pretty sure there's a way, but you can't simply, right off the bat, make an adjustment to the video card. You can't simply modify bits, the data. That has to be controlled and managed to keep everyone that uses the product stupid. And to take the fun out of it. There's nothing fun in the fucking GPU. This is fun. When it works. It's not really. I'll just zoom in on a small part. Apparently this program sucks, and it's not going to smudge like I wanted. It's literally a max smudge. It is literally at max smudgeability. Maybe it's not. Where's strength? There's no strength. Maximum. Maybe it'll work now. Oh man. Oh, it works. Kind of. There we go. It's not really. I guess it's best look at. Alright, so it's just like real art and supplies, just different medium. Some of the smudge bits. So now everything on the left is smudged over to the right. It doesn't really work like I want. It's not going to do what I want. Alright, I'm done messing with that. Whatever formula they use, it doesn't scale. When you change the diameter, it makes no sense. So pretend that worked. Because this actually does work, unlike that program. Alright, so I'm going to get rid of the bottom bits. So all the bits after this need to be deleted. Because they're out of range. They've been shifted off. So these are bits that are left. So up here, it is or equal the value of redshift 1. So I'm going to OR the result. This is the original number. This is 1, 2, 3, 4, whatever, shifted. So I'm going to zoom in. And anytime the bit's up here that's set, I'm going to set the bit on both of them. So I'm going to apply this number to this number. I'm going to click here, highlight 2 columns, rows, whatever you want to call them. Columns, rows, same thing, based on context. So since this bottom bit's 1, I'm going to set both to 1. Because I'm going to OR the result to the top value, which is going to be argx, whatever. I'm going to do that for this. So you don't actually have to do this. I'm just like going through what's happening behind the scenes. Yeah, if you actually have to do this, this is not easier than a loop. This would be way worse than a loop. Okay, so it's set here, so it's 1. It's 1 here. 1 here. I'm looking at the bottom one. If the bottom one is set, then I set both on. So that's it. No more. So I'm going to get rid of this. I'm going to OR it with the 2. Why does it keep doing that? Okay, so now I'm doing OR equal with the 2 result, because this was ORed with this. So do that all the way down. And so now with the right shift 2 value, if the bottom bit's set, then I set the bit in both. I'm going to skip over the ones that are already set. Alright, that's it. So right now it happens or it'll be done. So the 4 shifts, they're all already set. So this is like brute force also, because it breaks it down to like a constant number of operations instead of bit shifting until you find it. That's not constant. Well, it's constant if you treat everything as always going to be at least 63, except the timing is to be different. Like obviously 63 is the max that I could take for any of them, but it's going to be different timing because each will be a different bit set. Alright, so this is the result. As you can see, all the bits are smudged to the right, and all the bits to the right are set on, to whatever bit that was set highest that's on. Just like how it didn't really work in this example. If it did work, that's how it would be, but this didn't work. So pretending that this did work, just like that, is how this is. So the next part of this trick, or whatever, after the bit smudge, you take this number, and then you have the number, whatever, you take a copy of it, and then you shift the copy of it one bit to the right. So shifting right, 1. The bottom bit gets shifted off. As you see, whatever, only 1 bit set on the top row. So if you XOR these two values, anything with the same bit becomes 0. Anything that's 0 in both bits is 0. Anything with 1 in both bits is 0. Anything that's 1 or 0 is going to be 1. So if I take this, I get the result of an XOR. Like this. I'll just put it underneath. I have to start from the left end. I gotta start from the left side. Or not. Let's add space beforehand. Yeah, this is annoying, whatever. Alright, so 1, 1. This is gonna give me 0. Oh, it made tabs, come on. You know, I'm gonna start from the left side. Alright, so it's a unsigned shift, so it's 0 at the top. So we got 0, 0, 0, 0, 0, 0, 0. And then they're different. That's 1. And then they're the same. So it's a 0. So everywhere that they're the same, it's 0. That's how XOR works. Anywhere that they're different, it's 1. So we got 1, 1, 1, based on the 2 bits, whatever, top, bottom row. Dang it, I did that wrong. I meant 0. Because they're both the same, so it's 0. I zoom out, and ta-da, 1 bit set. So this is left over after doing the operation, isolate the highest bit. Alright, so now the highest bit is isolated without using any math. Now you map the bit position directly to the column that's in. Like this. Basically, you take the number, you fold it in half. This is 32 bits. So top half is 32, bottom half is 32. And you cut the number in half. So you get 0x. Half of 32 is 16. So that's 16. Then you do 8, 16, and 16. You cut the number in half again, and again, and again, until you get down to 1 bit, which is 0xAA. And this will scale for any bit size. Okay, so now, here's where our logic comes in or whatever. And no math involved, just brute force. Alright, so, oh, I gotta convert these to binary. I already did that down here, so I'll use this. Alright, here's the magic part. Watch how simple this is. This is like the most clever thing ever. That's why I'm claiming it. Or I have claimed it already. It's already been claimed. I have evidence. I have a whole stream. Well, it's only like an hour of the stream. I probably spent an hour explaining this right now. I should get the shader done, but I can't take it, so I'm gonna do this. Alright, so this is the bit masks for these here, the same length, whatever, but it's 1, 2, 3, 4, 5, 6. Alright, so 6-bit masks are needed for 64-bit number. To find out the position of the highest bit after bit smudging and then isolating it like this. So as you can, like it's 6 whatever, that's 6. So this is these bit masks but binary, this is hexadecimal. And this is binary. Alright, so I'm gonna paste the number here. Okay, so that's the same number up here, whatever. That I bit smudged, then isolate the highest bit. Alright, here's how simple it is. I'm going to convert it directly into the indice that it is with fucking magic. Because I'm a magical bitch. I'm going to go like this. Space, space, space. I'm going to go like this. Copy. Go over here. I'm going to go paste. I'm gonna go like this, back, boom. That's the bit it is. It really better be the correct bit. I gotta check it out. I'll paste this into chatbot. Tell it to give me the value in decimal. So convert this binary number to decimal. Alright, chatbot says it's 37. Alright, so is that the highest bit set? Time to find out. Take the number here. Paste it here. Zoom out. I didn't change the number or anything. It's literally magic. Well, it's not magic. I'm not going to explain it. I'll just say it's magic. Alright, so 37. I'm asked chatbot to give me a number with a bit shifted 37 bits. And I'll copy paste that here. Because I could count up 37 bits. But like, that's annoying. So I'll ask chatbot to give me a number shifted left 37 bits in binary. And I'll paste it here. And if it's the same, then it means that it's correct. And I found the highest bit set without shifting, without multiplication. Zero math, just straight up logic. And the fact that binary is in powers of 2. And I converted the position of the bit, its column, directly to its indice value. Magic. Real math. Actual fun math. Where the numbers actually mean something. That you can do something with the numbers that haven't been done before. You're not using a library of predefined everything. You don't have to wait for something to come out because you can just program it in the real world. But the video card, that's a magical, made-up triangle land where a square is a triangle and triangles are squares. Alright, so let's chatbot. I'm gonna say I don't know, like output the result, this result, whatever. I'll say compute this. To like 1 redshift 37. But return the result as binary. I'll say and output. Alright, so I'm telling chatbot, compute this. 1 left shift 37. That's the sign bit, or not the sign bit, the highest bit set. Set and output it as both decimal and binary. I'll put the result instead. And chatbot says this means shift the binary 1 left 37 bits. So decimal, that doesn't matter though, but when it's binary. Copy this. And I'm gonna paste it in here. It should be the same. I need to pad it with zeros. Because chatbot didn't pad with zeros. I'll tell chatbot to pad it with zeros. Pad. Edge binary value, so it's 64 bit. Alright, so I'm gonna copy all. I'll just put 0b in mine. 0b. So it doesn't line up. I'm gonna copy. It's copied. Copying this. I'm gonna paste. I'm really hoping it's the same. It better be the same. I'm scared to click it. What the fuck? Okay, hold on. Chatbot is wrong. Holy fuck. How does Chatbot fuck that up? I'm so annoyed. I'm so fucking annoyed. How the fuck is Chatbot supposed to be intelligent? It can't even shift a fucking bit 37 bits. It doesn't know how to fucking count. For fuck's sake. Why am I swearing? Alright, this is so dumb. This is literally the dumbest. This is the easiest thing for AI is not AI. Anybody that thinks AI is intelligent is a fucking moron. This is so stupid. I'm gonna ask Chatbot how many bits is one shifted to the left in its value. I'm gonna ask Chatbot what is the bit position of the highest bit set in this value. I'm gonna paste exactly what Chatbot gave me. And I'm gonna see if it says 37. Because this is what Chatbot said is 1 bit shifted left 37 bits. So I'm gonna ask Chatbot, what's the highest bit set in this number? What's the bit position of the highest bit set in this value? I said but bit position. So I said pin in this value. It even says 37 here. Chatbot said this is 1 shifted left 37 bits of a full 64-bit binary number. I'm gonna click copy. Just to prove how ridiculous this is. How the fuck do people get answers out of Chatbot? What are they asking? I can never get to answer me. Alright, so I gotta like type it in again because I like clicked. You could say I lied, but you could count it up if you want. Alright, so I'm gonna like copy it again. Alright, so I'm copying this, pasting it here. This is what's being copied. I'm not going to click anything yet until right now. I'm going to paste it. Do you see? That's what Chatbot said. It's so wrong that's not even funny. This is the simplest of all operations. A bit shift is one of the fastest operations on the CPU. It's faster in addition, in multiplication, in division, in the module operator, and chatbot can't even get this right. So here's what chatbot says. I said, what's the position of the ISET bit? How the hell is it getting 37? It says 1 is in the 30th spot from the right. Oh my god! Why would it do that? Why? It says this means the shift is left by 37 bits. I'm pissed off now. This isn't even funny. It intentionally did the bit shifting the other way. Is somebody at chatbot, ChatGPT watching and playing jokes? Is that what's happening? Because that'd be pretty funny. Because who the fuck shifts from the right? It says right here, that's 1/38 spot from the right. Hold on, what's 64 minus 38? I'm not gonna ask chatbot. Use a real calculator. (64 minus 38). Is that how far it is? I'm gonna cut this up. It's wrong still. How could it be wrong? I don't get it. I'm gonna paste this into a real calculator online. Hold on. Copy. I'm gonna paste it to online calculator. There's no calculator on Linux, I gotta find one. Here, okay, so paste it here. I'll put it as, there's no binary. Oh my god, so I'll convert this to binary. Man, I freaking hate everything. Why can't shit just work? Oh my god. Hex to binary. Okay, convert. What? Oh. It's because it's bigger than a 32-bit number. In JavaScript, it's only up to 32 bits. That's so funny. That's exactly why I'm writing a JavaScript engine. I'm gonna meet the whole standard. Every single page from 1 to 816. The standard, though, actually says that things have to be 32-bit. So I'm going to make an addition to the standard that supports 64-bit or bigger than 64-bit. I'm going to have it so you can pick the default size T and also have like big numbers or whatever. But like actual big numbers. Because 64-bit is the thing. The fact that JavaScript is only 32-bit, that's pathetic. This is pathetic. I just want the result here. Why can't anything work? Why is software? Why is chatbot? Why is everything so subpar? I mean, the paint tool, you can't even fucking smudge. Oh, everything is so dumb. Holy crap. I just want this number. And I'm gonna get it. I'm almost there. Oh my god, this is gonna have the same issue. It's gonna say, oh, the number's too big. It says hit convert. Therefore you can type 16 hex characters. Wait, maybe it'll work. I think it worked. I want padding. Why doesn't it add all the zeros? That's not what padding means. Do people not know what padding means? That's like aligning it into subgroups of 4. That's not padding. Anyways, I'm gonna copy this. And this should be right. Based on third-party sources. So paste it here, add X's for zeros. And look at that. It's right. So that's how to get the highest fucking bit set in a number without bit shifting. And chatbot is a stupid piece of shit. Like, what is this? It's not even close. It's what it can't. Chatbot can't even do bit shifting. Are you kidding me? And it's AI? What the fuck? That's just as dumb as saying everything's a triangle in video card land, where everything's a triangle, a square's a triangle, triangle's a square, because there's only triangles, and because everything is pre-computed for you. You just use data structures to call functions that are made, because you can't access the damn GPU. I'm gonna go in a circle here. Anyways, this is how to get the highest bit set in a number, and I claim this method because it's magical. I could get some water. I'm so annoyed though. Everything is just crap. I don't know, baby.
Object or null, and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary set prototype of O, v10, 1, 2, 1 ordinary set prototype of O, v. The abstract operation ordinary set prototype of takes arguments O, an object, and v, an object or null, and returns a boolean. It performs the following steps when called. Let current be O if same value, v, current, is true, return true. Let extensible be O if extensible is false, return false. Let bev, let done be false, repeat. World done is false if p is null, then I set done to true, be else if same value, p, O, is true, then I return false, see else. I if p is not the ordinary object internal method defined in 1, 0, 1, 1, set done to true, 2, else. Set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for int 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary is extensible. O10, 1, 3. 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a boolean. It performs the following steps when called. Return O10, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. O10, 1, 4. 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5. P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property. O. P10, 1, 5. 1 ordinary get own property. O. P. The abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else, A assert X is an accessor P. Property. B set D attribute. C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D 0, 1, 6. P. Desk. The internal method of an ordinary object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define known property. O. P. Desk 1, 0, 1, 6. 1 ordinary define known property. O. P. Desk. The abstract operation ordinary define known property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O. P. Let extensible be is extensible. O. Return capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current, 0, 1, 6, 2 is compatible property descriptor, extensible, desk, current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desk, a property descriptor, and current, a property descriptor undefined, and returns a boolean. It performs the following steps when called. Return capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 1, 0, 1, 6, 3, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current. The abstract operation, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, takes arguments O, an object or undefined, P, a property key, extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property currents while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert is property key P is true if current is undefined. Then A if extensible is false, return false. B if O is undefined, return true. C if is accessor descriptor desk is true. Then I create an own accessor property named P of object O whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else I create a known data property named P of object O whose and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise you return true. Assert current is a fully populated property descriptor if desk does not have any fields, return true. If current is false, then 70 ECMA International 2024 ABC. If desk has a field and desk is true, return false. If desk hasn't field and desk is not current, return false. If is generic descriptor desk is false and is accessor descriptor desk is not is accessor descriptor current, return false. D if is accessor descriptor current is true, then I if desk has a current 2. If desk has a current, else if current is false, then I if desk has a field and desk is true, return false. 2. If desk has a field and same value, desk current is false, return false. If O is not undefined, then if is data descriptor current is true and is accessor descriptor desk is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with an accessor property whose and attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. B else if is accessor descriptor current is true and is data descriptor desk is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. C else I for each field of desk set the corresponding attribute of the property named P of object O to the value of the field 7. Return true 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return ordinary has property O P 0, 1, 7. 1 ordinary has property O P. The abstract operation ordinary has property takes arguments O, an object, and P, a property key, and returns either a normal L completion containing a boolean or a throw completion. It performs the following steps when called. Let has own be O P. If his own is not undefined, return true. Let parent be O. If parent is not null, then a return parent P5. Return false 0, 1, 8. The return ordinary get O P receiver ECMA International 2024 171 10 1 8 1 ordinary get O P receiver. The abstract operation ordinary get takes arguments O, an object, P, a property key, and receiver, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let desk be O P. If desk is undefined, then a let parent be O. B if parent is null, return undefined. C return parent. If is data descriptor desk is true, return desk. Assert is accessor descriptor desk is true. Let getter be desk. If getter is undefined, return undefined. Return call getter receiver 0, 1, 9. The return ordinary set O P V receiver 1 0, 1, 9 1 ordinary set O P V receiver. The abstract operation ordinary set takes arguments O, an object, P, a property key, V, an ECMA script language value, and receiver, an ECMA script language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let own desk be O P return ordinary set with own descriptor O P V receiver own desk 0, 1, 9 2 ordinary set with own descriptor O P V receiver own desk. The abstract operation ordinary set with own descriptor takes arguments O, an object, P, a property key, V, an ECMA script language value, receiver, an ECMA script language value, and own desk, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If own desk is undefined, then a let parent be O. B if parent is not null, then I return parent. I set own desk to the property descriptor, undefined, true, true, true. If is data descriptor, own desk is true, then 72 ECMA International 2024 ABCD E. If own desk is false, return false. If receiver is not an object, return false. Let existing descriptor be receiver P. If existing descriptor is not undefined, then I if is accessor descriptor existing descriptor is true, return false. 2. If existing descriptor is false, return false. 3. Let value desk be the property descriptor V. I've return receiver P value desk.
You should
Currently have a property P. 2.
pray for wisdom.
Receiver P.
It'll leave you in a bit of a position that you don't really ever want to be in.
Perform. Call. Set. V. Return true. 0, 1, 1, 0.
I don't know. So that's how I get the highest bit set in a number
A property.
with no math.
An or throw completion.
Just brute force or whatever.
Ordinary.
No math.
1, 0, 1, 1, 0, 1. Ordinary delete. O.
Back to video card stuff. Hooray.
An object. And P. A property key. And returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Load desk B. O. P. If desk is undefined. Return true. If desk is true, then A. Remove the own property.
So it's black.
Row 1.
No image.
Of an ordinary object O takes no arguments and
All I need then.
to property keys. It performs the following steps when called. Return ordinary own property keys. O 1 0 1 1 1 1 ordinary own property keys. O. The abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the
All I need though is to get
list. For each own property key P of O such that P is an array index in ascending numeric index order. Do A append P to keys. For each own property key P of O such that P is a string and P
the desktop.
ascending chronological order of property creation. Do A append P to keys. For each own property key P of O symbol in ascending
Which is here, whatever desktop capture.
append P to keys 5. Return keys 0 1 1 2 ordinary object create proto additional internal slots list. The abstract operation ordinary object create takes argument
Onto the spinning quad.
list of names of internal slots and returns an object. It is used to
That's all I gotta do.
new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA
So something's been done
173. That must be defined as part.
because now it's black.
If additional internal
So something's being applied.
empty list is used
An empty image.
when called, let in
So all I have to do
additional
is figure out how to get
internal
the image onto the quad.
list and additional internal slots list. Let OB make basic object internal slots list. Set O
This freaking sucks.
1 3 ordinary create from constructor intrinsic default proto.
This couldn't be more frustrating.
The abstract operation
It's ridiculous.
constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get prototype from constructor intrinsic default proto. If internal slots list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create proto slots list 0 1 1 4 get prototype from constructor intrinsic default proto. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, used for. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The
Okay, I'm gonna figure it out. I gotta find some music. I'm gonna figure it out. Get this done.
prototype. If proto is not an object, then a letter in B. Get function realm, constructor, B set proto to realms intrinsic object named intrinsic default proto. Return proto. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object, and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174. ECMA International 2024. Note, if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. Internal slot. The abstract operation require internal slot takes arguments O, an ECMA script language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMA script function objects. ECMA script function objects encapsulate parameterized ECMA script code closed over a lexical environment and support the dynamic evaluation of the code. An ECMA script function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMA script function object may be either strict mode code 1 1 2 2 or non-strict code. An ECMA script function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to and, ECMA script function objects also have the internal slots listed in Table 30. Table 30, internal slots of ECMA script function objects. Internal slot, type, description, environment, an environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMA script code. A parse node. The root parse node of the source text that defines the function's body. Constructor kind. Base or derived. Whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function was created. This mode. Lexical. Strict. Or global. Capital D. Defines how this references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed to object. Copyright sign, ECMA International 2024. 75. Table 30, internal slots of ECMA script function objects. Continued, internal slot, type, description, strict, a boolean, true if this is a strict function, false if this is a non-strict function, home object, an object, if the function uses super, this is the object whose provides the object where super property lookups begin, source text, a sequence of Unicode code points, the source text that defines the function, fields, a list of class field definition records, if the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class, private methods, a list of private elements, if the function is a class, this is a list representing the non-static private methods and accessors of the class, class field initializer name, a string, a symbol, a private name, or empty, if the function is created as the initializer of the class field, the name to use for named evaluation of the field, empty otherwise, is class constructor, a boolean, indicates whether the function is a class constructor, if true, invoking the functions will immediately throw a type error exception, all ECMA script function objects have the internal method defined here. ECMA script functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMA script function object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let callee context be the running execution context. Let callee context be prepared for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If f is true, then a let error be a newly created type error object. B note, error is created in callee context with f's associated realm record. C remove callee context from the execution context stack and restore callee context as the running execution context. D return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore callee context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0 2 1 1 Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments f, an ECMA script function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let callee context be the running execution context. Let callee context be a new ECMA script code execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to f. Let local env be the new function environment. F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env. 0. Set the private environment of callee context to f. 1. If callee context is not already suspended, suspend callee context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note, any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0, 2, 1. 2 ordinary call bind this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments f, an ECMA script function object, callee context, an execution context, and this argument, an ECMA script language value, and returns unused. It performs the following steps when called. Let this mode be f. If this mode is lexical, return unused. Let callee realm be f. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then I let global env be callee realm 2. Assert. Global env is a global environment record. 3. Let this value be global env. Be else, I let this value be. To object, this argument 2. Note, to object produces wrapper objects using callee realm. Assert. Local env is a function environment record. Assert. The next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value, 0, return unused, 0, 2, 1, 3 runtime semantics, evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions: function body, function statement list, return, evaluate function body of function body with arguments function object and arguments list, concise body, expression body, return, evaluate concise body of concise body with arguments function object and arguments list, ECMA International 2024 177, generator body, function body, return, evaluate generator body of generator body with arguments function object and arguments list, async generator body, function body, return, evaluate async generator body of async generator body with arguments function object and arguments list, async function body, return, evaluate async function body of async function body with arguments function object and arguments list, async concise body, expression body, return, evaluate async concise body of async concise body with arguments function object and arguments list, initializer, assignment expression, assert, arguments list is empty, assert, function object is not empty. If is anonymous function definition, assignment expression, is true, then a let value be. Named evaluation of initializer with argument function object, else a let RHS be. Evaluation of assignment expression, be let value be. Get value, RHS, return completion record, return, value, empty, class static block body, class static block statement list, assert, arguments list is empty, return, evaluate class static block body of class static block body with argument function object, 0, 2, 1, for ordinary call evaluate body, F, arguments list. The abstract operation ordinary call evaluate body takes arguments F, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of F with arguments F and arguments list 1, 0, 2, 2, arguments list, new target. The internal method of an ECMA script function object F takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be F, if kind is base, then a let this argument be. Ordinary create from constructor, new target, %object prototype %4. Let callee context be prepare for ordinary call, F, new target. 178, ECMA International 2024. Note even though field initializers constitute a function boundary, calling, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call binds this. F. Callee context. This argument, BL, at initialize result be completion, initialize instance elements. This argument, F, see if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, ordinary call evaluate body, F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then A if result is an object, return result. B if kind is base, return this argument. C if result is not undefined, throw a type error exception. 1. Else A return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0, 2, 3 ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMA script function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let F be ordinary object create. Function prototype. Internal slots list. Set F to the definition specified in 1, 0, 2, 1. Set F to source text. Set F to parameter list. Set F to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set F to strict. If this mode is lexical this. Set F to lexical 0, else if strict is true. Set F to strict 1, else. Set F to global 2. Set F to false 3. Set F to env 4. Set F to private env 5. Set F to get active script or module 6. Set F to the current realm record 7. Set F to undefined 8. Set f to a new empty list. 9. Set f to a new empty list. 0. Set f to empty. 1. Let len be the expected argument counter parameter list. 2. Perform set function length. F. Len 3. Return f. ECMA International 2024 179. 1 0 2 4. Capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E F realm. The abstract operation capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm existent has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5 make constructor f. Writable prototype, prototype. The abstract operation make constructor takes argument f, any CMA script function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMA script function object, then a assert is constructor, f is false, b assert, f is an extensible object that does not have a prototype own property, c set f to the definition specified in 1 0, 2, 2, else a set f to the definition specified in 1 0, 3, 2, set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create, %object prototype %, b perform. Define property or throw, prototype, constructor, property descriptor, f, writable prototype, false, true, perform. Define property or throw, f, prototype, property descriptor, prototype, writable prototype, false, false, return unused. 80, ECMA International 2024, 1 0, 2, 6 make class constructor, f. The abstract operation make class constructor takes argument f, any CMA script function object, and returns unused. It performs the following steps when called. Assert, f is false, set f to true, return unused. 0, 2, 7 make method, f, home object. The abstract operation make method takes arguments f, any CMA script function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object, return unused. 0, 2, 8 define method property, home object, key, closure, enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object. If key is a private name, then a return private element. Method. Closure 3. Else, a let desk be the property descriptor. Closure. True. Enumerable. True. Be perform. Define property or throw. Home object. Key. Desk. C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9 set function name. F. Name, prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description, and else if name is a private name, then a set name to name. If f is an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f is an internal slot, then optionally set f to name. Perform. Define property or throw f. Name. Property descriptor. Name. False. Enumerable. False. True. Return unused. ECMA International 2024 181. The 10th of February 2010 set function length. F. Length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, 0 plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f. Length. Property descriptor. Length. False. Enumerable. False. true, return unused. 0, 2, 1, 1, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, func, arguments list. The abstract operation, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, takes arguments func, an ECMA script F, function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMA script function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do, if D is neither a variable declaration nor of the binding nor a binding identifier, then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then, a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then, a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then, if function names contains arguments or lexical names contains arguments, then, I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then, a note, only a single environment record is needed for the parameters. Since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval, let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. Let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env, deassert. The variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do, a let already declared be env has binding. Param name, b note, early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then, I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then, perform env initialize binding. Param name, undefined 22. If arguments object needed is true, then, if strict is true or simple parameter list is false, then, I let AOB create a mapped arguments object, arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env, see if strict is true, then, I perform env create a mutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. D else, I perform env create mutable binding, arguments, false. E perform env initialize binding, arguments. F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then, a perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else, a perform iterator binding initialization of formals with arguments iterator record and env 27. If his parameter parameter expressions is false. Then, a note, only a single environment record is needed for the parameters in top-level vars. Be let instantiated var names be a copy of the list parameter bindings. See for each element n of var names. Do, if instantiated var names does not contain n, then, append n to instantiated var names. Perform env create mutable binding. N, false. Perform env initialize binding. N, undefined. D let var env be env28. Else, a note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var env be new declarative n, the environment, env. C set the variable environment of callee context to var env. D let instantiated var names be a new empty list. E for each element n of var names. Do, if instantiated var names does not contain n, then, ECMA International 2024 183. 1. Append n to instantiated var names. Perform var env create mutable binding. N, false. If parameter bindings does not contain n, or if function names contains n, then, a let initial value be undefined 4. Else, a let initial value be env get binding value. N, false. Perform var env initialize binding. N, initial value. Note, a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note, an xb, 3, 2, 1 adds additional steps at this point. 0. If strict is false, then, a let lexi env be new declarative environment. Var env, b note, non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexi env be var env 2. Set the lexical environment of callee context to lexi env 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element b of lex declarations, do, a note, a lexically declared name cannot be the same as a function-generated declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of d. Do, if this constant declaration of d is true, then, perform lexi env create a mutable binding. Dn, true 2. Else, perform lexi env create mutable binding. Dn, false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize. Do, a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexi env and private env. C perform var env set mutable binding. Fn, fo, false. 7. Return unused. 0.3 built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2, 0, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1, 0, 3, 1. A built-in function object is a, internal method if and only if it is described as a constructor, or some algorithm in the specification explicitly sets its internal method. Such an internal method must conform to the definition in 1, 0, 3, 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b, 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMA script that predate ECMA script 2015. 84. Copyright sign, ECMA International 2024, 103, 1. This argument, arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f, this argument, arguments list, undefined 1, 0, 3, 2, arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in call or construct, f, uninitialized, arguments list, new target 1, 0, 3, 3 built-in call or construct, f, this argument, arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object, this argument, an ECMA script language value or uninitialized, arguments list, a list of ECMA script language values, a new target, a constructor undefined, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called: let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized. The this value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note, if if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or class, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object additional internal slots list contains the names of additional internal slots that must. Note when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024-185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let func be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null, 0, perform set function length, func, length, 1. If prefix is not present, then a perform set function name, func, name 12. Else, a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic C object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMA script function objects listed in table 30. Instead, they have the internal slots listed in table 31, in addition to and table 31, internal slots of bound function exotic objects. Internal slot type description bound target function a callable object the wrapped function object bound this an ECMA script language value the value that is always passed is this value when calling the wrapped function. Bound arguments a list of ECMA script language values a list of values whose elements are used as the first arguments to any call to the wrapped function. 186 ECMA International 2024 10411 This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let target be f, let bounds this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list, if same value, f, new target, is true. Set new target to target, return. Construct, target, args, new target, 0, 4, 1, 3 Bound function create. Target function, bound this, bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMA script language value, and bound args, a list of ECMA script language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of, and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1, 0, 4, 1, 1. If this constructor, target function, is true, then a set obj as described in 1, 0, 4, 1, 2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every known property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to ECMA International 2024-187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desc. Else if p is an array index, then a let length desc be ordinary get own property a length b assert is data descriptor length desc is true c assert length desc is false d let length be length desc e assert length is a non-negative integral number f let index b 32 p g if index length and length desc is false return false h let succeeded b ordinary define known property a p desc I have succeeded is false return false j if index length then I set length desc to index plus 1 2 set succeeded to ordinary define known property a length desc 3 assert succeeded is true k return true return ordinary define known property a p desc 0 4 2 to array create length proto the abstract operation array create takes argument length a non-negative integer and optional argument proton object and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform ordinary define known property a length property descriptor length true false false return a 0 4 2 3 array species create original array length. The abstract operation array species create takes arguments original array an object and length a non-negative integer and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If this array is false, return array create length let c be get original array constructor. If this constructor c is true, then 88 ECMA International 2024. Let this realm be the current realm record. B let realm be get function realm c. See if this realm and realm are not the same realm record. Then I have same value c realm is true. Set c to undefined. If c is an object, then assess c to get c add at species. B if c is null, set c to undefined. If c is undefined, return array create length. If this constructor c is false, throw a type error exception. Return construct c length 0 4 2 4 array set length a desc. The abstract operation array set length takes arguments a an array and desc a property descriptor and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desc does not have a field, then a return ordinary define known property a length desc. Let new len desc be a copy of desc. Let new len be 32 desc. Let number len be the number desc. If same value 0, new len number len is false. Throw a range error exception. Set new len desc to new len. Let old len desc be ordinary get own property a length assert is data descriptor old len desc is true assert old len desc is false 0. Let old len be old len desc 1. If new len old len, then a return ordinary define known property a length new len desc 2. If old len desc is false, return false 3. If new len desc does not have a field or new len desc is true, then a let new writable be true 4. Else a note setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desc to true 5. Let succeeded be ordinary define known property a length new len desc 6. If succeeded is false, return false 7. For each own property key p of a such that p is an array index and 32 p new len in descending numeric index order do a let delete succeeded b a p b if delete succeeded is false, then I set new len desc to 32 p plus 1 2. If new writable is false, set new len desc to false 3. Perform ordinary define known property a length new len desc 5. Return false 8. If new writable is false, then assert succeeded to ordinary define known property a length property descriptor false b assert succeeded is true 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desc is an object, then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates the string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have internal slot 1, 0, 4, 3, 1, p. The internal method of a string exotic object s takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary getOwn property, s, p. If desc is not undefined, return desc. Return string getOwn property, s, p, 0, 4, 3, 2, p, desc. The RTY internal method of a string exotic object s takes arguments p, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desc be string getOwn property, s, p. If string desc is not undefined, then a let extensible be s. P return is compatible property descriptor, extensible, desc, string desc, return. Ordinary define own property, s, p, desc, 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str. For each integer I such that 0 len, in ascending order, do a append. To string, I, to keys. For each own property key p of O such that p is an array index and to an integer or infinity, p, len, in ascending numeric index order, do a append p to keys. For each own property key p of O such that p is a string and p is not an array index, in ascending chronological order of property creation, do a append p to keys. 90. ECMA International 2024. 8. For each own property key p of O such that p is a symbol, in ascending chronological order of property creation, do a append p to keys. 9. Return keys 0, 4, 3, 4 string create, value, prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let s be make basic object. Set s to prototype. Set s to value. Set s is specified in 1, 0, 4, 3, 1. Set s is specified in 1, 0, 4, 3, 2. Set s is specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw s, length. Property descriptor, length. False, enumerable, false, false. Return s, 0, 4, 3, 5 string getOwn property, s, p. The abstract operation string getOwn property takes arguments s, an object that has an internal slot, and p, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If p is not a string, return undefined. Let index be canonical numeric index string, p. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s, assert. Str is a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of strf. Rom r, int x, dra, index plus 1, 1. Return the property descriptor, result str, false, true, false, 0, 4. 4 arguments exotic objects. Most ECMA script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMA script function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed in create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 20, 1, 3, 6 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the argument's object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the argument's object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMA script code. An ECMA script implementation does not need to actually create or use such objects to implement the specified semantics. Note: for ordinary arguments, objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMA script implementations. Note 5. ECMA script implementations F arguments exotic objects have historically contained an accessor property named caller. Prior to ECMA script 2017, this specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMA script 2017 dropped the requirement for a throwing caller accessor. 0.4.4.1 P. The internal method of an argument's exotic object args takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary get own property, args, P. If desc is undefined, return undefined. Let map be args, let is mapped be. Has own property, map, P. If is mapped is true, then A set desc 2. Get, map, P6. Return desc 0.4.4.2 P. Desc. The internal method of an argument's exotic object args takes arguments P, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, P. Let new arg desc be desc. If is mapped is true and is data descriptor, desc, is true. Then, if desc does not have a field, desc has a field, and desc is false, then I set new arg desc to a copy of desc 2. Set new arg desc 2. Get, map, P. Let allowed be. Ordinary define own property, args, P. New arg desc 92. ECMA International 2024. 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desc, is true, then I perform map, P. Be else. If desc has a field, then assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set, map, P. Desc, false 2. If desc has a field and desc is false, then perform map, P8. Return true 0.4.4.3. The let map be args, let is mapped be. Has own property, map, P. If is mapped is false, then a return. Ordinary get, args, P. Receiver 4. Else, a assert. Map contains a formal parameter mapping for P. P return, get, map, P. 0.4.4.4. The or a throw completion. It performs the following steps when called. If same value, args, receiver, is false, then a let is mapped be false. Else, a let map be args, be let is mapped be. Has own property, map, P. If is mapped is true, then a assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable, be perform set, map, P, V, false, return. Ordinary set, args, P, V, receiver 0.4.4.5 P. The internal method of an argument's exotic object args takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, P. Let result be. Ordinary delete, args, P. If result is true and is mapped is true, then a perform map, P5. Return result. ECMA International 2024 193 104.4.6 Create and mapped arguments object, arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMA script, language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create, % object prototype %. Set obj to undefined, perform. Define property or throw, obj, length, property descriptor, len, true, enumerable, false, true, let index be 0, repeat, while int x, len, a let val be arguments list, index, be perform. Create data property or throw, obj, to string, int x, val, c set index plus 1, perform. Define property or throw, obj, add at iterator, property descriptor, % array prototype values %, true, false, true, perform. Define property or throw, obj, callee, property descriptor, % throw type error %, false, false, return obj, 0.4.4.7 Create mapped arguments object, func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMA script language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0, 4, 4, 1. Set obj is specified in 1 0, 4, 4, 2. Set obj eat is specified in 1 0, 4, 4, 5. Set obj to percent object prototype percent 0. Let map be ordinary object create null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat. While int x, len, let val be arguments list. Index, be perform. Create data property or throw, obj. To string, int x, val, c set index to index plus 1, 6. Perform. Define property or throw, obj, length, property descriptor, len, true, false, true, 7. Let map names be a new empty list, 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names. 2. If int x, len, then let g be make arg getter, name, env. Let p be make arg setter, name, env. Perform map. To string, int x, property descriptor, get, g, false, true. Set index to index 1, 20. Perform. Define property or throw, obj, add at iterator, property descriptor, percent array prototype values percent, true, false, true, 1. Perform. Define property or throw, obj, callie, property descriptor, func, true, false, true, 2. Return obj, 0, 4, 4, 7, 1 make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0, note, getter is never directly accessible to ECMA script code. Return getter, 0, 4, 4, 7, to make arg setter, name, env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, setClosure, 1, note, setter is never directly accessible to ECMA script code. Return setter, 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer int x property keys. Typed arrays have the same internal slots as ordinary objects and additionally, length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1, p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string, p, b if numeric index is not undefined, then I let value be typed array get element, numeric index, 2. If value is undefined, return undefined, 3. Return the property descriptor, value, true, 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 return ordinary get own property, O, P, ECMA International 2024 195, 1 0, 4, 5, 2, P. The internal method of a typed array, O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string, P, B if numeric index is not undefined, return is valid integer index, O, numeric index, return. Ordinary has property, O, P, 0, 4, 5, 3, P, desk. The internal method of a typed array, O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string, P, B if numeric index is not undefined, then I is valid integer index, O, numeric index is false, return false, 2. If desk has a field and desk is false, return false, 3. If desk hasn't field and desk is false, return false, 5. If is accessor descriptor, desk, is true, return false, v. If desk has a field and desk is false, return false, v. If desk has a field, perform. Typed array set element, numeric int x, desk, 7. Return true, return. Ordinary define known property, O, P, desk, 0, 4, 5, 4. The, if P is a string, then a let numeric index be canonical numeric index string, P, B if numeric index is not undefined, then I return typed array get element, numeric index 2. Return. Ordinary get, O, P, receiver, 0, 4, 5, 5. The, If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined, then I have same value. O, receiver, is true, then perform. Typed array set element, O, numeric int x, V, return true, 2. If is valid integer index, O, numeric int x, is false, return true, return. Ordinary set, O, P, V, receiver, 96, ECMA International 2024, 104, 5, 6, P, the internal method of a typed array. O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined, then I is valid integer index. O, numeric int x, is false, return true, else return false 2. Return. Ordinary delete. O, P, 0, 4, 5, 7. The internal method of a typed array. O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy ST. Let keys be a new empty list. If it's typed array out of bounds, tar record is false, then a let length be typed array length. Tar record be for each integer I such that 0I, length, in ascending order, do I append to string I to keys. For each own property key P of O such that P is a string and P is not an integer index, in ascending chronological order of property creation, do I append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do I append P to key 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, B, J, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexy st or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Capital L at buffer b obj. If is detached buffer is true, then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order, return the typed array with buffer witness record. Obj, byte length, 0, 4, 5, 1, 0. Typed array create, prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1, 0, 4, 5, 1. Set A is specified in 1, 0, 4, 5, 2. Set A is specified in 1, 0, 4, 5, 3. Set A is specified in 1, 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A, 0, 4, 5, 1, 1. Typed array byte length, tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness, record, and returns a non-negative integer. It performs the following steps when called. If it's typed array out of bounds, tar record is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size 0, 4, 5, 1, 2. Typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array out of bounds, tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert byte length is not detached. Return floor byte length byte offset element size 0, 4, 5, 1, 3 is typed array out of bounds, tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else a let element size be typed array element size. O be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0. 4. 5. 1 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments O, a typed array, and int x, a number, and returns a boolean. It performs the following steps when called. If is detached buffer O is true, return false. If is integral number int x is false, return false. If index is -0, return false. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O. Unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If it's typed array out of bounds, tar record is true, return false. Let length be typed array length, tar record. If R int x 0 or R int x length, return false, return true. 0 4 5 1 5 typed array get element O index. The abstract operation typed array get element takes arguments O, a typed array, and an x, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index O int x is false, return undefined. Let offset be O. Let element size be typed array element size O. Let byte index in buffer be R int x element size plus offset. Let element type be typed array element type O. Return get value from buffer O. Byte index in buffer element type true. Unordered. 0 4 5 1 6 typed array set element O int x value. The abstract operation typed array set element takes arguments O, a typed array, int x, a number, and value, any CMA script language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be. To big int, value. Otherwise, let num value be. To number, value. If is valid integer index O int x is true, then a let offset be O. Be let element size be typed array element size O. C let byte index in buffer be R int x element size plus offset. D let element type be typed array element type O. E perform set value in buffer O. Byte index in buffer element type num value true. Unordered. Return unused. Copyright sign ECMA International 2024 199. 186, ECMA International 2024, 10411. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let target be f, let bounds this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target, return. Construct, target, args, new target, 0, 4, 1, 3 bound function create, target function, bound this, bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMA script language value, and bound args, a list of ECMA script language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of, and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1, 0, 4, 1, 1. If this constructor, target function, is true, then a set obj as described in 1, 0, 4, 1, 2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4, to array exotic objects. An array is an exotic object that gives special treatment to array index property keys, C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, W. Whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index, and whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return. Array set length, a, desc. Else if p is an array index, then a let length desc be ordinary get own property, a, length, b assert, is data descriptor, length desc, is true, c assert, length desc is false, d let length be length desc, e assert, length is a non-negative integral number, f let index b, 32, p, g if index length and length desc is false, return false, h let succeeded b. Ordinary define known property, a, p, desc, I have succeeded is false, return false, j if index length, then I set length desc, index plus 1, 2. Set succeeded to, ordinary define known property, a, length desc, 3. Assert, succeeded is true, k return true, return. Ordinary define known property, a, p, desc, 0, 4, 2, to array create, length, proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proton object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length, 232 1, throw a range error exception. If proto is not present, set proto to percent array prototype percent. Let a be make basic object. Set a to proto. Set a is specified in 1, 0, 4, 2, 1. Perform. Ordinary define known property, a, length, property descriptor, length, true, false, false. Return a, 0, 4, 2, 3 array species create, original array, length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be, is array, original array. If is array is false, return. Array create, length, let c be, get, original array, constructor. If this constructor, C, is true, then 88. ECMA International 2024. Let this realm be the current realm record. B let realm be. Get function realm, C. See if this realm and realm are not the same realm record. Then, I have same value, C. Realm is true. Set C to undefined. If C is an object, then I set C to get C, add at species. B, if C is null, set C to undefined. If C is undefined, return. Array create, length. If this constructor, C, is false, throw a type error exception. Return. Construct, C, length, 0, 4, 2, 4 array set length, A, desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return. Ordinary define known property, A, length, desk. Let new len desk be a copy of desk. Let new len be 232, desk. Let number len be the number, desk. If same value 0, new len, number len, is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property, A, length, assert, is data descriptor. Old len desk is true, assert. Old len desk is false, 0. Let old len be old len desk, 1. If new len old len, then a return. Ordinary define known property, A, length, new len desk, 2. If old len desk is false, return false, 3. If new len desk does not have a field or new len desk is true, then a let new writable be true, 4. Else, a note, setting the attribute to false is deferred in case any elements cannot be deleted. B, let new writable be false. C, set new len desk to true, 5. Let succeeded be ordinary define known property, A, length, new len desk, 6. If succeeded is false, return false, 7. For each own property key P of a such that P is an array index and 32, P, new len, in descending numeric index order, do a let delete succeeded B, A, P, B. If delete succeeded is false, then I set new len desk to 32, P plus 1, 2. If new writable is false, set new len desk to false, 3. Perform ordinary define known property, A, length, new len desk, 5. Return false, 8. If new writable is false, then assert succeeded 2. Ordinary define known property, A, length, property descriptor, false. B, assert succeeded is true, 9. Return true, not. E, if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have internal slot 1, 0, 4, 3, 1, P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, S, P. If desk is not undefined, return desk. Return string get own property, S, P, 0, 4, 3, 2, P, desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property, S, P. If string desk is not undefined, then a let extensible be S. P return is compatible property descriptor, extensible, desk, string desk, return. Ordinary define known property, S, P, desk, 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str. For each integer I such that 0 I, len, in ascending order, do a append to string I to keys. For each own property key P of O such that P is an array index and to an integer or infinity, P, len, in ascending numeric index order, do a append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024. 8. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do a append P to keys. 9. Return keys 0, 4, 3, 4 string create, value, prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length, property descriptor, length, false, enumerable, false, false. Return S, 0, 4, 3, 5 string getOwn property, S, P. The abstract operation string getOwn property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If its integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s, assert. Str is a string. Let len be the length of str. If r, int x, 0, or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r. Index plus 1, 1. Return the property descriptor. Result str, false, true, false, 0, 4. 4 arguments exotic objects. Most ECMA script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMA script function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed and create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 20, 1, 3, 6 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024-191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMA script code. An ECMA script implementation does not need to actually create or use such objects to implement the specified semantics. Note 4. Ordinary arguments objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMA script implementations. Note 5. ECMA script implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMA script 2017, this specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMA script 2017 dropped the requirement for a throwing caller accessor. 0, 4, 4, 1, P. The internal method of an arguments exotic object args takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary getOwn property, args, P. If desk is undefined, return undefined. Let map be args. Let is mapped be has own property, map, P. If is mapped is true, then a set desk to get, map, P6. Return desk 0, 4, 4, 2, P, desk. The internal method of an arguments exotic object args takes argum, ends P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args. Let is mapped be has own property, map, P. Let new arg desk be desk. If is mapped is true and is data descriptor, desk is true. Then, if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to get, map, P. Let allowed be ordinary define own property, args, P. New arg desk 92. ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desk, is true, then I perform map, P, be else. If desk has a field, then assert. The following set will succeed, since formal parameters mapped by arguments objects are always writable. Perform set, map, P, desk, false 2. If desk has a field and desk is false, then perform map, P8. Return true 0, 4, 4, 3. The let map be args. Let is mapped be has own property, map, P. If is mapped is false, then a return. Ordinary get, args, P, receiver 4, else, assert. Map contains a formal parameter mapping for P, be return, get, map, P, 0, 4, 4, 4. The, if same value, args, receiver, is false, then a let is mapped be false, else, a let map be args, be let is mapped be has own property, map, P. If is mapped is true, then a assert. The following set will succeed, since formal parameters mapped by arguments objects are always writable. Be perform, set, map, P, V, false, return. Ordinary set, args, P, V, receiver 0, 4, 4, 5, P. P, the internal method of an argument's exotic object args takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args, let is mapped B. Has own property, map, P, let result B. Ordinary delete, args, P, if result is true and is mapped is true, then, perform map, P5. Return result, ECMA International 2024 193, 104. 4. 6. Create and mapped arguments object, arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMA script, language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create, %object prototype %, set obj to undefined, perform. Define property or throw, obj, length, property descriptor, len, true, enumerable, false, true, let index be 0, repeat, while index, len.
So basically,
Index.
chatbot is garbage.
Throw. OBJ. To strip.
It is so annoying.
Index +1.
It literally only gives you what you give it.
Iterator. Property descriptor. Array prototype values %.
It's like, here's a step-by-step.
Define property.
Well, it says that. I'm not saying whatever it says. Step-by-step, whatever.
False. Return OBJ.
And down here it says VK sampler.
Create mapped arguments object. Func. Formal.
That's the one thing I don't have.
The abstract operation create.
And it's like,
Arguments func. An object. Formals. A parse node.
you need this stuff, and it's like,
Language values.
everything's good. It's perfect after that, blah, blah, blah.
Exotic object. It performs the following.
And they get down here,
Formals does not contain a rest parameter.
and it's like,
Or any initialize.
update the descriptor, set to bind the texture.
Let OBJ.
Do this once after creating the image view sampler.
OBJ is specified in 1 0 4 4 2. Set OBJ. Set OBJ. Set
So
0 4.
that's the only one in quotes.
And object prototype %0.
It's like blah 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 blah, and it's like subtext.
Let
P.S. I know this is missing.
parameters be the number.
Just make sure you do this. Don't ask me,
Index be 0 5.
and then you're good.
Let val be arguments list. Index be perform. Create data property or throw. OBJ. To string. Index. Val.
And it's like just do that, and you're good. It'll work.
Form. Define property or throw. OBJ. Length. Property descriptor. Len. True. False. True. 7. Let map names be a new empty list. 8. Set index to number of parameters 1. 9. Repeat. While index 0. 94. ECMA International 2024. A, B, C. Let name be parameter names. Index.
So I just want to get this working.
Name. Then.
So I don't care about the swap chain. If this works, it works.
Getter. Name. env. Let pb make arg setter.
And chatbot's just like,
rm map. To string. Index.
just do this and you're good.
E. False.
Leaving out, like,
Perform. Define property or throw.
the whole thing that I don't have.
Property descriptor. Array prototype values %. True. False. True. 1. Perform.
It can't even count up
Throw. OBJ.
the bit position
True.
of a fucking binary number.
OBJ 0, 4, 4, 7, 1 make arg getter. Name. env. The abstract operation make arg getter takes up
So no wonder it can't make a goddamn shader.
and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getterClosure be a new abstract closure with no parameters that captures name and env and performs the
Was it the conversation?
let binding value. Name. False. Let getter be create built-in function. GetterClosure 0. Note. Getter is never directly accessible to ECMA script code. Return getter 0, 4, 4, 7 to make arg setter. Name. env. The abstract operation.
How does this happen?
String and env. An environment record and returns a function object.
It's wrong both ways.
Value bound for name and env. It performs the
How can it not do something as simple as shift a bit left?
env and performs the following.
Like seriously,
The env set mutable binding. Name.
people find this impressive? Are you serious? People find chatbot impressive.
0, 4, 5 type.
I can't get anything out of chatbot. Nothing useful.
Integer index.
Ever. It never helps.
Use ordinary objects and additionally length.
Oh, and it changed its value.
Internal methods use the depth.
So chatbot even changed the value at some point, and it's still wrong. It's still not even at the right freaking bit.
1.
Because it was here,
Method of a typed array. OT.
and then it shifted left 2 more.
Property descriptor or undefined. It performs the following steps when called. Be canonical numeric index string p b if numeric index is not undefined. Then I let value be typed array get element. Oh, numeric index 2. If value is
How can chatbot? I really don't understand why people are so impressed. a chatbot.
2024.
It can't do the most basic things.
2.
It's not even funny how bad chatbot is. It can't even bit shift.
Normal completion.
Like, are you fucking kidding me?
Steps when
And I'm here asking it questions.
index be canonical.
I guess I'm a joke.
P. Be if numeric. Then is valid integer index.
I'm about to stream go on for 10 more minutes because it's the end of the stream. But I'll start another stream because I gotta get this done.
P. Desk.
So I'm gonna let it run on for 10 more minutes because it doesn't always send the whole stream
Returns I.
because it's 2025
Or throw complete.
and software doesn't work.
Called. If P is a
Software never worked,
numeric index.
but it really doesn't work. At least my software.
Index is not
Chatbot doesn't work. The streaming software doesn't work.
numeric.
The Mac is full of bugs.
False. 2.
So I don't know. I'm about to stream run on for 10 more minutes. I need some water
Return false.
and I'll start another stream. So, BRB, next stream.
V. If desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element. Oh. Numeric int x. Desk 7. Return true. Return. Ordinary define known property. O. P. Desk 0. 4. 5. 4. The. If P is a string, then a let numeric index be canonical numeric index string. P. Be if numeric index is not undefined. Then I return typed array get element. Oh. Numeric index 2. Return. Ordinary get. O. P. Receiver 0. 4. 5. 5. The. If P is a string, then a let numeric index be canonical numeric index string. P. Be if numeric index is not undefined. Then I have same value. O. Receiver is true. Then perform. Typed array set element. Oh. Numeric int x. V. Return true. 2. If is valid integer index. O. Numeric int x is false. Return true. Return. Ordinary set. O. P. V. Receiver 96. ECMA International 2024 104 5 6. P. The internal method of a typed array. O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a